Hi everyone. So in this video we will discuss all the solutions of the mock test that was conducted today, Booster X. So if you have not already, still the test is open, so you can still attempt the test Booster X and just check your progress. So I will just tell you briefly regarding the difficulty level of the paper, and then of course we'll start with the solutions. So as of now, because I'm recording this video before the attempts has been completed, so as of now I feel the paper level is mostly on the easier side. Some few students may feel it is on the moderate side, so even if you feel it is on the moderate side, it will be more from moderate to easy, not moderate to tough, it will be moderate to easy. So it will be somewhere between easy and moderate, right? Mostly I will feel this was a easy paper. Okay, so we will obviously able will be obviously be able to comment more on the level uh, in the live session, right? So uh, in the evening we'll come live at 6:30 p.m. So there we will do all the analysis. It will be the same as KillerX, like whatever we have done the analysis for KillerX will be the same here. Will say what is the topper marks. Will not obviously say the topper names, but we will say you what are the marks of the toppers, what was the difficulty level, where you stand, and what will be your actual performance in the examination, depending on the marks here, right? All those things we will discuss. So make sure you join us at 6:30 a.m. Of course, we will guide you a bit as well regarding your next 20 days or 15 days preparation, right? So yeah, that's it. So let's begin with the video solutions.
Yeah, so let's see the solution of this one. I will read the line. I know that, sir, I don't know the meaning of this particular thing. What is this written? I don't know the meaning. Exacerbate. Okay. But I can read the statement. I would get to know that, yes, I can get the correct answer. During the design of high-speed digital circuits, engineer must carefully manage the signal integrity issue. Improper termination can reflections on the transmission line. What do you think? What it would do? Improper termination would what it would do? It would increase, right? It would increase the reflection on transmission line, leading to the timing error and the degraded system performance. Like, sir, even if I don't know, sir, what will improper termination would do, then also you can understand. No, from the sense of the meaning that you need to take care of something. You need to take care of something, otherwise something would happen. Right? Are you able to understand this point? You need to take care of something, otherwise something would happen. You need to take care of health, otherwise you will not be able to study. So there will be a sense of negation. And what is the negation? Reflection coefficient will be increased. So intensify. That's it. I don't even know the meaning of this alleviate as well. Post one I know suppress, I know suppress. Post one will not be there, but I can understand that surely it will be intensify. The reflection coefficient will be intensified. That's why the answer would be 2. Okay. Let's go to the next. Yeah, so here the decreasing order of intensity is given. Okay, terrified, like very much terrified or very much afraid, then uneasy. I am feeling uneasy, right? You know the meaning of everything. Hot, warm, then what should come? You don't know the meaning of this tepid, right? You know the meaning of mild. Mild means lesser warm only, so this would not come. You might have heard the word scorching, like there is a scorching heat in Rajasthan. At 12 p.m. in the noon, there will be scorching heat. So that you might have heard, right? Scorching. So that means very hot, very much hot, actually. So scorching would come. Okay, and lukewarm means lesser than warm. Here lukewarm would come. Like very much less warm. Lukewarm. Okay, so this would also not come. Scorching would be the answer. Yeah, let's see this one, very straightforward. How many marbles Z is having? Let's just say Z is having P number of marbles. So how much Y is having? Y is having P plus 10. So how much X is having? X is having 1/3 of the total number of marbles with the others. So others are having 2P plus 10. So he is having 2P plus 10 divided by 3. So this much marble X is having. You know that total number of marbles total number of marbles are 120. How many marbles Z is having, that you need to find out. So P plus 10 plus 2P plus 10 divided by 3, that is equals to 120. Now it depends on your calculation. So this is 2P. So this would become 6P plus 30 plus 2P plus 10, that is equals to 360. 360 minus 40, 320. 320, 8P equals to 320, 40. Okay, so that's the answer. Yeah, so how do you solve these kind of problems? Everyone has some different technique. If you are having some different technique, then don't change it for me. Okay, if you have studied from me, then solve with my technique only. So how many people are there? There are 6 men who are working at their own efficiency for 10 days. 6 men having efficiency of M working for 10 days plus 8 women having efficiency of W working for 10 days will get your work done. Work is X. This is your work. So to get your work done, you need 6 men having efficiency of M working for 10 days. 8 women having efficiency of W working for 10 days will get your work done. Similarly, another thing is also given that 26 men having a efficiency of M. Efficiency of man. Efficiency of man I am saying. What is that? Efficiency of man is M. Efficiency of one man is efficiency of a man. That is M. Efficiency of a woman I am calling as W. Okay, so 6m into 10 plus AW into 10 equals to X. Now 26 men with the efficiency of M are working for 2 days and 48 women with the efficiency of W is also working for 2 days. They will get their work done. Now we can compare now from here we will get the relation between the efficiency of man and efficiency of woman. What I can do is that 60m plus 80W 52 M plus 96W. So what we are getting 8M equals to 16W. So it is given that one man is twice sufficient of a woman. This is just given in the problem. I am not saying it. Okay. This is just given in the problem. So please don't be offended. Even a woman can be 3 times sufficient of man, or even a man can also be 3 times sufficient of woman. But this question is saying that man is twice sufficient of a woman. Okay. So this is what this question is saying. So now you need to do the X task only, but how much days it would take? So you are having 15 men and 20 women. This is the scenario you are having. Both will work for X days, right? Now just let me know one thing. 15 men, 20 women. Is it equivalent to 25 men? Because 20 women will be equivalent to 10 men. As per the given question, not according to me. As per the given question, 20 women would be equals to 10 men, because 2 women would make 1 man. 20 women would make 10 men. So this is equals to 25 men. So it's like 25 men working to do the task. Right? So how many days they would take? So if I come here in this scenario, so just let me know in this particular scenario, how many men were there? 26 men were there. And how many women were there? 48 women were there. What does that mean? 24 men? Say yes or no? 48 women means 24 men. Like, read this line now. 26 men and 48 women can complete the task in 2 days. What does that mean? 48 women means 24 men. So 24 men plus 26 men, that means 50 men. So 50 men are doing the work in 2 days. So how much time one man would do? How much time one man would take? 100 days. 50 men are taking 20 days, so one man would take 2 into 50, 100 days. So how much time 25 men would take? So 25 men would take 100 by 25. 4 days. That's it. So some people apply some formula and everything, but I don't believe in formula in aptitude. So this is how I solve it. Okay. Just people, their efficiency, multiply with number of days will be your work done. That's it. And then simple thing is there. Okay. Let's go to the. Yeah, this is very tough to solve. When I saw this question for the first time, actually this question is framed by Anish sir. Okay. He framed it. But when I saw it for the first time, I was not able to solve it. What I thought, first let me tell the answer. So answer is, this is 13 square minus 1, and this is your 11 square minus 1. And how you can get 11? You can get 11, 5 plus 1 plus 2 plus 3. How you can get 13? 6 plus 2 plus 3 plus 2. That is 13. So here what you will do? 5 plus 3, 8, 12, 14. 14 square. What is 14 square? 196. So 196 minus 1, that would be 195. This is the answer. But would it click to you? Is it that easy? No. Right? It is not very easy. So it might happen that sometimes these kind of questions are not clicking, then just simply drop it. If I had been a student, I would have spent 1 or 2 minutes and then I would have dropped it. It would be a heavy heart that I am not able to solve an aptitude problem, but still drop it. Okay, because it is not very straightforward that it would click to you. 13 square, 11 square, 14 square. Okay. What I thought was like, how I proceed. just as I saw 120 and I saw 5 as well, then what would click to me? 24 5s are 120. This is something that would click to me. 24 can be written as 8 into 3. So 2 to the power 3 into 3 into 5. So this was clicking to me. So what I thought is that 2 to the power 3 into 3 multiply with 5. So similarly 3 to the power 2 into 2 multiply with 6 and then multiply with 1 as well. So I tried different combination, but I was not getting answers. Okay, because that's not the approach. Okay, so I tried everything, but I was not getting the answer. In the examination, I would have simply dropped it. This is what I would have proceeded. Okay, in the examination, I would have surely dropped it. But it is very tough to get these kind of questions correct in the examination. Let's go to the next one. Yeah, this is a very standard PNC problem. Very standard. These kind of questions have been asked a lot of times in the GATE examination, and like these are very standard as well. If you have studied PNC, then surely it would be there in your class notes as well. Number. So how we will be starting in the dictionary? First we will be start like what is the order? B is the smallest, then A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X. In that manner, 6 numbers. So first we will be starting with B. How many spots would be there? 5 more spots would be there. Then next we will be starting with E. The next we will be starting with N, M, and then we will be starting with N. So all these spots, what that would be equivalent to 5 factorial into 3. So all these spots would be filled, then N would come up. Now, just as N comes up, what will be the next word? Sorry, not word. What will be the next letter? That would be B. N, B. Then rest of the letter would come. That means 4 letter would come. Now after B, whose turn it would be? After B, who would come? E would come. Then again, 4 space would be there. Now after E, who will be having the term? M. So in that manner, first B, then E, then M, and then R. So M will have the term, and then R will have the term. Right? These 4 guys will be having their terms. So 4 factorial, 4 factorial. So this was the first scenario, 5 factorial into 3. Now the second scenario is 4 factorial into 4. Because after this, what would come up? After this, U would come up. So after U, then what would come up? B would come up. N, U, B. So after that, how much space is there? 3 space is there. So 3 factorial. After B, who would come up? E would come up. N, U, E. How much space is there? 3 factorial. After that, M would come up. Okay. After that, B would come up. After that, E would only come up. And after that, who would come up? N would come up. I'm sorry, N is already there. So who would come up? R would come up. Yeah. So that's the next one. Look, if you don't know what I am doing here, that means you need to study this concept. I cannot give the whole concept in this particular solution video, no? So you need to study this concept, that how to get the rank of a particular number in the dictionary. So answer is 5 factorial into 3 plus 4 factorial into 4 plus 3 factorial into 2 plus 1. So let's do this calculation. 120 into 3, 360 plus 64, not 64, 24 into 4, what that would be? 24 into 4, 48, 96, 12 plus 1, 9, 6 and 4. 469 is the answer. Okay, well and good. Let's go to the next. Yeah, so this is also a very standard type of pattern. These kind of questions were there in our elementary classes as well, right? So what we need to do, we need to cover a distance of 21.5 meter, and what monkey is doing, we need to cover a distance of 21.5 meter. What monkey is doing, he will go for 2 meter, he will go for 2 meter and then fall back for 0.5 meter. What does that mean? In 2 minutes, he is covering 1.5 meter. So 21.5 meter, how much time he would take? Will I simply divide it? No. Like, will I do this particular thing? 21.5 divided by 1.5 into 2. That would be wrong. Why is that so? So let's reach as near as we can. Let's say that let's do 12 times of this. That means in 24 minutes, how much distance he would cover? 12 times of this we are doing. Here we have done that 12 times of this. So here also we will do that 12 times of this. So how much distance we are getting? 12, 6, 18. 18 meter he would cover. After that, what he will do? Make a jump of 2. That means he will go to 21. Sorry, 20 meter. Then fall back. He will come to 19.5 meter. That means this much process would have taken him 2 minutes. After that, what he would do? 2 minutes. After that, what he would do? He would again make a jump of 2.1 meter. Sorry, he would again take a jump of 2 meter. That means he will reach at 21.5 meter. Right? Yes. So how much time this would take him? 1 minute. So for 24 minutes plus 3 more minutes it is taking. That means 27 minutes it would taking. That's it. This is the answer. Okay. Let's go to the next. Yeah, that's a good question. I would say time taking, not good. It would be taking some time. So scenario is, okay, I don't have any other page, so I need to add a page. So angle of depression, you would know. Angle of depression is social media actually, but here it is something else. Angle of depression is 60 degree. So this angle is 60 degree. This height, let's just say this is h. It needs to cover a distance of let's just say x. So starting from here till the point that angle of depression is becoming 30 degree, till that particular point he has taken some particular time. How much time he has taken to cover this much of distance? Let's just say this distance is y. So to cover the distance of y, he has taken 10 minutes. Right? So what we can do is that we can see that tan 60 equals to x by h, and tan 30 is equals to y minus x by h. Right? What we need to find? We need to find the distance, x distance we need to find. In terms of y, if I find it, my job would be done, because I know that y, to cover the distance of y I need 10 minutes. So to cover the distance of 2y, how much time I would take? 20 minutes. Right? To cover the distance of 1.5y, how much time I would take? 15 minutes. Right? So I need to find out x in terms of y. That's it. This is my target now. X in terms of y. That's my target. So from here I can sense that x is coming out to be under root 3h, and y minus x is coming out to be h by under root 3. So what will be h? H will be x by under root 3. Right? What will be h? H will be x by under root 3. From here h will be x by under root 3. So this would become x by 3. So y would become 2x by 3. So what x would become? X in terms of y, that would be 1.5y. That's it. Job done now. If for covering the distance of y you are taking 10 minutes, so covering the distance of 3y to y, how much time you would take? 15 minutes. That's it. So you read the statement carefully. The boat will reach the shore from the point where angle of depression is 60 degree in minutes. So from this particular scenario to here, how much time it would take? So 10 minutes here and 5 minutes here. So answer would be 15 minutes. Let's go to the next one. Again, very straightforward. Who is consuming the most of the energy? Electrical. Okay. Electrical or EC. Electrical guys would consume most of the energy. So electrical department shows a constant increase in the consumption over 3 years. Yes. It is not consistent. Okay. It is constant. Like here, if it was 140, would you click on this answer? In place of 135, if it was 140, would you click on this particular option? No. Constant, not consistent. Consistent means, yeah, there will be increase. Like Virat, today he is scoring 50 runs, then he is scoring 60 runs, then he is scoring 70 runs, some day he is scoring 200 runs, some day he is scoring 45 runs. So we will say that he is consistent. Or let's just say here he is scoring 210 runs. So we will say that he is consistently improving. Right? But if he is scoring 50, 60, 70, 80, 90, 100, then we will say that increase is constant. Okay, so just take care of this thing. This could have been a very good question if it was 140 here. If it is 135 only, that means constant increase is there. 15, 15. And you guys would be thinking that, sir, MSQ, You see the pattern of gate question paper, nowhere it is written that in aptitude there could not be MSQ. Although in the previous year always MCQ has come in aptitude, but MSQ can also come. Okay, so just we are taking a guess, who knows, it may come. So just I put this particular question as MSQ. Computer science department has the highest percentage increase. From here to here you need to go, no? From 21 to 23. 21 to 23. So they are increasing by 70 by 90. Like I am having 20 rupees now. Tomorrow I am having 30 rupees. So how much increase is there? 50%. So how would I find out this for 50%? 30 minus 20 divided by 20. So similarly, from 90 to 160 I am going. So how would I find out the increase? 70 divided by 90. So that would be 70 by 9. $700 by 9. So whatever the answer you are getting, 70 point something, whatever that you are getting. So that is very high. You can see that here the gap is 25 by 80. 25 by 80. Surely this would be higher only. You can see here the gap is 40 by 100. Here the gap is 30 by 120. That is 25% only. So surely where is the highest? In the computer science department. The total energy of consumption of all departments in 2022 is greater than 2023. No. Surely this guy is more. Like here you are increasing only. In everywhere it is increasing only. That means in 2022 it is lesser than 2023. The mechanicals department's energy consumption increased by 40% from 21 to 23. From 21 to 23. Mechanical 21 to 23. 40 by 100. Yes sir. 40% increase is there. 140 minus 100 divided by 100. So 40% increase is there. Yes. So 1, 2, 4. That's the answer. Let's go to the next. Yeah, so it is not based on sampling or anything. Okay, even if you don't know sampling and all, still you would be able to solve it. Like in the gate examination, these sampling and all these things will not come in aptitude. They will frame a generalized paragraph, but still, if I want to make a bit tougher, then I would frame it in this manner. But again, you don't need any knowledge. You just need to read it and then you need to understand. So what you can understand, modern communication system increasingly relying on digital signal processing to improve reliability and efficiency, while higher sampling rates can capture more signal detail. Higher sampling rate means more details, more signal detail. But there is some issue as well. They also increase computational load and power consumption. So power consumption, increasing the power consumption, that is an issue, and computational load, that is also an issue. So while means जबकि ऐसा हो रहा है, ये भी हो रहा है. Like something is happening good, but like while I get some enjoyment watching cricket, I am losing some time as well. Like I will feel good when I watch cricket, but I will lose some time as well. So that's the thing here. While means it is giving the sense of negation. Okay. Engineer therefore often choose sampling rates that balance performance requirement with hardware limitations rather than simply maximizing their resolution. So basically we need to have a trade-off. We need to maintain an equilibrium. There will be a trade-off between the performance and the sampling rate. You cannot increase sampling rate very drastically and you cannot decrease it very drastically as well. So there has to be some equilibrium. So this is what this paragraph is saying. Increasing the sampling rate always leads to better overall system performance. No. Overall system performance, no. If you increase it, then there are some issue as well that more power consumption would be there, computational load will also be there. Power consumption in digital system is independent of the sampling rate. No. Sampling rate higher power consumption. Practical system design involves trade-off between the signal quality and implementation constant. Yes. So constant was that you cannot increase sampling rate drastically. So yeah, there is a trade-off. Hardware limitation completely prevent the use of high sampling rates in communication system. No, you cannot. It is not saying that you cannot use sampling rate, higher sampling rate. We can use higher sampling rate, but there has to be some limitation. Okay then, yeah. So third would be the correct one. Let's go to the next one. Now we will start the technical part.
In the circuit shown, D1, D2 are silicon diodes, okay, each having cut-in voltage of 0.7, that is the threshold voltage. The input and output voltages are denoted by V in and V out. Determine the transfer characteristics. So simply we have to plot the transfer characteristics. So if I see, like I see 1.7, 0.7, 1.7, 1.7, right? So let's say when both of these are off, when both of these diodes are off, your output voltage is certainly, this current is 0, right? This current is also 0, this current is also 0, so certainly this current will be 0. So your output voltage V out is equals to 1 volt when both of them are off. I see here V out equals to 1 here. this region, right, it is not possible. This is not possible. When both of them are off, this means that both of them are off and they are telling me that it is 0. This is not certainly possible. This is again possible. This is not possible. So automatically option B and D are automatically eliminated. Now what about A and D? So let's assume, let's take a point, right? So what is the potential here? 1 volt. So what is the condition for the input voltage so that the diode D1 is on? So it must be 1.7 volts, right? If the input voltage is greater than 1.7, then the diode D1 will be on, because the P to N junction potential would be greater than 0.7. So input voltage has to be greater than 0.7, then the diode D1 will be on, and your V out will be equals to V in then. Why? Because this point will be totally short circuited. So V out and V in will be the same. So when your input voltage is greater than 1.7, your V out will be equals to V in, which I see. Yes, it does follow the same characteristics. Your V out is equals to V in when the input is greater than 1.7. So certainly both option B and both option A and C are matching. Now let's take for the negative case. Okay. Now for the negative case, what will happen? Again, if both of them are off, this point potential is 1 volt, right? So what is the voltage here that is required for this diode D2 to be turned on? It will be actually 0.3, right? Because the difference must be greater than 0.7. P side must be higher by more than 0.7. So this, if this side is higher more than 0.7, so if this side is less than 0.7, right? Let's say, sorry, if this side is less than 0.3, that is 0.2, 0.1, you choose any value, this difference will be greater than 0.7. So basically your input voltage must be less than 0.3. Then again these 2 points will be short circuited, and then again your V out will be equals to V in. So your input must be less than 0.1, then your V out will be equals to V in. That I see, I don't see here, right? I see your input is less than minus 1.7, then only your V out is equals to V in, the slope is 1. So that is certainly happening in option A. So certainly your option A would be the correct answer here. Am I correct here? Yes, option A would be the correct answer for this particular question. Three-phase transmission line has conductors with resistance 1 kilometer per phase. Okay, 1 kilometer per phase per kilometer, right? Sorry, 1 ohm per kilometer in each phase, right? Okay. Transmission line has conductors with resistance of 1 ohm per kilometer. This should be in each phase. Each phase. So it delivers a load of this much at a power factor of this. The receiving end voltage is this, and the line losses are 10% of the load power. So this is the load power, right? 10,000. So line losses are this. Determine the distance over which the load is transmitted. So if the line losses are 10%, right? That means what is the total line loss? What is the total line loss? Total line loss would be 10% of the delivered power, that is 10 kilowatt, that is 1000 kilowatt. This is the total line loss, right? Now they are asking me to determine the distance over which the load is transmitted. So if, what do you know what is this P loss equals to? So this P loss is equals to 3 into, because nothing is mentioned, I will assume the line to be star connected. So your IL square, like your I line and I phase current will be same. So it will be I square into the resistance of the line. What is the resistance of the line? It is simply 1 into the length of the line, because 1 ohm per kilometer is the resistance per unit length. So 1 into L would give me the overall resistance of the line. So this will be 3 IL square into L. 3 IL square into L, right? So I need to find out what is my IL square. This is in kilowatt, right? So let me write this in megawatt, because that will help me. What is your IL in kiloamperes? Yeah, what is your IL in kiloamperes? So I know it delivers this much amount of power at a power factor of this, with the receiving end voltage to be 132 kilovolt. So we know this formula, right? Root 3 into VL into IL cos phi would be equals to the power delivered, that is 10,000, 10 raised to the power 4, 10 raised to the power 4, right? Cos phi is given, that is 0.8 lagging. and your IL would be equals to 10 raised to the power of 4 upon root 3 into VL. VL is 132 kilovolt into cos pi, that is 0.8, right? So this would be equals to 132 into 0.8 into root 3 into 10 raised to the power 4. I want to write this in kilo ampere, so I'll only multiply by 10. That will be 0. Okay, this will be actually very small, 0.0546 kilo ampere. You can solve this, right? I can put this IL value here. So this if I square and then I take the inverse and then I divide by 3. So your length of the line approximately comes out to be 111.51 kilometers. That is present in option B. So option B will be your correct answer for the question. Four identical 20 MVA 11 kV alternators with 16% subtransient reactance are connected in parallel. Determine the short circuit capacity of the bus. So in per unit, right, the short circuit MVA is simply equals to 1 divided by XTH, right, magnitude of XTH. So this I have derived in the full course. You can visit, you can go to the playlist, right, YouTube playlist, power system analysis. There I think in the second video all these things were derived in the fault marathon, right? All these things are derived. So it will be the equivalent XTH because four identical alternators are connected in parallel, right? So XTH will be what? All four of them will be in parallel. So this will be XTH would be equals to whatever is the reactance 0.16 divided by 4, because four of them are in parallel, it will be divided by 4. So ultimately your S short circuit MVA will be 4 divided by 0.16. This would be into 5 is into 5 is this. So this again multiply by 2 divided by 2. So this will be 2.5. Am I correct? Sorry, 25. Okay, short circuit MVA would be 25. Okay, now this is in per unit. They have asked in MVA, right? So what will be your actual short circuit MVA actual? It will be per unit into the base value. Base is the actual rating of the alternators, that is 20, that is the base. So 25 into 20 will be 500 MVA. So this is the short circuit MVA of the whole system, that is 500 MVA. Determine the value of the series resistance RS required to convert this PMMC instrument, which has an average full scale deflection current of 10 microamperes and an internal resistance of 1 kilo ohm, into an AC voltmeter capable of measuring 10 volt RMS. Okay, it wants to measure 10 volt RMS from the supply using the following diode bridge rectifier shown. For the instrument to work properly, the average current through the meter must not exceed the full scale deflection current of the meter. Okay, if it is used to operate properly, this right average current through the meter must not exceed the full scale deflection current, right? Okay, it must not exceed the full scale deflection current. So here what we can do is, first of all, if this is operating, right, what is the average current in the through the meter? If this particular circuit is operating, it is basically V average upon what? So it will be whatever is the average voltage here upon Rm, right? V average upon Rm, that is the average current that is going into the meter. Or in other words, what we can say is, because either these two diodes are on or these two diodes are on, it is simply a bridge rectifier. I can say it is basically okay, no, exactly no. Let's see it as V average only. V average upon Rm. Okay, the voltage here, average voltage here, and the Rm. Now, how do I compute the average voltage here? That will be not that simple. What is the average voltage? Okay, let's not solve it like this. Let's solve it like this, right? So, what is the current when these two diodes are on? It is basically this. isn't it? Right, it is a sinusoidal current only, but it will be scaled. What will be the scaling factor? This has a, if this has a peak voltage of Vm, it will be Vm, hold on a second, Vm upon Rs plus Rm. Right, again in the negative half cycle, these two diodes will be on, the current direction will be like this only, right? And the peak value will be same. So what is the average value of this? Average value of this is Vm by Rs plus Rm, basically the 2 times the peak divided by pi. This is the average expression of my current, right? So this, because if I want my circuit to work properly, if I want my circuit to work properly, this must be, average value must be less than equals to my full scale current, right? Full scale current is 10 microampere. So 2 Vm, Vm is, so Vrms is given, that is 10 volt RMS. So if I want to convert this into the maximum voltage, this will be 10 volt RMS into root 2 upon Rs plus Rm. Rs is basically, I don't know, that is what I have to compute, plus Rm. Rm is 1 kilo ohm, right? Upon pi equals to microampere, equals to how much? How much? 10 microampere. So 10 raised to power 6, right? So if I want to solve this, this will be how much? This will be, okay, let me compute this. 2 into root 2 into 10 raised to power 6 is equals to, divided by pi is also there, Rs plus 10 cube, right? Quite large. So Rs value would be what? So 2 into root 2 divided by pi into 10,000. So this is actually 900. So your Rs value would be basically 899.31 kilo ohms. This will be the amount of resistance that you will need to connect in series if you want your circuit to work properly. A toroidal core made of steel has a relative permeability mu r equals to 1000. The core has mean radius to be 10 centimeters. So it's mu r. So it's a toroidal core, right? So that basically means the toroid is something like this, right? So the core is toroidal, whose mu r is 1000, right? And the core has a mean radius r m of 10 centimeter and a circular cross section of 1 centimeter. Circular cross section of 1 centimeter. So, okay, hold on. Circular cross sectional radius. Okay, core has a mean radius of 10 centimeter. What does it basically mean? That basically means that uh, the length of the core, right, L, will be equals to 2 pi r into the mean radius of the core. So that basically means this is the length. Okay, so it's a toroid, right? If you remember, the toroid is something like this. So it's a circle. It's a circular core. Okay, let me, right, and in the core the wires are oriented. If you remember, this is the structure of a toroid and they're talking about this radius. Okay, this is the radius, mean radius of the core, mean radius of the core. This is the core, right? Mean radius of the core, and this radius is the cross sectional radius, that is the radius at which the wires are wounded. Okay, so this will help me to compute the length of the path. So magnetic flux will flow along this direction, right? So this will help me to compute the mean length of the path that will be used later on. Yeah, so your cross sectional radius r is equals to 10 centimeter. And a circle, okay, sorry, not 10, sorry, 1 centimeter, right? 1 centimeter. A coil of 200 turns is uniformly wound. So number of turns, right, is 200. So n is equals to 200. Uniformly wound around the core. The permeability of the free space is mu naught. Okay. So mu naught is equals to 4.10 raised to the power minus 7 H Henry per meter. Determine the current in amperes required to produce a magnetic flux phi of 0.5 milliweber in the core. Right, permeability is mu naught only. So how do I compute it? What is the current formula? Do you remember what was the current? How do I find out current? So I remember one thing, that N into I is the MMF produced by the current, right? And that will be equals to what? That will be equals to H into L, right? Simply this is the simple Ampere's law. If you remember, what was your Ampere's law? Your Ampere's law was I enclosed was equals to closed line integration of H dot dl, right? This was your Ampere's law. This is just the extension of that. That's all. So I enclosed is the total amount of current enclosed because I have n turns, right? So this cross section will enclose what? How many? N number of currents. So that's why n into I. And here this is H dot dl. H into L. What is L? L is the mean length of the path. Okay. So I know what is the mean length of the path, but I don't know what is H. What is H? H throughout this core will be constant. What is that? That is equals to H is equals to mu into B. Sorry. H is equals to B upon mu, right? B upon mu. Yeah, because uh, what is the unit of B and B? So if you ever tend to get confused, right? I know this thing certainly, that my flux, right, is equals to mmf upon reluctance. So flux is mmf upon reluctance, that is Ni upon S, right? Okay, that will not help me. Yeah, I'm just telling you how do you remember that, whether it will be B upon mu or not. How do you remember it? Okay. Yeah, you remember it like this, right? You remember that your electric flux density is equals to epsilon into electric field intensity. Similarly here, your magnetic flux density will be equals to mu into magnetic field intensity. That's how you remember this thing. Okay, that's all. That's how you remember this thing, right? Yeah. So yeah, let's come back to our problem. So if I know B, right, I will be able to compute my H. Now what is B? Flux is given, right? This is the amount of flux that I need to generate. So if what is B? B is flux upon the area. Area is the cross sectional area that the flux will cut, right? So cross sectional area can be found from this particular radius, right? So if I do pi r square, that will give me the cross sectional area. So yeah, all the values are with me. Now all I need to do is calculate. So first let us compute the flux density. So this will be 0.5 into 10 raised to power of minus 3 upon area. Area is pi r square. Pi into r square, that is 10 raised to power of minus 2 whole square. So this will be 10 raised to power 4, that will go on the top. This will be 5 upon pi. This is the amount of magnetic flux density, right? So 5 upon pi, and if I know 5 upon pi, I will be able to calculate what is my H. H would be 5 upon pi upon mu. Mu is 4 pi into 10 raised to the power of minus 7. This is my H. I got my H. What is my L? L is the mean length, that is 2 pi into Rm. So 2 pi into Rm. Rm is basically the radius 10 centimeter. I will convert this into meters. So 10 into 10 raised to the power of minus 2, that is equals to 0.2 pi. 0.2 pi, right? So your N into I, just give me 1 second. N into I, right? N is 200 tons. We have 200 number of tons, right? 200 tons into I, that is what I have to calculate, will be equals to H 5 pi 4 pi. This will go on the other side, 10 raised to the power of 7 into L. L is 0.2 pi. Okay, current in amperes, this is going bit higher, on the higher side. Okay, sorry, relative permeability is given, right? Yeah, I'm sorry, I missed the first point. Relative permeability is given, so your actual permeability will be mu naught into mu r. So this will be actually this into 1000. Okay, just a point that was missed by me. So this will be 10 raised to the power 4. Okay, relative permeability is given, mu is equals to mu r into mu naught. Okay, so pi will be cancelled, uh, two zeros will be cancelled here, right? Another 0 can be cancelled, this will be 2, this 2 also will be cancelled. So ultimately everything is cancelled. What is left? Your I is equals to 5 upon 4 pi. That is what your I is equals to, right? I hope I am doing everything correctly. 5 upon 4 pi, 10 raised to the power minus 4, 10 raised to the power minus 4 will go up at the top. Yes. uh okay, so if I compute this value, what is this value? This value is equals to 5 upon 4 divided by pi. Okay, I'm making some mistake in a multiple of 10. Okay, what kind of mistake I'm making? So 2 pi 2 pi r, this is in centimeter, so this will be 10 raised to the minus 2 only. So this will be, yeah, this will be 0.1. 1000 I have to multiply, this will be pi r square, that is 10 raised to the minus 4. R is 1, right? R is 1, so that is not a problem. And a coil of 200 tons. Okay, this is 5 upon pi, 5 upon pi upon mu r mu naught. Okay, I'm making a mistake of 10. I don't know where exactly the 10 is going. I just have calculated the values. Let me check here where exactly I'm making the mistake. mm, Mu naught for pi 10 is to a minus 2, 6.2 into pi 1 by 5. This is correct. 0.2 into 5, your h is coming out to 12. Okay, let me just quickly calculate this value. 10 is to power 4 to 5 divided by pi square divided by 4. This is also correct. Okay, L is also correct, N is also correct. Everything is correct. Where am I making the mistake? Okay, somewhere in cancelling stuff. Okay. This will be 10 only, right? There will be 10. There will be 10 left. Okay. Somewhere in cancelling, I was making a mistake. This would be 50 upon 4 upon pi. That is 3.97. Okay. Don't, like, whenever you're doing the calculations, be very careful. Okay. This for a good practice. This will be this amount of current, 3.97 amperes. So for this question, 3.97 amperes will be your answer. They have told you to round off to 2 decimal places. Yeah. This will be actually 3.98. This will be the answer of this question. Consider a Boolean gate D whose output Y is related to the inputs A and B as this, right? A is basically OR, logical OR operation of B complement. Now they are telling me that you have this particular output available with you, and you have Boolean constants 0 and 1 as available as separate inputs. Using only this gate D and the constants 0 and 1, which of the following statements is not correct? NAND gate can be implemented. Can I implement a NAND gate? What do I need for a NAND gate? So basically for a NAND gate, you need the two inputs, right? And the output would be basically not AND, right? That is basically A, B bar. So basically I need to implement a AND gate and a NOT gate. Is that possible? Let's see. So Y is equals to A, B bar. This is the gate basically. If I have a gate here D, right? Some gate here D. So that if I give it as input as A, B, then the output would be A or B bar. So can I, in both the cases, can I give inputs as A? If I give both the cases inputs as A, I will simply get 1, right? I don't have complements available. Okay. Hmm. So I have another gate. Let's say here I give the input. Okay, I give, this is B, right? So now here I give B and here I give A. So this output would be what? This output would be B or A bar, and this output would be A or B bar. Okay. So for a NOT gate, what do I need? For an AND gate, I need AB bar, that is A bar or B bar. Hmm. Can I implement a NOT gate out of this? I'm trying to figure out how can I implement a NOT gate. I cannot implement a NOT gate out of this. And if I give both of them as A, that will be same. Now if I give this as the input to another D gate, what will happen? Or let's say one of, okay, if the one of the input is 1, what will happen? If one of the input is 1, right, the output would be A. Yes, so I can simply get A and B. That is a possibility. And if the input is 0, the output would be simply 1. That is also a good, yeah, okay. So I can actually, what I can do, so if y is equals to A B bar, so let's say if my B is equals to 1, if my B, if one of the inputs of this D gate is 1, right, then what will be the output? Output would be simply A. That is nothing but a buffer. Now if what I do, in A I give 0, right? One of the inputs of the gate D I give 0, and the other input I give as input itself, right? B bar. So that will be just complementing it. What do I mean? So let's say this is my some gate, right? This is input 1, this is input 2. So in the input 1 I give 0. In the input 2 I give my actual input, right? A. What will happen? Output would be what? Output will be this input 1 or input 2 bar. So that would be A bar. So my gate, this can function as a NOT gate. So I got my NOT gate. Now can I make a AND gate out of this? How can I make a AND gate? So I got a NOT gate. I just need to make an AND gate. Then I will be able to make an AND gate. OR gate cannot be implemented, right? Let's think. OR gate. They want to implement OR gate. Okay. Yeah, OR gate can be certainly implemented. Okay. OR gate cannot be implemented. This statement is wrong. Why? Because this is one of the input, and let's say the other input, okay, is this. I'm getting the same input itself. Let's say now I am providing this as 1, right? The second input as 1. What will happen? This will be B or second input complemented, right? That is 0. So B or 0, that is B itself, right? So we got B. This is one of the output, and we got A bar. Now I will again provide this inputs to the same gate swapped. Okay. So I have A complement, I have B. So this will be 2 and 1, right? So what is the output of this particular gate? It will be B or the second input complemented, right? Because the second input is always complemented. The first input is simply the same input itself. So this would be A. So we can actually implement a OR gate with these gates, right? So we'll have to just play around with the inputs. So non OR gate cannot be implemented. This statement is wrong, and they are telling me which are not correct statements. So certainly we will, option 2 is certainly one of our correct answers. Okay. Uh, hmm. Now I am not able to think of how can I make a AND gate with this, right? We cannot actually okay, so we make a NOT gate with this, but I really don't know. Okay, NAND gate would be this, right? So A or B or NAND gate can be implemented. Okay, yeah. So what is NAND gate? It is A or B or sorry, A complement or B complement. So we got this, right? So we can actually get A complement and B complement as well. How? So what we can do? We can do a bit of trickery here, right? So I will copy the same circuit. Okay, we'll copy the same circuit till this point. right? Now I will swap the inputs 1 2, and what happens? First input is copied as it is, right? That is A bar, and second input will be copied but with a complement sign, that is B bar. So this is nothing but the output of a NAND gate. So we can certainly implement a NAND gate with our D. So this statement is correct, but they are asking what is not correct, right? So this will not be my answer. Okay. NOR gate can be implemented. NOR gate can be implemented. They want to say NOR gate can be implemented. What does NOR gate basically means? NOR gate means we are ORing and then we are taking the complement. Yes, certainly NOR gate can be implemented. So I know how to make a NOT gate, right? With this gate D. So I will just add a NOT gate here, right? We can already make OR gate. So if I add a NOT gate after this, I will get NOR. So no, they are telling NOR can be implemented. Yes, it can be, right? So but they are asking me which is not correct. So this is not my correct answer. Yes, it can be, and it is, this statement is true, but they are telling me which statement is not true. AND logic cannot be implemented. AND logic cannot be implemented. Okay, they are telling me AND logic cannot be implemented. Can I implement a AND logic? I am trying to think. Remember 0 and 1 is available, that's why we were able to use 0 and 1. Ha, AND logic. They are trying to say to me AND logic. Okay, AND logic is actually implementable, right? So if so this is my NAND gate, right? In front of the NAND gate, if I add a NOT gate, that will be nothing but AB. What we are doing? So you got your NAND, right? That is bar of AB. Then again, if I do another bar, right? Another complement, what will happen? That will just cancel out. We'll get AB only. So AND gate can be implemented if I, in this output, I add a NOT gate. And NOT gate, I have already told you how can you implement, right? Simply connect 0 to the input 1 and connect A to the input 2. So yes, if I connect a NOT gate here, right? This output I will connect to the second input which I want to NOT, and the first input would be 0. So this will be basically complement of this particular expression, that is AB. So AND gate can be implemented, but they are telling me it cannot be implemented. This statement is wrong. This statement is wrong, and they are asking me which statements are wrong. So certainly this will be my correct answer. So option 2 and 4 are my correct answers for this question. What type of circuit is represented by the given figure? So is it a decoder, is it a equality detector, full adder, or full subtractor? So I see I have two functions as the output. So certainly I know decoder has only one output, right? And equality detector also has only one output, either it is equal or not equal, correct? Full adder and full subtractor, certainly they have two outputs and they have three inputs. So I think the intuition says that it can be either full adder or full subtractor. Let us solve it further, we will realize exactly what is the answer here. So yeah, so let us find out the min terms of F1, because we are simply ORing, right? We are simply doing the OR, and C, remember, is your MSB and A is your LSB, and your D input is 1. So essentially whenever I will select a particular line, right, that will pass 1, right? So basically what is the min term? What is F1? So if Y1 is passed, that is simply 1, right? Then your F1 will be 1, right? If Y2 is 1, then your also F1 will be 1. So basically F1 is the combination of the min terms, because when is Y1 passed, this is a 1:8 demultiplexer. So Y1 will be passed when your CBA will be 0 0 1. So this 0 0 1 is a min term, right, of F1 function, because when the select lines are this 0 0 1, then Y1 is selected and it is passed 1. So 1 or with anything will be 1. So F1 is high. So basically this particular Y1 is the min term, right? So similarly, if you do for the other combinations, so your F1 is a combination of min term of 1, and of course I see 2 is connected, 2, then I see 7 is connected, 7, and of course there is 4 also connected. So 4 and 7. So let me quickly show you the key map. So if I show you the key map, remember your C is the MSB and A is the LSB. Please make sure you remember this. So it's a 3 variable K map. So 0, 1, 2, 3. Make sure you make the boxes a bit bigger in the actual exam. And this will be, I will select 1, I will select 2, I will select 4, I will select 7. Is it something very obvious to you? What is this? This is the output of XOR. So we are doing C XOR B XOR A, right? So do you remember what was the output in a full adder? It is basically, in a full adder we have an input carry as well. So it is A XOR B XOR C. In a full subtractor, the output also is A XOR B XOR B. I hope you remember this thing, right? So for both of these cases, the F1 output is same actually, but full adder also has a other output, that is C out, correct? And here we have B out. So this we have to consider. So this we will eliminate with the help of F2. So again, if I follow the same rule for F2 as well, that F2 is a combination of what minterms. So F2 has Y1, F2 certainly has Y2, F2 certainly has Y7. So M1, 2, 1, 2, 7 and then 3. 1, 2, 3 and 7. Of course, you can minimize this, right? But I don't exactly remember what is the expression of C out and what is the expression of C in, right? I don't remember it. So let me go with the help of truth table. So if I plot the truth table of C out with respect to your A, B and C in, so 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. Let me take another page. 1, 0, 1 and 1, 1, 0. So I think this much will be enough actually. You will be able to eliminate it. So when everything is 0, essentially your C out is simply the what C out is whether you will have a carry or not, right? So here the sum will be zeros or 0s or 1, that is 1, that is fine. But do you have a carry? No, we don't have a carry. So carry is 0. But here you see this min term is supposed to be 1, right? If you see F2 function, it is 1 when the in the 0. So this is the 0th min term M0 and this is the M1, right? It is supposed to be 1 actually here, but it is 0. So certainly this is not the expression for the carry out. It is not the expression for carry out. Certainly you can verify. Like here again, what is the carry? For 2 as well the carry is 0, but yeah, 2 is again here a min term. For 3 the carry is 1. Okay, 3 is min term here, that is not a problem. Carry is 1. Here the carry is 0 for 4. For 5 the carry is again 1. 5 the carry is again 1. But here if you see, there is no carry for 5. Like there is no min term 5 present, right? So certainly you know your answer is full subtractor. You know the answer is full subtractor, but let's verify it, right? So in case of a subtractor, how do you compute borrow? So borrow basically means whether you will have to take a borrow from the next highest bit or not. So this you can again verify and study. I will not explain here the borrow thing, but briefly I will tell you how to compute. So when all the three borrow input borrow is also 0, A, B is 0. So basically your B out will go high only when your A is less than B plus B in, borrow in, right? B is the second subtrahend that I'm subtracting from. I'm doing A minus B, right? I'm doing A minus B and minus B in as well actually, right? Actually I'm doing A minus B and B in. Why? Because B in was the previous borrow, that is carry forwarded into the next stage. So basically when till the point this is greater than 0, I don't have to make the borrow out high, right? Till the point this is greater than 0, there is no problem because A is enough to support. So A will be high enough to support this negative values. But as soon as your A will be lower, right? Basically the other case, basically then your borrow out, B out will be turned on because we'll have to borrow from the higher bit. I hope you know how to do subtraction, right? So if you assume, let's say you have to perform this particular subtraction, let's say 15 and minus 9. How do you perform the subtraction? So what do you do? like this case is much simpler. So you know your answer is 6, right? So you simply know your answer is 6. But let's take this particular case. While this is 215 and this is 2. Okay. So how will you perform the subtraction now? So I cannot do 5 minus 9, right? You cannot do 5 minus 9. What you'll do? You'll borrow from the previous state, right? So here the previous state is 1. So if you borrow, this will be 1 5, right? So what is 1 5 minus 9? That is nothing but 6. Then you know the previous state borrow is you have borrowed a 1 from the previous state, so this is will be 0, right? This will be 0 because you have already borrowed a 1. It is 0 and this is again 2, right? So how to solve this? Again I will borrow from the previous state. Again this will become 1 0. I will borrow a 1 from the previous state, so this will become 1, right? So 1 0 minus 2, that is 8, and this will be what? 1 is still there, this is 0, so I don't have to borrow anything, so this will be 1. So that's how we solve the subtraction. Okay, I hope you remember, like although we do it directly here, right? Your brain does it directly, you don't think about it. So you borrow something, you do 6, you say this is 6, and then you say this is 10, this is 8, and this is 1. You directly do it, right? But that is what happens here internally. So if I want to perform this subtraction, right? So this bit is smaller than this one. So I will have to borrow from the next MSB, next bit. So I will borrow a 1. So basically the weight of this is what? What is the weight of this? Okay, this was actually 1, right? Yeah, this was 1. Sorry. This was 1 5. I borrowed a 1. So basically, right, the weight, if I can take it to the next stage, weight is 10. Why? Like what is the, so this is 0 0, right? If it is 0 1, what is the weight of this particular digit position? It is 2 raised to power 1, right? Similarly the weight of this position is 10 raised to power 1, weight of this position is 10 raised to power 2, something like that, right? 200 basically. So yeah, these things are there. I'm not going into the borrow right now. So yeah, this is the condition basically. So in the first case, if I see, it's pretty simple, like yeah, a is not less than b out plus b in, it is equal, so no problem, we don't have to take any borrows, no borrows required. Next case 0 0 1. So in this case again a borrow is required because your b in is greater, right? B in is greater, so certainly a borrow will be required from the next state. And we see that at this is what my min term 1, and at min term 1 the output is going high. Certainly what is happening over here as well, min term 1 the output is going high. Okay, so that is what is happening over here. And at this min term 0 1 0, again do you have to borrow? Yes, your b is greater, right, than a, certainly your borrow will be high. Again at min term 2 the output is going high. Similarly if you follow along, you will see 0 1 1, again you will have to borrow, this will also go high, right? But 1 0 0, certainly here you don't have to borrow, your a is greater than b plus b in. Again 1 0 1, again it is not less, right? It is equal, borrow will be 0. In this case also borrow will be 0. 1 1 1 1 0, again borrow will be 0. 1 1 1, again your borrow will be 1. Okay, so how many min terms? 4. M1 M2 M3 M7, M1 M2 M3 M7. So certainly this is the expression for borrow. I just wanted to verify so that you can actually understand it more properly. So your answer would be option D for this particular question. In the voltage commutated DC to DC chopper circuit, TM and TA are auxiliary and main thyristors. The load current remains constant at 120 amperes. So load current is constant at 120 amperes. The SCR, main SCR TM is triggered at t equal to 0. Then capacitance and inductance values are given. The supply voltage is this, right? Then the peak value of the current through the capacitor, turn off time of through the capacitor, and these values they're asking, right? So one thing, this all the expressions that I will write here, all these expressions has been derived in the full course. So you must watch the I think DC to DC converter, the last few lectures there I have discussed about the commutation, right? How to compute the commutation, and all the formulas are derived. So the equation of the current across the capacitor is nothing but it will be like a sinusoidal. It will be Vs into under root C by L sine omega t, omega not t, where omega naught will be 1 by under root LC, that is the resonant frequency. So simply it is basically Vs by Z, right? And Z is under root L by C. Okay, this I have derived in the full course. And if you put t equal to 0, the capacitor current is 0 because it does not even come into action at t equal to 0, right? So the peak value of the current will occur when this particular value will be equals to 1. So that will be IC, because at t equal to 0, this will have the highest value. Okay, this will be equals to IC will be equals to, because the auxiliary thyristor will be turned on. Vs value is Vs given to us. Yeah, Vs is 230 volts. So 230 into under root C value is 30 microfarad upon 20 micro Henry into 1, obviously. So this will be basically under root of 3 by 2. So 3 by 2 under root into 230, right? So it is actually equals to 281.7 volts, sorry, 7 amperes. Okay, so the peak value of the capacitor current is 281.7 amperes. That is present in option A. So option A is certainly correct. The turn off time, right? So how do I find out the turn off time? So what happens during turn off is, we write this equation. Okay, because the voltage across the capacitor during turn off would be, because when this, okay, when this will be on, so we use this equation during turn off basically. So the voltage across the capacitor, so we use this equation, Vc is equals to C dVc by, sorry, IC is equals to C dVc by dt. And during turn off, our IC current is almost constant, that is equals to my load current, that is equals to uh, my 120 ampere. This has been derived, right? I will not derive it here, but you can go and check that in the videos. So 120 into the capacitance value, that is 30 microfarad, into dVc by dt. So basically your what will be the, they are asking what is the circuit turn off time. So your change in voltage would be equals to what? Your change in voltage would be equals to, it will start from 0 volt. Initially the capacitor voltage will start from 0, and it will go to 230, because it will change linearly. Okay, the voltage would change linearly upon t. This is a t off. So voltage will change linearly across the capacitor. Why? Because the current across the capacitor is constant. Whenever the current is constant, the voltage will change linearly. So basically this is the equation of the capacitor current, right? So voltage will increase linearly. Why? Because the current across the capacitor is constant, that is equals to 120 amperes. If it is constant, the voltage will change linearly, right? This is a very basic concept of capacitor. So this already has been derived there, I will not derive it here. So this will be 41 by 4. So 230 by 4, 230 by 4 is 57.4 microseconds. So 57.4 microseconds would be your answer. Option B is again correct. The peak current through the capacitor is this? No, incorrect. The peak current through the main thyristor. So the peak current through the main thyristor, right, would be actually, the load current is always constant. So the peak current through the main thyristor will be coming from here, right? So this is the capacitor current and IO. So the peak current would be, IO is always constant, that is 120 plus IC peak, right? So 120 plus IC peak. IC peak was 281.7, that is 401.7 amperes. So 401.7 amperes. So option D is again correct for this question. So option A, B and D are correct for this question. Again, this is a formula based question for which the formulas have been already derived in the there. I will not derive everything here because that will consume more time. So answer will be A, B and D. For the control system with open loop transfer function as this, the root locus forms a circular pattern. What are the center and radius of the circle? So if they're telling me that it forms a circular pattern. Let me verify whether it actually forms a circular pattern or not by plotting the root locus. So root locus of OLT is given, right? So if I mark the zeros and poles, so I have a pole at s equal to 0, I have a pole at s equal to -2, correct? And I have a 0 at s equals to -5. So how many poles I have? 2. How many zeros I have? 1. So what will be the number of branches? It will be the higher of the two, that is number of poles, that is 2. How many asymptotes I will have? That it is poles minus 0, that is 1. I will have one asymptote. What will be the value of the asymptote? That will be 180 by pole minus 0, that is 1 into 2n minus 1, because I will have only one asymptote. So here n will be 0. So this will be 180 degrees. So I will have asymptote at 180 degrees, that is exactly here. So basically I will have a virtual 0 at 180 degrees. So how will the root locus form? So basically we start where I have even number of poles or zeros. So in this whole region, I always have even number of poles and zeros on the right hand side. So I will have the root locus here, and there will be a break away point, and then again I have even odd number of, so not even, sorry, odd number of poles or zeros. So here I have odd number of poles or zeros. So again here I will have a break, sorry, this was a break away point, this will be a break in point, sorry about that, this will be a break in point. Okay, so this will be my root locus, and of course, yes, it forms a circular pattern. So there is a shortcut, to remember this, that always the rightmost zero will be the center of the circle. What is the rightmost zero? -5. So -5 will be the center. Only one option has -5 as the center, so that will be my answer. But let us verify. How can I verify? We can verify by calculating the breakaway and breaking points. So if I say that -5 is my center, so the distance from this -5 to the break-in point and the distance from -5 to the breakaway point would be exactly same if -5 is my center. Although in the picture you're thinking, sir, this distance is higher than this one, but this picture is not according to scale. Okay, so we'll find out this distance A and we will find out this distance B, and we'll see that both of them are coming exactly same. So hence -5 has to be the center. Okay, so how do I calculate the break away and break in point? For that I will write the characteristics equation. So 1 plus g of s into h of s equal to 0. So from this I can actually say what is my characteristics equation. So g of s, h of s is this value, right? So basically your k value will come out to be minus of s into s plus 2 upon s plus 5, right? Now for calculating breakaway and breaking point, what I will do, I'll just simply differentiate this with respect to s, and I will equate this equal to 0. That will be my breakaway and breaking point. So if I differentiate this particular thing with respect to s, right? So I can ignore the negative sign because anyways I'm equating with 0. So negative sign is just a constant that will go away, right? So I can just focus on the s square plus 2s term. Okay, so the differentiation would be, this will be 2s plus 2 into s plus 5 minus, this will be s square plus 2s into 1 basically upon this s plus 5 whole square, which will, anyways negative sign is there, this negative sign, and this also, oh no, this is correct. So automatically this will be equated to 0. So from this, if I solve this equation, right, this will be 2s square plus 10s plus 2s, that is 12s plus 10 minus s square minus 2s, okay, equal to 0. So it is s square plus 10s plus 10 equal to 0, right? So from this I can find out the break in and breakaway points, right? So here s will be minus 10 plus minus b square minus 4ac upon 2a. So this will be basically minus 5 plus minus under root of 15. Now if I check the points, what is under root of 15? So under root of 15 would be 3.8 something, right? So s will be equals to, there will be 2 points, this will be minus 5, so one will be minus 1.127 and the other point would be, hold on a second, this minus 5, yeah, minus 8.87. So the interesting fact is minus 8.87 will be lying somewhere here and minus 1.127 will be lying somewhere here. So these are all valid points. So one point will be my breakaway point, other point will be my break in point. Okay, so I got my breakaway and breaking point. Now one interesting fact I saw, that the plus is the break-in point, breakaway point, and minus is the breakaway point. So I see from minus 5, right? From minus 5, if I add plus under root 15, I reach my breakaway point. So this distance is basically under root 15. Similarly, from minus 5, minus 5. If I subtract under root 15, I will reach my breakaway point. So this distance is also under root 15. So hence proved A equals to P. So the distances are same. Of course, minus 5 will be my center. You can observe from here as well, minus 5 is center, right? From minus 5, it is equidistance. Plus under root 15, minus under root 15. Okay. And what is the radius? Radius would be this distance B, that is under root 15. So that's why option A will be your correct answer for this question. For the given linear time invariant system, determine which of the following statements are correct. Okay, the system is observable, controllable. So they're asking about controllability and observability. So I remember that for controllability, we used to make this matrix. So it's a 2 cross 2 matrix. So I will have A. A is the column. Sorry, A is the. Sorry, this will be AB. I will have first B, then I will have AB, right? That will be the controllability matrix for a 2 cross 2 system. Okay. If the determinant is not equal to 0, then we say that it is controllable. Otherwise, we say it is not controllable. Basically, it has to be a full rank matrix, right? Similarly, now for observability, how can I check for observability, right? So for observability, what we can do is, hold on a second, this is P. Yes. For observability, we will do this. This will be QO, and we will form a matrix with C transpose, then C transpose, sorry, this will I think be, yeah, C transpose into A transpose. Okay, 2 cross 2, so not C transpose into A transpose, sorry, A transpose into C transpose. Correct? Yeah, that is correct. Okay, so yes, hold on, sorry, small mistake. Yeah, this is correct already. Yeah, so we will make this matrix. So we will again check the determinant of this matrix. If this is non-zero, then we will say our system is observable. Okay, or we say if this matrix is full rank matrix, then we say system is completely observable. So let me find out the let me calculate the QC matrix. So it will be B. B would be 0, 1 into A into B. A into B would be basically A into B would be, this is minus 1, 0, 0, 2 into B, 0, 1. So 0, 0, this will be 0, this will be 0, this will be 2. So we say that the determinant is 0, right? Determinant is 0, QC is 0. So it is not controllable. It is not completely controllable. So option B is correct. It is not controllable. Let me check for observability. So observability, I will do C transpose. C transpose is this, right? So this is my A, B, C basically. C transpose would be 1, 2. Okay. Then A transpose into C transpose. So A transpose is minus 1, 0, 0, 2 into C transpose. C transpose would be 1, 2. Okay. So this will be minus 1 into 1, that is yeah, minus 1. Minus 1 into 1, that is 1. This is 0, 0, 4. Okay. So just hold on a second. So if I check the determinant of this, right, that is 4 plus 2, that is 6. So this determinant is definitely non-zero. 4, hold on a second. Yeah, 4 plus 2, yeah, that is 6. This determinant is definitely non-zero. So my system will be completely observable. Correct, my system will be completely observable. So option C is correct, option B is correct. So BC will be your answer for the question. A three-phase star-connected induction motor has a rotor resistance per phase of 0.05 ohms per phase and a standstill rotor reactance of 0.12 ohm per phase. The stator resistance may be neglected. The induced EMF between the slip ring terminals is 100 volts. So basically on the stator side, right, stator resistance may be neglected, and the EMF that I am developing is 100 volts, right? That is, this is equals to my E1, and of course there will be some magnetizing reactance that will connect the secondary and the primary. Okay, induced EMF between the slip ring terminals, this is a line voltage, right? This is line. Okay, so per phase it will be 100 divided by root 3 because it is star connected system. If the motor operates at a slip of 4%, determine the phase angle between the rotor induced voltage and the rotor induced current. So for this, right, you don't actually have to worry about anything. All you need is the information regarding the uh, this reactance, right? So basically they're asking you what is the, so this will be scaled here. If you remember, this is your primary side voltage, your secondary side voltage was S into E1, right? S into E1, whatever is the slip. Okay, and this, and the current will be this rotor current IR. So basically what is the phase angle between this voltage and the current? That is nothing but the impedance angle, right? That is nothing but the impedance angle. So ultimately we will have to calculate the impedance angle. How do I compute the impedance angle? Do you remember it? So uh, this, the reactance that they have given me, right, it is a standstill rotor reactance, and this voltage whatever induced EMF, this is a standstill EMF. So this EMF is when the slip is 1. Okay, when the slip will be 0.04, the EMF will be something else. Again, this EMF is this reactance is when the slip is 1. When the slip will be something else, the reactance would be S into X2S. I hope you remember this thing, X into S2, simply like this, right? So the slip currently is 0.04 into S into X2. X2 is 0.12 ohms. So your actual reactance would be 0.04 into 0.12, that is equals to 0.0048. Now what will be your angle? Phi. Phi would be tan inverse 0.0048 upon 0.005. So this upon 0.05 tan inverse, that approximately comes out to be 5.83 degrees. So this will be the answer of your question. Technically you just have to find out this phase angle, that's all. A single phase 230 volt 50 hertz 4 pole capacitor start uh, induction motor has the following standstill impedances. What should be the value of the starting capacitor required to create an 80-degree phase difference between the currents in the main and the auxiliary winding? So if you remember the circuit diagram of the main and the auxiliary winding, the circuit diagram was something like this, right? This is the auxiliary winding, this is the main winding. Now what we do to increase our starting torque, we add a capacitor in series with the auxiliary winding. Why? To increase the phase difference, right? That is the main purpose. If you remember, then we totally disconnect the auxiliary winding, only the main winding is in the operation when it is running properly. So yeah, something like that is happening. So we want the phase difference. What should be the value of the starting capacitor required to create a phase difference of 80 degrees between the currents? So I have a current here, that is a main winding current, and this is the auxiliary winding current. The phase difference between these two currents must be 80 degrees. Okay, that is what they want. The phase difference must be 80 degrees, right? So how do I compute that? I know there is some voltage here, right? Now this voltage is applied across both, let's assume this is a V angle 0. This voltage is applied across both the main winding and the auxiliary winding. So technically they are in parallel. So now what you can do is, what is the main winding current? It will be the voltage across the main winding. Just give me a second. Voltage across the main winding divided by the impedance of the main winding and the angle, right? So your angle of the main winding, this is theta m, is actually equals to, if I say what is the angle of IM, angle of IM is actually equals to minus of theta m. And what is the angle? Okay, we don't have space, so let me get everything in the bottom. What is the angle? Similarly, if you compute, right, you will get the same result, angle for the of the current of the auxiliary winding, that will come out to be minus theta a. Now they want the phase difference. What they want? They want the phase difference between the currents in the main and the auxiliary winding to be 80 degrees. So the mod of the difference between theta, basically, okay, let me compute the angles, right? Let me compute this angle. This angle would be, what is theta m? Minus of tan inverse xm upon r, right? Whatever is the reactance upon r, so that, sorry, reactance upon r, that would be the theta m. So xm is 12 upon r, that is 4, sorry, 8. So this would be equals to 12 upon 8 tan inverse, that is minus 56.3. Now what is the angle here? This will be minus of tan inverse. Now reactance provided by the auxiliary winding is plus j, it is plus j 4, and there will be a minus xc because reactance provided by the capacitance will be negative. So minus xc upon the resistance is 16. Okay, so this is the angle of the current of the auxiliary winding, and this is the angle of the current of the main winding. We know that whenever auxiliary winding is connected, it will be somewhat in the leading phase, right? Somewhat in the leading phase. So difference between these two must be equals to 80. What I mean by it? So difference between angle of the auxiliary winding, because it will be leading, so its angle will be positive. That's why I'm writing it first. Or if you are confused, just take the absolute value. Just take the absolute value. Ultimately, the phase difference between the main winding and the auxiliary winding current must be equals to 80 degrees. So basically, if you take the absolute value, this will be minus of tan inverse 4 minus xc upon 16. This will become plus 56.3 degrees. Let's assume this is positive, right? Let's assume this is positive. Uh, no, we have to assume so absolute value of this, right? So there are two solutions. Either I can break it down. This is negative of 80 or positive. So if I break it down as positive, what will happen is that yeah, this is fine. If your xc is greater, so if your xc is greater, no, we cannot break this absolute value to be positive. Uh, Hold on, auxiliary winding angle will be greater, right? No, so this is fine. Yes. So what I can do is, we know auxiliary winding current will be leading because it has a capacitor. So its angle will be higher than the obviously the main winding. That is the purpose of connecting auxiliary winding. Anyways, if you are confused, just take the absolute value. Don't worry. Here, what I will do, I will replace this with a. So I can take the negative sign common, right? Because xc will be greater than x4, and this negative sign can go outside. Okay. I hope you know how to calculate the tan inverse, how to take the negative sign and all those things. This will be positive and that sign will go on that side. So it will be 80 minus, sorry, 80, yeah, minus 56.3, that is equals to 23.69. So your xc would be equals to tan of this. So xc approximately comes out to be 11.2. Am I correct? Approximately comes out to be 11.2. Ohms, right? This is the degrees. So this is my xc, but what have they asked? They have asked the capacitance value, right? So we know xc is equals to 1 by omega c, that is 2 into pi into 50 into c, right? So from this I can get the c value. C value would be equals to 11.2 into 2 into pi into 50 whole inverse into 100. So divided, it's approximately 284.2 microfarad. This will be the approximate answer of this question. This is not present in the option. I will change the options. Actually, this there was a typo here. So approximately this will be your answer for the question. 2-point charges 2q and minus 6q are located at 0, 0 and 0, 6 respectively in the xy plane. So I have 2-point charges x and y. One is located in the origin with 2q, another one is located at 0, 6 with minus 6q charge. Now in the xy plane, now what is the radius of the equipotential surface where the electric potential is 0? So basically they are asking me in between somewhere the potential will be 0, right? And that surface will form a circle actually, right? All they are asking me is the radius of that particular surface. How do I compute the radius of that particular surface? So let me first see. I don't know whether the center will be at 0 or I don't know, but I certainly know there will be some equipotential point where the electric potential is 0. So let's assume any random point. Let's assume a random point P whose coordinates are x comma y. If I assume P, then what is the potential at point P due to point charge 2q and due to point charge minus 6q? So potential at point P due to point charge 2q would be k q, that is 2q upon r1, the distance, right? This potential I'm writing with respect to reference. Same here, the potential at point P is with respect to a reference, right? That is at infinity. So this plus k into minus 6q upon r2, where r2 is the distance between this point and P. So this will be equals to 0. That is given in the question, right? The potential shall be equals to 0, right? So everything will be cancelled. Ultimately your r2 would be equals to 3r1. R2 would be equals to 3r1. Now what is your r1? R1 is basically the distance of this point charge from the point P, that is basically x minus x1, that is x square, plus y minus y1, that is y square, whole under root, right? Now what about your R2? R2 also, it is x minus x1, x minus x1, x minus 0, that is x square only, plus y minus y1. Y minus y1 is y naught is uh, 6, right? 6 whole square, whole under root. Okay, so I can put everything in this equation. So this will be x square plus y minus 6 whole square whole under root is equals to x square plus y square whole under root into 3. I can square both sides. This will be x square plus y minus 6 whole square equals to 9 into x square plus y square. So this will be equals to, this can go on the other side. So 8x square plus 8y square plus, what is this? This is minus, right? Hold on a second. Yeah, plus this is minus. So 12y plus minus 36. Okay, that is equals to 0. So if I form this equation properly, right, let me form this equation properly. Let me take 8 as common, right? If I take 8 as common, this will be x square plus y square. This will be, if I take 8 as common, this will be 12 by 8, that is 4 by 3. 12 by 8, sorry, not 4 by 3, 12 by 8. So this will be 3 by 2, 3 by 2y. And if I take 8 common from here, this will be okay, I can take 4. So this is basically 9 into 4. 9 into 4. So this will be 9 by 2 equal to 9 by 4, right? 9 into 4, 1 4 is there, taken out, so 9 by 2 only. Yes. So this will be equals to, if I rewrite this in proper square format, because I want to form the equation of a circle, right? I want to form the equation of a circle, so this will be y minus, this is negative, this will go on that side, this can be y plus this is 3 by 2y, right? So this will be 3 by 4 whole square. Okay, so for getting to 3 by 4, I have to add by 9 by 16 and subtract by 9 by 16, right? I'm just completing the square here. So this would be actually this, if I multiply by 8, 8 into 9 is 72, 72 plus 9 is 81 by 16. So on the other side it will be 81 by 16. Okay, so it will be 81 by 16. Now this is the equation of a simple circle, right? This is simply the equation of a circle. Now simply it is x square plus y minus some a whole square equals to r square, right? So r would be equals to 9 upon 4, that is equals to 2.25 meters. So your radius of the circle of the equipotential surface would be 2.25 meters, and the center would be, this is not this is center would be at minus 3 by 4. Okay, 0 comma minus 3 by 4. Remember this, it is 0 because here I have x minus 0 whole square, and this will be minus 3 by 4. Be very very careful, right? This will be minus 3 by 4. Okay, so here this will be minus 3 by 4, like center would be at minus 3 by 4, center would be lying somewhere here. Okay, this will be the center of the equipotential surface. So yeah, so answer is 2.25 meters. The electric displacement field is given by this. So it is basically the flux density, electric flux density field is given. IJK are the unit vectors along x, y and z. A cube of side length 1 meter whose center is at origin, extending from minus 0.5 meters to plus 0.5 meters along each coordinate axis, okay, is given. Determine the total electric charge enclosed within the cube. Express your answers in coulombs. So we have to compute the total electric charge enclosed in the cube. How do I compute that? So what we can do, we can compute the surface integral, right? We can simply compute the surface integral d dot ds, and that will give me the overall charge enclosed within the cube. Okay, that is one way to solve it. Or what you can do, you can actually totally calculate the volume charge density. From that also you can solve, if you know the volume charge density of the cube. Will that be helpful? uh, Let me just think. Because if you compute the surface, if you compute the surface integration, right, you will have almost 8 surfaces, correct? There are almost 8 surfaces, which will be a bit difficult for you to solve. So what is this? This is actually equals to q enclosed. So this can also be converted into Gauss divergence theorem, right? Because this is a closed surface integral, I can convert this into Gauss divergence theorem. Of course this is polynomial, so everything is continuous. So this will be del dot d ds dv, right? Del dot d dv volume integral. This will be much easier for me to solve, equals to my q enclosed, right? So what is the divergence of the electric displacement field? It will be 3x square plus 3y square plus this is 0, right? I'm differentiating with respect to z, that will be 0. It is in coulomb per meter square, so everything is in SI units. Okay, don't forget, everything is in SI units. Now yeah, if I solve this further, right, this will be triple integration. What is dv? Dv is dx dy dz. This becomes a bit easier for me. So this will be the first term I can integrate with respect to x, right? So it will be x cube divided by 3, 3 will be cancelled, and x will go from what? So it's a cube, right? And all the points are going from minus 0.5 to plus 0.5. So this will go from minus 0.5 to plus 0.5. I hope you know how to compute the integration. dy dz. So okay, we're not getting enough space. Just give me 1 second. Now it should be fine. So everything will go from minus 0.5 to plus 0.5, right? So this was only for x. Okay. Now of course I have to compute the integration of this term as well. Same thing. Everything will be carbon copy ditto. This will also go from minus 0.5 to plus 0.5, minus 0.5 to plus 0.5, but this will be the limits of y and z, and I have the x here. Right? That is y cube. That is going from minus 0.5 to plus 0.5. So it's odd function. Sorry, it's even function, right? X square y square is even function. So it will be simply 2 into whatever is the value. So I hope you can compute the integration. I'm not explaining you how to compute the triple integration. I hope you know how to compute the triple integration. It will be 2 into 0.5 cube, right? 0.5 cube into 0.5. Okay, yeah, 0.5 whole square. So basically this will be also multiplied by 2. So I'm just computing the integration here. Okay, I hope you can compute the integration. I'm not explaining you how to compute the integration. Okay, so what will be this value? This value will be 2, this will be gone. This is 0.5 whole cube. Okay, I hope I'm not making any mistake here. X cube 3y square. Z is going, two values, two limits are there, 0.5 into 0.5. Yeah, okay, sorry, yeah, this is 1, this is 1, this is what, this is 1, this is 1, right? This is also 1, this is only 0.25 cube. Okay, somewhere I'm making, that's why you should not rush in a hurry. Okay, so let me solve it properly. So basically what will happen, this integration will be, this will be 0.5 whole cube minus of 0.5 whole cube, that will actually become 0.5 whole cube, right? That is the solution of this particular term, right? After that this will just a constant, and I am integrating this, right? These are separable, this is in the variable separable format. What is the range? 0.5 to minus 0.5. So essentially it is 1. What is the change in y? It is 1, right? So multiply by 1. And what is the change in z? It is 1. And this function is identical. The integration value will be same. You see the variable to be different, but the integration value will be same. So as I'm adding, so I will multiply by 2. As I'm adding up, I will multiply by 2. Okay, you can solve the integration. I hope you can solve the integration. So this will be 2 into 0.5 cube, that is 0.5 whole square, into 2, that is 0.5 only. So your answer, right, your charge enclosed is 0.5 coulombs. Everything is in SI units, so it will come out to be in coulombs. So electric charge enclosed within the cube will be 0.5 coulombs. This will be the answer of your question. In a balanced three-phase star-connected system, two wattmeters are used for power measurement. Wattmeter 1 records reading of 4500 watts. Wattmeter 2 records minus 800 reading. Basically, that basically means the connections are reversed. After its current coil has been reversed. Okay. Yeah. If the supply voltage is 400 volt, okay, it's a star-connected system. The system operates at 50 hertz. The value of the capacitance that should be added to each phase to ensure that the entire power is measured by solely wattmeter 1. Pretty interesting question. We know in 2 wattmeter method, the power measured, right, overall power measured, P is actually equals to W1 plus W2. So in this case, our W1 plus W2 is minus 800 plus 4500, right? So it is actually 4500 minus 800, right? W2 is negative. So which comes out to be 3700 watts. But we are certainly not interested in this. What we're interested is to compute the individual powers. So we know one of the wattmeters reading would be VLIL cos, I hope you remember this formula, cos of 30 plus 5, and the other wattmeter will be 30 minus 5. Now have they told us the load, what kind of load it is? Okay. Yeah, it should be mentioned actually the load is lagging. Okay, it should be mentioned the load is lagging, right? That will be mentioned in the question, the load is lagging. Okay, lagging load. So if the load is lagging, so one of the readings of the wattmeter would be 30 minus 5, and the other reading of the wattmeter would be VLIL cos of 30 plus 5. Now if the load is lagging, right, if the load is lagging, then what will happen? Then your power factor would be equals to what? What will be the power factor? Your power factor, so out of this, one of them reads negative, right? One of them is reading negative. And what is the ratio of both of them? W1 upon W2, it is basically 4500 upon 800. So it is 45 upon 8, right? Okay, this will not help us. Okay, let me first compute the power factor angle, right? What is tan phi? Tan phi would be the reactive power upon the active power. So what is the reactive power? Reactive power is root 3 into W1 minus W2. If you remember, it was root 3 into W1 minus W2. So W1 is 4500. This will be positive because I have assumed the load to be lagging. And this will be minus of minus 800, right? Upon W1 plus W2, that is 3700, right? So this will be equals to, so I can compute the power factor angle here. Why is it important? I will explain just in a moment. So this will be 5300 divided by 5700 into root 3 tan inverse. So your power factor angle phi comes out to be 68.04 degrees. Now what we want is, so if it is 68.04 degrees, right, what is cos of 30 plus 5? That is cos of 98.04. So what will happen? This will read negative. That's why I see W2 reads negative, and cos of 30 minus 5 would be minus 38.04. Cos of this angle will be something positive only, something less than 1 and positive. So just give me a second. I think this is fine. So this would be actually equals to something positive, right? So certainly we can verify, yes, whatever we have computed, that seems correct. Now what they want to connect a capacitance in each phase. What is the value of the capacitance in each phase that must be uh, connected? Okay, obviously in microfarad they're asking, so that what happens, all of the reading is measured by wattmeter W1. When that will happen? When wattmeter W2 will read 0. And when will it read 0? When your angle phi is equals to 60 degrees. If your angle is 60, it will become cos 90, and cos 90 is 0. So basically what we want to do, we want to improve our power factor from 68 degrees to 60 degrees. That is all we want to do. Correct? That is all we want to do. Okay. So, if it's a simple RL load, right? If it's a simple RL load, what is the, if I draw the per phase equivalent, they should have mentioned actually it is a balanced load. Yeah, it is a balanced three-phase system. Okay, if the system is balanced, that means load and source both are balanced. Okay, yeah. So basically, what is the current if I have, let's say, single phase equivalent of R and XL, JXL, right? What is the current and voltage? So I certainly know what is VL into IL. VL into IL. So I can use this particular equation. So cos of 30 minus 5, that is cos of 38, right? into VL. So cos of 38 is simply 0.787 into VL into IL will be equals to W1. W1 is equals to 4500, right? And your VL is what? VL is given, right? It is a supply voltage is 400, that is the RMS value, and VL is the supply line voltage only. So this into 400 into 4500, so you, from this you get the value of your phase current, right? IL, you get the value of your phase current, that is IL. So your IL is actually equals to 14.28 ampere. In this equation also you will get the, okay, hold on, no, yeah, this will be a phase current because this is the balance system. Yeah, in this equation again, if I use the same formula, right, you will get the same result. So here my wattmeter reading is 800 and cos of 30 minus 5, that is 98.04, cos of this into VL, that is 400, and this into minus 800, right, that is 14.3. Yeah, it is exactly coming out to be same. So your IL current is coming out to be 14, approximately 14.3 amperes. This is a balance load and it is a star connected system. So in a star connected system, your line current is the phase current, that is 14.3 amperes, and the voltage would be what? Line voltage divided by root 3. Line voltage is 400. It is a star connected system, so it will be 400 divided by root 3. That is the phase voltage. We got our phase voltage, we got our line voltage, we got a current, phase current. So I can easily compute what will be the impedance. So impedance would be equals to what? The magnitude of the voltage upon the magnitude of the current. So this will be to 400 upon root 3. So that is 16.15 ohm. So this impedance magnitude is this. What will be R? R will be Z of cos phi, right? So into cos of phi, phi is what? 68.04 degrees. So R would be 6 ohms, approximately 6.04 ohms. What will be your XL? XL would be Z sin phi, right? Like, don't worry, in the question it will be mentioned that the load is a CRL, series RL load, otherwise you will not be able to solve it, right? It should be mentioned, it will be mentioned. So XL is equals to Z sin phi, so 16.15 into sin phi, that is almost 15 ohms. So your XL is equals to 15 ohms, right? So your inductive reactance is 15 ohms approximately. So what will be, so what they want our power factor to become 60, right? So what will be the modified circuit? The modified circuit will be this, right? Once I will connect a capacitor, I will have the inductance and the capacitance. This will be minus jxc, this will be plus jxl, this will be R, right? So overall what will happen, this particular thing, right, overall reactance X should be equals to what? So overall reactance X by R should be equals to my tan phi dash the new power factor, right? Here if you see what was the new power factor that I want to get to, I want to get to phi equal to 60, so that this will read 0. So here the new power factor must be 60. So tan 60, right? Tan 60 is root 3. So your overall reactance must be root 3 times R. Okay, what is R? R is 6.04. So your overall reactance must be 6.04 times root 3, that is 10.46. Currently what is the reactance? It is 15, right? So of course certainly I will need to connect a capacitive capacitance which will reduce this reactance from 15 to 10.46. So what is the amount of capacitive reactance? That is XC. So this X is equals to what? X is equals to XL minus XC, right? XL is basically my 15. So XC will be coming out to be 4.538 ohms. This is the amount of capacitive reactance which is equals to 1 by omega C, that is equals to 4.538. So your C would be equals to into 2 into pi into f is 50 in inverse, so it into, yeah, so this will be coming out to be, just give me a second, 7, so not 7, sorry, hold on, into 100, so it is 10 raised to the power minus 4, right? So it is actually 7.01 into 10 raised to the power minus 4 if I want to say in microfarad. So I think none of the options are matching, but yeah, we will, because there is some discrepancy in the, I think in the, what do you call, the calculation. Okay, so yeah, this calculation would be, just give me a second, right? R value is 6.04. I'm just checking whether R value everything is correct or not. It's 12, 16, power factor cos 5. Yeah, just give me a second. Cos 5 68, 568. If I come out with this, everything is correct. So just so your C will come out to be 701.3 microfarad. Okay, this will be the answer of your question. There were some calculation errors, so that's why the option are wrong, but your answer will be 701.3 microfarads. I will change the options, so this will be your answer of the question. Find the particular integral of the differential equation. So what is my particular integral? So pi, right, is equals to basically, so first of all let me write this down properly. This will be x cube into d cube plus 3x square into d square plus x into d plus 1 into y. Okay, I can convert this. So this is nothing but the Cauchy format, right? So I have to do this substitution. What kind of substitution? I can do z equals to uh, e raised to power x, right? This is the amount of, sorry, I will not do this, x equal to e raised to power z. This is the substitution that I will do. So then your d into x will be converted into dz, basically this will be dx, right? And your x square into d square will be converted into dz into dz minus 1. So all this I have taught in my full course, so I'm not explaining here much. Okay, so this will be, so now I have to find out pi would be what? Pi would be basically equals to, so let me replace this x is equals to e raised to power z, right? So this will be e raised to power z, like pi would be this function q upon this function, right? That is my pi. So q is x is e raised to power z, so this will be e raised to power z upon, hold on a second, x would be e raised to power z upon d, like for x cube into d cube I will replace dz into dz minus 1 into dz minus 2, okay, plus 3 into dz into dz minus 1 plus dz x into dz plus 1, that's it. Okay, that is what, at least what my pi would be. Okay, so let me first of all so what I can do, so if I have e raised to power a upon f of d, right, so I can replace d with a, that will be my pi basically. This I have taught in the full course. So here I will replace my, so e raised to power ax, sorry, e raised to power ax, this will be, I will replace my x with, I will replace my d with a basically, correct? So here it is e raised to power z, that is e raised to power z into 1. So everywhere I can replace my d with 1, everywhere. Okay, so if I replace my d with 1, this will be, this will be 0, right? This will be 0, this will be 1 plus 1, that is 2. So answer will be x by 2. So your particular integral would be x by 2. Okay, so if you are having doubts, you have to revise the differential equation. So with my RP by Q series, you can revise how am I doing all this, right? I will not explain here because this is just the solution of the question. If A is 3 cross 3 matrix with determinant of A is this, then the value of the determinant, determinant of adjoint of adjoint of adjoint of A inverse. Okay, do you remember what was the formula for adjoint of A determinant? It was basically determinant of A into raised to power n minus 1 whole square. So if I have 3 adjoints, then it will be determinant of A raised to the power n minus 1 whole cube. Okay, this determinant basically. Now here the interesting fact is it is A inverse. It is A inverse. So basically we know this will be changed, right? Your determinant of A, let me assume this to be another matrix B, right? P basically. Let me assume this to be B. And your B is A inverse, correct? So what will be your determinant of B? Determinant of B would be 1 by determinant of A, that is basically determinant of A raised to the power minus 1. Okay, so this will be basically A raised to the power minus 1 into n minus 1 whole cube, right? N is 3 in our, sorry, n is the order of the matrix, right? That is 3, yeah, that is 3 basically. So what is determinant of A? It is 2 raised to the power of minus 3 minus 1 whole cube, that is 2 cube, that is 2 raised to the power minus of 8, and 2 raised to the power 8 is nothing but 256, so it will be 1 by 256. This will be your answer for the question. The cumulative distribution function CDF of a Gaussian normal distribution has which of the following shapes? A horizontal shape. So they're talking about the CDF, right? So what is the PDF of a Gaussian function? Let's say a very basic with zero mean. The PDF is like this, right? CDF is nothing but the integration of PDF. So if I integrate this, slowly the area will increase, and at about the mean, the area will be maximum. Then what is happening? Here also we are adding up the area, but the rate at which I was adding, that will reduce, right? Because overall area whatever I'm adding, that is slowly reducing after every positive values of x. So it will be like this. The slope will reduce. That's all. Okay. So essentially, it is actually the shape is somewhat like this. So it's not like proper like this, but it is like a S shaped. Okay, so it is not obviously it is not a straight line, it is not a horizontal line, it is not a bell shaped curve. Bell shaped curve is the PDF, not the CDF. So it is a S shaped curve, that is given here, right? So your option D will be the correct answer for this question.
Yeah, ft is an even and periodic signal. Okay, as signal xt is defined as f of t u of t, and what is your yt? Yt is nothing but f of minus t u of minus t. Ft is even as well, so can I write it down in this manner? Yt is nothing but f of t u of minus t. So this is your ft, which is periodic, and it is even as well. So this is how your ft is going. Okay, now what is your xt? Xt is this much, it is periodic as well. So this is your xt, and this is your yt, and so on. This is your yt, and this is your xt. This is periodic in the left hand side, periodic in the right hand side, sorry. This is periodic in the right hand side. What does that mean? Its ROC will be real part of s should be greater than 0. And what about this? Its ROC would be real part of s less than 0. Why is that? So what is the meaning of ROC? Meaning of ROC is that your signal should be multiplied with e to the power minus sigma t such that xt dot e to the power minus sigma t becomes absolutely integrable. So if I multiply with e to the power minus sigma t, so if I say sigma is less than 0, that means let's say sigma is 1. So what it would become? E to the power t. So what will be the graph of e to the power t? Somewhat like this. So if this particular graph is multiplied with this graph, what will happen? The values will keep on increasing like this. That means it will not be absolutely integrable. If I put sigma should be less than 0, what will happen? If I put sigma less than 0, sorry, if I put sigma greater than 0, let us say sigma is 1. So what will happen? xt e to the power minus t. So this particular graph will be multiplied with e to the power minus t. What does that mean? The values will keep on decreasing and it will go to 0. That means now it will become absolutely integrable. So if there is a signal which is looking towards right hand side and it is periodic, then its ROC will be real part of S greater than 0. If there is a signal which is looking towards left hand side and it is periodic, then its ROC will be real part of S less than 0. Is that understandable to you? Okay. So from here, what do you see? That your X of S will converge for everything where real part of S is greater than 0. Real part of S is greater than 0, yes. Real part of S is greater than 0, no. And your Y of S will converge everything where real part of S is less than 0. It is less than 0, no. It is less than 0, yes. There you go. Okay. So this is again coming from the concept of ROC. This here surely one question is coming from the concept of ROC. There is no doubt about it. Okay. Let's go to the next one. And again, it has been explained on YouTube only in the last Killer X solution as well. I recommended to watch that particular video. I hope you have watched it. Let's move to the next one.
Two loads each with known power and power factor are connected in parallel. Okay. Determine the overall power factor of the combined system. So it's very simple, right? What will be the overall power factor? Is the overall power upon the overall apparent power taken. Okay. So what is the overall power? So this load is 24 kilowatt. This load is 40 kilowatt. So overall power would be 24 plus 40, that is 64 kilowatt. That's very simple. But to find out the overall apparent power, it is difficult because it is a complex number. It is combination of P plus JQ. So I know P. How can I find out the Q? So from this, I can use the simple formula that my Q over P is equals to tan of phi, right? So from this, I can find out the reactive power. These are lagging. Reactive power absorbed by the lagging load of 0.8 power factor. So this will be power factor is 0.8, right? So 0.8 cos inverse is 0.8 cos inverse is 36.86. This tan into 24, that would be 18. So Q1 is 18 kVAR, okay, J, right? And Q2 similarly, I can again, like, my cos phi is 0.8, right? That's how I got it. So I can do cos inverse, and from there I can put this value for the load 1. For load 2, same I do. Cos phi is 0.95. 0.95 cos inverse would give me the power factor angle. Then I will take the tan of that. That will be 0.23. Then I will multiply by the active power consumed. That is 40, right? So this will be 13.14 plus J 13.14 kVAR. So overall reactive power would be the addition of these two because they are in parallel. So overall reactive power will be 18 plus this, that is, this is 64 plus J 31.14. Okay. So this whole square plus 64 whole square whole under root. So your apparent power is 71.17 kVA. Okay. So now I can simply find out the overall power factor of the system. That will be overall apparent power into the overall power, that is 64. That comes out to be 0.9. So 0.9 lagging would be your answer for the question. Which of the following options correctly gives the values IR, IL and the circuit's power factor based on the given diagram? Okay. And the phasor current magnitudes. So basically these are the phasor current magnitudes. The angles are not given, only the magnitudes are given. Okay. So okay, I'm applying 10 volt. So here there is a current of 3 ampere. So from the 10 volt, right, this is purely capacitive. So the angle here would be plus 90 because capacitive current leads the voltage. Here the current here would be what? I don't know what is the current. This should be 4, right? Because 4 plus J3 magnitude will be make 5. Okay. Okay. Now this is also 5. That is interesting. So what shall be the current so that the magnitude does not change? So this current is what? This is 4 plus J3, right? So this also has to be some, it can be either 4 plus minus J3, right? So if I have some inductor and it is taking some current, so I can assume this to be how much current? Minus J6. If this is minus J6, right, then this will become 4 plus J3, sorry, minus J3, then still the magnitude will be same, just the phase will change. It will behave as lagging circuit because it has more lagging current. So what would be the power factor? What would be the IR value? IR value is Magnitude of IR is 4. Magnitude of IL is 6 magnitude. Okay. So 4, 6. So IL is 4, 6. So option B is correct, or option B or D is correct, right? Now we have to check for the power factor. So what is the power factor? Power factor would be the angle between the voltage, cos of angle between the voltage and the current. So what is the current? Current is 5 angle, as it is minus, right? Minus J. So this would be minus 36.86. So voltage is 100 angle 0. So cos of theta V minus theta I. So 0 minus of minus theta I. So this will be 0.8. So your power factor would be 0.8 lagging. Okay. So 0.8 lagging is present in the option B. So option B would be your correct answer for our question. In a test conducted in 50 MVA 11 kilovolt 3-phase alternator, these are the following results for different kinds of faults. The generator neutral is solidly grounded. The task is to determine the sequence reactance of the alternator. Right? We have to determine the sequence reactance. So these are the fault currents. Right? So in 3-phase fault, do remember what happens? The fault current in per unit is equals to 1 upon x1. This is the fault current in per unit, right? In 3-phase fault. Now, in line to line fault, your fault current in line to line fault is equals to root 3 into the positive sequence current. So if you remember the circuit, right, your circuit is somewhat like this in line to line fault. This is x1, this is x2, and this is your 1 pu. This is the voltage basically we teach, right? I hope you remember bit of it. So this will be like you will compute the positive sequence current IA1 from this, and your fault current is root 3 j minus j root 3 times the positive sequence current. Okay, these things are there. These things I have derived. It is present in our YouTube playlist itself. You can go visit the, you can go on YouTube, go to the playlist. There I have explained all this concept. This video is from, I think, the unbalanced, like unbalanced faults. Okay, I think it's the third marathon, unbalanced faults, right? So this will be root 3 divided by x1 plus x2. Okay, I'm talking about the magnitudes here only, talking about the magnitudes, right? X1 divided by x2. Now this will this help me in some way? Yeah, this will help me. So if I see the ratio of these two, right, if I see the ratio of these two, that is 3-phase fault current upon the line to line fault current, if, because all these values are derived in per unit, but here these are actual values. So if I take the ratio, then all the bases will be cancelled. So then I can compare properly. So this will be 3-phase upon if L to L magnitude. This will be equals to x1 plus x2 upon root 3 into x1, right? So let us compare. Okay, we have no other option but to compare. Or can we solve this? We can solve this as well, right? So yeah, we know what is the fault. So because I'm taking the ratio, right, it does not matter whether this is in per unit or this is in actual quantity. Why? Because I can multiply by the current base both on the numerator and denominator to either convert it back to actual quantity or into per unit. So it does not matter. That's why I'm comparing the ratios. So IF 3-phase is 2000, right? So 2000, and IF line to line is 2600. This will be equals to x1 plus x2 upon root 3 into x1. So from this, let me compute what is my x1 in terms of x2. So 2000 upon 2600 into root 3 minus 1. So my x1 is equals to 3 into x2. So x1 should be thrice of x2, right? I see only in this option x1 is thrice of x2. So certainly option 3 will be correct. Certainly option 3 will be correct. But if you want to verify, you can obviously go one step further. You can compare the this voltage, right? So the line to ground fault. So in a line to ground fault, all the sequence networks are in series. So a zero sequence current flows whose value is 1 by x1 plus x2 plus x naught, and of course we know the fault current will be thrice of the zero sequence current. That's why it will be 3 upon x1, x2 upon x4. Now this is equals to my if line to ground fault, right? Now what I can do is, I know this particular relation, right? x1 equals to 3x2. So this will be 3 upon 3x2 plus x2, that is 4x2. Okay, let me not use this. Let me uh yeah, let me compare what is x2 equals to. X2 is equals to x1 by 3, right? So this will be 3 divided by 1.33 x1 plus x naught. Okay, this is the fault current. Now again, if I take the ratio of the three phase fault current, that is 2000 upon the line to ground fault, right? So 2000 upon 4200 is equals to uh, your, this will be 1.33 x1. All I'm taking is the ratio, right? This ratio upon the other one, 1.33 x1 plus x naught upon 3 into x1. Okay, so from this, if I relate the x0 and x1, right? So if I relate the x1 and x0 and x2, this would be 2000 upon 4200 into 3 minus 1.33, this inverse. So your x1 actually is approximately 10.15 times of x0. So I see, yes, that is exactly what is happening, right? My x1 is almost 10 times of x0, right? So yeah, although I am not calculating the exact values, but without even calculating, I am able to solve, right? This is the shortcut that which you will use. Okay, so yeah, that's how you solve this question. Option C will be certainly correct. But if options are not present, then you will have to solve it using the long method. You will calculate. So you are able to compute what is my x1 x2 in per unit, right? I hope you can convert from per unit to base actual quantity. What you will do? You will multiply by z base with all the per unit values. I hope you can do that, right? So yeah, that was the solution of this question. Option C is the correct answer for this question. For a three-phase bus power system, if a solid three-phase fault occurs at bus 3, what are the values of the fault current and the voltage at bus 1 during the fault? So the fault current is very simple, right? So if a fault is occurring at bus 3, a solid three-phase fault is occurring at bus 3. So this will be simply equals to my uh, the pre-fault voltage. Okay, bus 3 pre-fault voltage upon the Thevenin impedance seen from the bus 3 plus the fault impedance, right? So nothing is mentioned regarding the fault impedance and nothing is mentioned regarding the pre-fault voltage. So I'll assume pre-fault voltage to be 1 and your fault impedance ZF to be 0 and your Z33 is given according to the matrix, that is J 0.175, right? So this will be equals to 0.175 inverse. This is equals to minus J 5.714 pu, that is present in only option B. So certainly your option B will be correct. Now how do you compute the voltage at bus 1 due to a fault at bus 3? So what you will have to do is simply uh, your voltage at bus 1 after the fault or during the fault will be equals to pre-fault voltage minus the drop due to what? Due to the fault current that is flowing from bus 1 to bus 3, that is IF, into the impedance between bus 1 and bus 3, that is Z13. So this will be 1 minus minus of J divided by 0.175 into Z13. Z13 is here, right? This is Z13, that is 0.125. Okay, so this will be equals to uh, okay, they forgot to write a J here. There should be a J. Okay, they forgot to put a J at the starting, so there should be a J here. Don't mess this up. There will be a J. This will be J actually. Yeah, sorry about that. So this will be JJ will be, this will be plus point, hold on a second, 0.125 upon point one, hold on a second, 0.175, that is 0.7 and plus 1, that is 1.714. Okay, that is the pre for voltage. Am I correct here? Just give me a second. This is a minus j. Oh, sorry, already minus sign is there. This will be minus only. I have to subtract. Sorry. Minus 1. So this will be plus 1. So this comes out to be 0.2857, right? Why? Because there is already a negative sign, and j into j is also minus 1. So minus 1 into minus 1 is plus 1. So ultimately this will be negative, right? So this will be 0.28. So option B certainly will be your correct answer for this question. In a three-phase semiconverter, the firing angle of the thyristor is 90 degrees. Okay, then determine the conduction interval of the freewheeling diode. Okay, what is the conduction interval of the freewheeling diode? So this thing actually I have taught in my full course. Like these things you'll have to remember that the summary for a three-phase semiconverter is if my firing angle is between 0 to 60, right, then the conduction period of a sphere would be always 120 degrees if the current is obviously assumed to be continuous. If the firing angle is greater than 60, that is in this case it is 90, then the conduction angle would be alpha. Sorry, what are they asking? They are asking me the conduction interval of the freewheeling diode. So the conduction interval of the freewheeling diode, sorry, in the previous case, if your alpha is between 0 to 60, the conduction period for your freewheeling diode would be 0 degrees. In this case, if your alpha is greater than 60, then the conduction period for your freewheeling diode would be alpha minus 60. This thing I have derived in the full course. It's not possible for me to draw the waveforms here and derive everything. So if you want to understand it, how it happens, you can refer to the full course. So alpha minus 60, right? That is the conduction period of your freewheeling diode. I hope I'm correct. Yeah. So it will be alpha minus 60. Alpha is 90. 90 minus 60, that is equals to 30 degrees. So your freewheeling diode will conduct for 30 electrical degrees. In a triggering circuit with 16-volt source, a load line characterized by the slope of minus 128 volt per ampere, right? So basically the load line, right? A load line triggering circuit is shown. The load line is characterized by a slope of minus 128 volt per ampere. What does it mean? So this is my voltage and this is my current, right? This is a load line. I think they are characterizing this, I think VG and IG. So the gate current and the gate voltage, that is what they are characterizing. That is a slope. Now calculate the gate triggering voltage and the current that results in an average power dissipation of 0.5 watts. Okay, so so can I write the equation of VG and IG? So what will be VG? VG would be equals to Vs minus Ig into Rs, right? So this is the equation of Vg with respect to Ig, right? This is the load line basically that they are talking about. You can see the slope is negative, that's why it is negative minus 128, right? So what is the slope here? So if I differentiate with respect to Ig, I will get the slope. So dVg upon dig, that is the slope of the curve, that is minus Rs, right? So from this I get the value of Rs. Rs actually is 128 ohms. Now they're telling me the current that results in an average power dissipation of 0.5 watts at the gate terminal. So there is a power dissipation of 0.5 watts. So basically your Vg into Ig, right? Because it's a DC circuit, Vg into Ig would be equals to 0.5 watts. That is given, right? So from this I can say that my Vg into Ig is this. So my Vg would be equals to 1 by 2 Ig, right? So this is the equation. So what is the equation of my load line? It is equals to Vg is equals to Vs. Vs is 16 minus Ig. Okay, what is Ig equals to? Ig is equals to 1 by 2 Vg. So this will be equals to Ig, that is 1 by 2 Vg into Rs. Rs is 128 128 ohms. Sorry, 120, yeah, 128 ohms, right? So this will be Vg is equals to 16 minus 64 by Vg. So Vg square minus 16 Vg plus 64 equal to 0. So Vg would be equals to what? Minus b plus minus b square, that is 256 minus 64, that is 4 into this, right? That is also 256, this is 0 only upon 4a. So this will be actually 4. Vg would come out to be 4. So Vg is 4. Hold on a second. Is it correct? 4 square. No, Vg would not be 4, right? Minus b. B square. B square is how much? 16 whole square is 256. Right? And yeah, sorry. And 64 into 4. Oh, 64 into 4 is 256. This is 0 only, right? Upon 2a. So Vg is actually equals to 8. Sorry. Yeah, Vg is actually equals to 8. Yeah. Vg is 8, right? So if Vg is 8, so what are they asking? So yeah, Vg would be 8, and if Vg is 8, then what is your Ig? Ig will be 1 by 2 Vg, that is 1 by 16 amperes. If I multiply this by 1000, that will give me milliamperes, that is 62.5 milliamperes. 62.5 milliamperes, that is present in option D. So option D will be correct for this question. A three-phase voltage source inverter is operated in 180-degree conduction mode. Which one of the following statements is / are correct? Both pole voltages and line voltages will have third harmonics. Okay, they are talking about the third harmonics. So we know pole voltages will always contain third harmonics. What is line voltage? Line voltage is the difference of two pole voltages, right? Let's say A naught minus A B naught. This is my VAB line voltage. We know triplet harmonics are always constant. It is similar. Triplet harmonics are similar to zero sequence, and as zero sequence are constant and are of same phase, so if I subtract two quantities, the zero sequence components will be gone. So actually my line voltages will be free from third harmonics, and my phase voltages, that is pole voltages, will contain harmonics. Okay, this is a very important point. So pole voltages will have third harmonics, line voltages will be free from third harmonics. So option B will be the correct answer for this question. Given below is a unity negative feedback control system with open loop transfer function as this. It is a unity negative feedback control system with OLTF this. Determine whether the statements are true or not. S equals to this value is a valid breakpoint. S equal to value of k is 4 at breakpoint. Value of k marginal. K marginal basically when the system is marginally stable. They should have mentioned when the system is marginally stable, then the value of k is 70. The natural frequency of oscillation, that is omega n, right, is 3.61 radian per second, 3.16 radian per second. So how can I calculate all these values? Natural frequency of oscillation. So this is a third order system. How can I find out the natural frequency of oscillation? Okay. Okay. Basically, the natural frequency of oscillation will be when my system is undamped. Okay. So if I plot the root locus of this particular system, right? So s equal to 0, we have a pole. S equal to minus 2, we have a pole. S equal to minus 5, we have a pole. Correct? So then if I plot the root locus, right? So these two will combine with each other, then there will be breakaway point. Here I will have a virtual 0 basically. Correct? I have a virtual 0. And yeah, here they will again break away. So is my system ever getting to natural frequency of oscillation? So if I plot the root locus, I'm not observing that my system is ever crossing, basically it is ever cutting the j omega axis, right? My system is never cutting the j omega axis if I see here. Okay, so now so it is a unity negative feedback transfer function. Yeah, is equal to minus 2 minus 5. Now they are telling that s equal to minus 3.8 is a valid breakpoint. So at s equal to minus 3.8, right? S equal to minus 3.8 would be somewhere here. So it does not even lie in the root locus. How can it be a valid breakaway point? or breakpoint basically. It does not even lie in the root locus, so it cannot be a valid breakpoint. Okay, so that is gone. So this option is automatically gone. Now the value of k is 4 at breakpoint. Okay, so actually it should have mentioned whether it is talking about the break, like we can discuss, we can see, we can take both breakaway and breaking point, right? So what will be the value of k at this particular point at breakaway? So do you remember what used to happen in breakaway? Either the value of k would have been maxima or minima, right? So basically what is the value of k? So I can write 1 plus g of s, right? 1 plus g of s equal to 0. So from this I can write the expression for k. Expression for k would be minus s into s plus 2 into s plus 5. Okay, so dk upon ds, like either maxima or minima of k will happen, right? That would be, so let me first like solve this. This will be minus s into s square plus 7s plus 10. Okay, this would be equals to minus of s cube minus of 7s square minus of 10s. So if I differentiate k with respect to s, I will get my breakaway and break-in points. So this will be minus, I can take common, this will be 3s square plus 14s plus 10. Okay, so yeah, I will equate this equal to 0, right? So from this I can get the value of s. S will be equals to minus of b minus of 14 plus minus b square, that is 256. Sorry, it will be 196 minus 4ac, right? 4ac would be 14 to, that is 120 upon 2a, that is 6. So this would be 196 minus 120 under root. So this would be 8.71. So this plus minus 14 upon 6, this would be equals to minus 0.88, and the other value would be 8.71 minus 14 upon 6, that would be, yeah, minus 3.8, and minus 3.8 is not even a breakaway point. So yeah, at s equal to minus 0.88 there is a break point, correct? One more break point should be there actually. Okay, why I'm not able to find out this break point? Minus 3.8, this should also be break point, right? Break in point, or it is never breaking in, because here I have 3 odd modules, so it will, no, it will break in here. So it is, okay, sorry, okay, I've made a mistake in making the uh, root locus, right? Because what used to happen is, how many number of virtual zeros we'll have? We'll actually have 3 virtual zeros, correct? Yeah, sorry, this will not terminate here, right? Okay, sorry, I've made a very small, like huge error. So always from the root locus, right? Always from the root locus, what used to happen? My root locus starts from the from basically the root locus starts from the, what do you call, the poles, and it ends at the zeros. So I have to actually find out the asymptotes. So as there are 3 poles, right? So there will be 3 virtual zeros. I also have forgotten number of z is 0, so there are 3 virtual zeros. Okay, what will be the asymptotes? Asymptotes angle, right, would be basically 180 divided by p minus z into 2n plus 1. So one of the asymptote will be where n is equals to 1, 2, 3, 4. So one of the asymptote would be 60 degrees when n is 0. Other asymptote would be when n is 1, it will be 180 degrees, and the third asymptote would be at when n is 2, that is 5 into 60, that is 300 degrees. Okay, so I was wrong actually. We'll have, so I also have like I also have make bit of mistake because I also have not revised control much. So so one of the asymptote is at 60 from the positive x-axis, so that would be somewhere here. Okay, other one would be at 180, that is here. This was correct actually. There is no breakaway breaking point, it will directly terminate, right? And the final one would be at 300 degrees, that is basically somewhere here. 300 degrees will be somewhere here. So basically my root locus will break away. There is only one break point, that is this one, right? And then it will end in the asymptote. So I was wrong there. Initially I had drawn the root locus wrong. Okay, so now I have it is clear. Now it cuts. Okay, now it cuts the j omega axis. So what we can do, we can take the dominant pole assumption and we can neglect the pole that is further away from the origin, so that my system will behave as a second order system, and due to that we can actually calculate the marginal value. So we got our breakaway point. Yes, this is a breakaway point, that is minus 0.88. So what is the value of k at minus 0.88? So I will put the value of s, that is 0.88, 2 plus 2 minus 0.88 into 5 minus 0.88. Okay, so this would be equals to 2 minus 0.88 into 5 minus 0.88 into 0.88. So that is minus 4.06. Okay, so k value is minus 4. Okay, should it be minus 4 or plus 4? Just hold on. S plus this, both of them are plus only. How can it cannot come negative, right? There is no possible. Sorry, s here already a negative sign was there, and this is minus 0.88, so this will be plus 4.06. So this is correct. So k equals to 4. The value of k is 4 at breakpoint because there is a single breakpoint, so this option is correct. Okay, the marginal value of k, basically marginal basically means where my system is marginally stable. So at this particular point my system is marginally stable. So how can I find out the value of k when my system is marginally stable? So in this particular case my roots, two roots will be purely imaginary, right? So if I write down the characteristics equation, that is equals to 1 plus gs, right? 1 plus gs, hold on, 1 plus gs would be my characteristics equation, that is equals to this, right? This whole thing. So k upon 3a square plus 14a plus 10 plus 1 equal to 0. So I can replace, this will be 3a square plus 14a. So cube also is there, right? Don't forget. Sorry. This is the value, right? Sorry. It is basically s square plus 7s plus 10s. Sorry, that was the differentiation. S cube plus 7s plus 10s. So this will be s cube plus 7s plus 10s plus k equal to 0. Okay, so when my system is marginally stable, when basically the inner product is equals to the outer product, right? This is also a shortcut. So 70 equals to k. So k is basically 70. Okay, we get the value of k when it is marginally stable when k is 70. So yeah, this option is correct. The value of k marginal is 70. This option is absolutely correct. The natural frequency of oscillation is 3.16. So we can replace it, right? We can replace the value of k here, right, with 70. And if I know that like at marginally stable, the roots are basically purely imaginary. Two roots are purely imaginary. So I can replace my s with j omega. So if I replace my s with j omega, this will become minus j omega cube. This will be, this is square actually, so this is square, right? Don't forget this square. Okay, this will be 7 minus omega square plus 10 j omega plus 70 equal to 0. Okay, just give me 1 second. So I can equate the real and imaginary terms basically. So we know that the real part and the imaginary part both should be 0, right? So if I equate the real part is basically minus 7 omega square plus 70 has to be 0. So basically I can say omega square has to be equals to 10. So from that I can directly say that omega will be under root of 10. I will ignore the negative solution, that is under root 10 is somewhat like this, that is 3.162 radian per second. Okay, that is what my omega is. So this is correct. Natural frequency of oscillation is 3.16 radian per second. That is correct. So option 2, 3 and 4 will be the correct answer for this question. A control system is given with a block diagram like this. The system exhibits a steady state error of 0.4 for a unit ramp input. Okay, based on this information, so we have a steady state error of 0.4 for a ramp input. Okay, so we are getting a finite error, non-zero error for a unit ramp input when my input R of S equals to a ramp signal R of t, right? Unit ramp, this will be basically the Laplace transform would be 1 upon S square. Based on this information, determine which of the following options is correct. The system gain k is this, the time constant of the system is this, the decay ratio is this, the settling time is this. Okay, so first of all let me define the OLTF, because this all these things are will be defined by the OLTF. So what is the OLTF? Let me simplify this block diagram. This will be 2 by g this g upon 1 plus g is, right? That is 1 plus 2 into 2 by s into s plus 1 into 2s, right? That would be my transfer function basically. Okay, so my transfer function would be OLTF would be 2 upon, this will be s square plus s plus 4s, that is s square plus 5s, right? So this would be basically, so this is the this block diagram. Now I will multiply k, so overall it will be k into 2 upon s into s plus 5 basically, right? S into s plus 5. Now the steady state error is 0.4. What is the definition of error? Do you remember what was the definition of error? Basically the error was here, right? For a unity feedback system, my E of s was equals to R of s minus C of s, right? Or if I take common my R of s, right? R of s, if I take common, this will be 1 minus C of s upon R of s, which is nothing but the transfer function of the system. Now what is my transfer function? Because this is my OLTF, G of s. What is my transfer function? It is g of s upon 1 plus g of h of s, that is 1 plus g, right? Because it is a unity feedback system. So this would be 2 upon s square, so 2k upon s square plus 5s plus 2k. Okay, so I will put that here. So R of s is 1 by s square, 1 minus 2k upon s square plus 5s plus 2k. Okay, that is equals to my error function. So the steady state error would be, I have to apply the final value theorem, ES of s, right? That is limit as s tends to 0, s into E of s. That will be the steady state error. So this will be 1 by s into this will be s square plus 5s. So I can again take s common, that is 1 s plus 5 upon s square plus 5s plus 2k. Okay, that is equals to 0.4. Okay, so this would be 5. So SS will be cancelled. 5 upon 2k is equals to 0.4. So from this I can say what is the value of k. 0.4 is nothing but 2 upon 5, right? So this will be 25 upon 4. 25 upon 4 would be 6.25. So value of k would be 6.25. 25 upon 4, yes, 6.25. 5.25, hold on a second, 25, no, 5.25 is incorrect, right? It will be 6.25. So value of k is 6.25. So this is incorrect. The time constant of the system is 0.4 seconds. Okay, they are asking me the time constant. Time constant would be basically for a second order system, right? It is basically zeta into omega n. That is the time constant, okay, of a system. So okay, they're asking me time constant. So yeah, time constant would be uh, sorry uh, sorry, zeta, one inverse of this, right? 1 by inverse. Why, how? So we remember basically, if first of all I will check like if it's an underdamped system or not. For underdamped system only this is the value. So I'll quickly tell you how is the time constant defined. So let me first plot the transfer function, right? Transfer function. So transfer function would be 2k. Remember there was a 2k here. This was 2k. Transfer function was 2k upon s square plus 5s plus 2k. So 2 into 6.25 would be 12.5. So 12.5 upon s square plus 5s plus 12.5. Now is the system overdamped, underdamped or critical damped? So we can check that by seeing the observing the roots. So if I find out the roots, this will be minus 5 plus minus b square minus 4ac. So your b square minus 4ac, right, would come out to be b square minus 4ac negative. B square minus 4ac is coming out to be negative. That means of course your system has to be underdamped. For in underdamped system only my roots are complex conjugates. Okay, so it's an underdamped system. For underdamped system we know that the poles will be lying somewhere here, and the time constant is defined basically the negative of the real part, negative of inverse of the real part of the pole. Okay, so my real part of the pole is lying at zeta omega n. Time constant would be inverse of this, right? So inverse of this, that is 1 by zeta omega n. So what is my zeta and omega n? Omega n is basically omega n whole square will be 12.5. Omega n would be under root of 12.5. What is my zeta? Zeta would be 2 zeta omega n. I can compare with the normal equation equals to 5, right? So from this I can easily find out the value of zeta. Zeta would be, so omega n is 12.5 under root this into 2 into 5. So this will be 0.707. Okay, so your time constant tau would be zeta into omega n, that is 12.5 under root inverse, that is 0.4 seconds, which is correct actually. So time constant equals to 4. This is correct. The decay ratio is e raised to power minus 2 pi. What is the decay ratio? So decay ratio, right, if you remember that my maximum peak overshoot MPO, it is equals to e raised to power minus pi cot theta. Now this is the first peak, right? So this is the first peak. When does the second peak happen? After a period of 2 pi. So the second peak, right, maximum peak overshoot, second peak overshoot would be after a 2 pi period, that is e raised to power minus 3 pi cot theta. Now the decay ratio is the by how much the peak decays, right? Because the peak would be somewhat like this. By how much the peak will decay, that is the decay ratio. So this will be the second peak overshoot upon the first peak overshoot. Okay, that will be equals to e raised to power minus 3 pi cot theta upon e raised to power minus pi cot theta, that will be equals to e raised to power minus 2 pi cot theta. That is my decay ratio, and this value actually is the maximum peak undershoot. Okay, that for your information. So what is theta? Basically theta is basically cos theta is zeta, right? So cos inverse of zeta would be my theta, that is zeta is 0.707, so theta would be 45 degree. So cot theta also will be 1. So basically my decay ratio would be e raised to power minus 2 pi. Okay, so what is e raised to power minus 2 pi? So 2 into pi exponential would be 0.01, 0.001, which is yeah, e raised to power minus 2 pi, this is correct, right? Decay ratio is e raised to power minus 2 pi, this is correct. The settling time of the system is 1.61. Settling time is nothing but 4 tau, right? 4 tau, which is 4 upon zeta omega n. So I already know what is tau, so 4 tau would be 1.61 approximately. So this option is again correct. So option A, B, C, all of them are correct answers for this question. So not A, B, C, sorry, B, C, D are correct answers for this. A 25 kVA 2000 to 200 volt 50 hertz transformer has maximum efficiency at 80% of full load. So basically, when does maximum efficiency occurs? Maximum efficiency occurs when your copper loss PCUFL is equals to, sorry, your x square into copper loss, that is the actual copper loss, is equals to the coal loss, right? So very general formula, and this I have derived in the lecture series. So if you want to go and see the solution, like if you want to understand this condition, you can watch that lecture. Has efficiency at 80% of full load, right? So then x is basically what, where x is the percentage full load, that is in this case it is 0.8. so your p coal loss would be 0.64 of p full load copper loss, right? Its per unit resistance and impedance are 0.012 and 0.05 respectively. Okay, so per unit resistance, per unit impedance is given. So rpu 0.12 pu, and impedance is given, zpu is equals to 0.05 pu. Its efficiency at half of full load and at 0.8 power factor lag is what? So this was the, okay, here nothing is mentioned, so I think they should have mentioned that it is operating at unity power factor, right? They should have mentioned it, this is operating at unity power factor. Okay, uh, okay, let me use this. So what they're asking, the efficiency at half full load. So I know what is my PCUFL. Yeah, okay, we can compute, certainly we can compute. So the efficiency is maximum at this particular load, right? Now what they're asking, they're asking me the efficiency at this particular load. Uh, okay, do you remember what is your full load copper loss? Do you remember? In per unit, your full load copper loss PCUFL actually is equals to RPU. This is again a derivation that we have derived in the lecture series. So okay, this is again a derivation of transformers. You must go and watch that particular lecture where we derived. I think it's the voltage regulation lecture, right? So your PCUFL will actually be 0.012 pu. Okay, so your P coal loss also you will be able to compute. It will be 0.64 of PCUFL. That is fine, right? And now I think we are good to go. So the efficiency, right, at half full load, right, it is x into s rated, that is 1 into 0.8 power factor, that is 0.8, divide by, again, basically the formula, I hope you remember the efficiency formula, I am directly using it, right? So it is x into s rated, that is 1 pu, into the cos phi upon x cos phi plus the losses, right? This formula I am directly using. I hope you can watch the lectures and there you can see the solution there. I'm not explaining you how this formula got to be derived and all those things. That already has been told to you in the lecture series. This will be what will be the copper loss? Copper loss will be x square, that is 0.5 whole square into PCUFL, and core loss will be constant, that will be P core, right? This will be equals to 0.4 upon 0.4. This will be 0.25 plus 0.64 PCOFL. So this will be 0.89 PCUFL. So PCFL I already know, into 100 obviously to compute in percentage, right? This will be equals to, I can certainly compute this, 0.4 plus 0.85 into 0.012 into 0.4 into 100. So it approximately comes out to be 97.5 percentage. 97.5 percentage. This will be the efficiency. This will be the answer of your question. A 100 kVA transformer has percentage efficiency at full load. Power factor is 95%. Now linear dimensions of the core and the winding are doubled. Okay. Find the percentage efficiency of the transformer at new rated load at unity power factor. So 100 kVA transformer has a percentage efficiency of at unity power factor is 95%. Okay, at full load. So basically, right, your your efficiency at full load. So let's compute in per unit, right? So let's assume S is equals to S rated. So in per unit it will be 1. So 1 cos phi is also 1 unity power factor upon, this is the output power, upon, just give me a second, 1 plus the losses, right? So we have because it is operating in full load, so it will be PCUFL in per unit plus P core, that is equals to 0.95. Now the linear dimensions of the core windings are doubled. Okay, if the linear dimensions of the core windings are doubled, what will be the percentage efficiency at the new and rated load? So this exact same concept has been taught in this lecture, right? What will happen if the linear dimensions are scaled by K? What will be the ratings, what will be the scaling factor of the ratings, right? This all thing has been taught to you in this particular lecture, lecture 15. So make sure you watch that. Here efficiency of transformers has been completely discussed. So yeah, if the linear dimensions are scaled by K, the kV rating would be scaled by K raised to power 4. Why? Because the current rating is scaled by K square, the voltage rating is scaled by K square, so the kV rating would be scaled by K raised to power 4. Both will be multiplied. Your core loss actually will be scaled by K cube. Okay, so your core loss component will be scaled by K cube. What will happen to your copper loss also roughly will be scaled by K cube only. Okay, if I technically see, yes, copper loss also will be roughly, because you, yeah, copper loss also will be scaled by K cube, because what happens, so your current gets scaled by K square, it is I square. So if we see, right, the core loss, certainly I know core loss will be scaled by K cube, right? So P core dash will be K cube into the old core loss. Now what happens is to the copper loss, what is copper loss? Copper loss is I square into R, right? And your I is scaled by K square. So this will be scaled by K raised to the power of 4. What about R? R is rho L by A. So all the linear dimensions are scaled by a factor of K. So this will be K into L, and this will be what? Area. Area is K square into A, right? Because it will be scaled by K square. So actually the R will be scaled to 1 by K into R dash. So your copper loss will be copper loss will be basically K square into the old K cube into the old copper loss. So basically your losses, your overall loss will be totally K cube into the previous losses, right? If I'm scaling all the linear dimensions by K, the old losses will be scaled by K cube. Okay, so basically you can say overall losses also have the same scaling factor. So we can actually put all that in this equation, right? So they are full load efficiency has efficiency of this at this new load. What is the efficiency? So they are actually, this is my loss, right? This is my total loss. So this will be equals to 1 upon 1 plus P loss at full load, of course, equals to 0.95. So from this I can actually calculate the value of P loss. That would be equals to, P loss would be equals to 0.0526. Now what will be the new P loss? It will be K cube. So all the linear dimensions are scaled by a factor of 2. So it will be 8 into the old P loss, right? So 8 into this would be equals to 0.421, right? 0.421. Now what will be the new efficiency? This is in per unit, right? Everything is in per unit. Now new efficiency will be the rating in per unit. Your rating, what will happen to the rating? Your rating will be K raised to the power of 4, because your current and voltage were K square. So this will be 2 raised to the power 4, that is 16 into 1 pu, and again same power factor into power factor, upon 16 into 1 pu plus the losses, that is 0.421 into 100, because they have asked in percentage. So this will be equals to this plus 16 into 16, that is into 100, 97.44 percentage, right? 97.44 percentage, that will be your answer, that is present in this 97.43. Option C is the correct answer for this question. Consider the function this. Which of the following statements are true? The total number of extrema of f of x is 3. The total number of extrema of f of x is 5. The point at which f of x attains a minimum value is this. The point of inflection of f of x occurs at x equal to 0. Now there are multiple ways of solving this single question, right? So first I will solve using graphical method, then I will solve using analytical method, where I will only use equations, no graphs, because sometimes you will not be able to draw the graphs. So in this case the function is pretty simple, right? This is my f of x. So if this is your f of x, I can obviously integrate this, right? Simply we have to integrate t dt. So that would, the integration would be t square by 2. So if the integration is t square by 2, then you will do what? You will put the limits, upper and the lower limits. Upper limit is x cube, lower limit is x square. So this will come out to be 1 by 2 x raised to the power of 6 minus x raised to the power of 4. X raised to the power of 4, right? So this, right, this we will try to plot in the graph. So plotting this is pretty difficult, but let me simplify it. Let me take x raised to the power 4 common by 2 into x square minus 1. So now let me plot the two functions. One function would be x raised to the power of 4 by 2, another one would be x square minus 1. So that is very simple for us to plot. So x raised to the power of 4 by 2 would be this, right? It's very simple. It is just like a quadratic only, but like this will increase more faster. So slope will be higher. That's all. That is the only difference. Now what about x square minus 1? So x square minus 1 would be this, right? So at x equal to 0, the value would be minus 1, and it will be concave up because it will behave like a quadratic, positive quadratic, right? So x square minus 1. So what I'm doing, I'm essentially multiplying these two functions, right? I'm multiplying these two functions. So if I'm multiplying these two functions, what will happen? If I'm multiplying these two functions, what will happen is that uh, there is a zero crossing point over here. So the let me first of all compute that zero crossing points, right? So 0 is here. If I multiply at any point, if I'm multiplying two numbers, right, let's say x1 and x2, and one of them is 0, and if the other one is a finite value, then certainly the multiplication will be 0, right? So let me identify the zero crossing points, right? So here at x equal to 0 there is a zero crossing point. Here at x equal to 0, this is minus 1. So 0 into minus 1, 0. So this will be 0. Then at x equal to, what is this point? This point would be, just Give me 1 second. When will it cross 0? So at x equal to 1 plus minus 1, right? X equal to plus minus 1, my second function will have 0 crossing points, and obviously at plus minus 1 this is some finite value. Yeah, finite value. So multiplication again would be 0 at x equal to 1, again will be 0 at x equal to minus 1, right? Now let us decide on the sign. So here right hand side of, so you can simply use the wavy curve method, right? That also you can use actually to plot, but without wavy curve method also you can solve, but with wavy curve method actually it becomes easier if you break it down into factors, right? So essentially what is this? This is nothing but x minus 1 into x plus 1 into x raised to the power of 4, right? So when x is greater than 1, right, this function is always positive. So when x is greater than 1, this function is always positive, right? When x is less than minus 1, right? Or sorry, when x is between 1 to minus 1, right, this function is always positive. X raised to the power of 4 is always positive, right? So when x is between 1 to minus 1, so the sign will be according to this one, right? Because if you see in this whole duration, this function is always positive, so only the sign will be decided upon this, so it will be negative somewhat between 1 to minus 1, and then again at x beyond x equal to minus 1, less than x equal to minus 1, right, the function, this function is also positive, this function is also positive, as can be proved by the wavy curve method as well. I hope you know what is wavy curve method. So this function is positive, right? So it will increase basically. So this will be the graph of my function. Okay. Now, sorry, I just discussed about the sign actually. Sorry. Beyond this point, my function will be positive. X greater than 1, my function will be positive. X less than 1, my function will be positive. Between x minus 1 to plus 1, the function will be negative. But actually, what will be the plot of the function? If you notice one thing, that here the function is negative, and let's say this is between minus 1 to 0, right? The value of the function is minus 1 to 0, and between minus 1 to 0, this will be also somewhere here only, right? So my function will be limited. So at this point, the value of the function is 0. Okay. Now let's say I'm somewhere here, right? Where the value of the function is 0.5, and here the value of the function will be something else, right? I will take a very basic example. Let's say I'm at x equal to 0.5. So at x equal to 0.5, what is happening? This is 0.5 raised to the power of 4, right? 0.5 raised to the power of 4, and this would be 0.5 square minus 1, right? Whatever be the value. Now if you multiply these two, what will happen? It will be something less than minus 1, right? So the value of the function would be somewhat like this. Why it will be somewhat like this? Between minus 1 to 0, because if you see, when I'm at this point, right, this function is very close to 0, right? This function is very close to 0, but this function is very far away from 0. But as my x approaches towards the origin, as my x is approaching towards the origin, the value of the function, other function is increasing, right? It is minus 1, very close to negative 1, but the value of this function is again approaching 0. So I'm always, what is happening here, I'm multiplying it by a small number and a large number, so essentially the overall product is a small number. Again near here as well, I'm multiplying by a small number and a large number, so the product is essentially negative, and somewhere here it will have some maxima, somewhere in the middle, right? When both of them are at optimum values, the multiplication will be highest. Okay, and similar will be followed in the other side. Like this you can do intuitively, or if you are not able to understand graphically, I have the analytical solution as well. So now this will increase, and here again what will happen? I know in between these minus 1 to 1, the function is negative, and after this it will always be positive. So here if you see, the value of the function is increasing, it is very close to 0. That's why I will also start very close to 0, because the multiplication factor is very small, and once both of them increase, so it will be very high, and here also it will be very high. Okay, this will be the proper graph of the function. So of course we can see that the function has 3 extrema points, or critical points as we say. Extrema points means wherever we see local maxima, local minima, and global maxima, global minima, those all will be counted on extremas. So I can see from the graph it has 3 extrema points. So first option is certainly correct, right? What about the other option? The function attains a minimum value at x equal to under root 2 by 3. So for this, certainly you can derive this, right? You can derive this. I will differentiate the function, don't worry. But you can see somewhere between 0 to minus 1, the function will attain a minimum value. But exactly at what, that we will have to do by the first derivative test, right? By the first derivative test. So what is the first derivative test? F dash of x. That will be equals to 6x raised to the power of 4 minus 4x cube into 2. Yeah. And this will be equals to 3x raised to the power of 5 minus 2x cube. Right. So, yeah. So this is the value, right? Where is this going to 0? So if I take x cube common, this will be 3x square minus 2 equal to 0. So we see certainly at x equal to 0 there is extrema point, and we can see that, right? Certainly it is attaining a global maxima here. So not global, sorry, local maxima. We are getting a local maxima somewhere here, right? X equal to 0, and at x equal to plus minus root 2 by 3 will get local minimas. You can do the derivative test as well, but yeah, you can do the derivative test. I will do the derivative test, don't worry about it. But you will see that, yeah, these are the points of local minima and not maxima. Okay, and these are certainly not points of inflection. So x equal to 0, so this option is correct, right? We attained a minimum at x equal to root 2 by 3. That is correct. What about inflection point? So it does not have 5 extrema points, that is certain. Now what about the point of inflection? So the point of inflection of f of x occurs at x equal to 0. So it occurs at x equal to 0, right? Does it really? What does inflection means? Inflection basically means the curvature of the graph changes, right? Or we can say, just give me a second, yeah, or we can say, yeah, curvature of the graph changes, right? So if you see, sorry, curvature of the graph changes, or you can say that the slope remains constant. Slope does not change. So I can take the example of a cubic function. If you take an example of a cubic function, so if you see around origin, right, just after origin and just before origin, the slope does not change. Slope is same. So this actually point is a point of inflection. This particular point is a point of inflection, right? Where the nature of the graph changes, right? This is concave up and this is convex, right? From convex we go to concave, something like that. But here the curvature is same actually. The slope does change. Okay, it will not be sharp change, it will be like a smooth change only. So slope will change actually. After it and before it, slope does change. Okay, so certainly it is not an inflection point, but if you want to totally understand it mathematically, how you can do it. So before that, I want to say this function is very easy to integrate. But what if this function was a bit difficult to integrate? Then first of all, how will you compute f of x? So you will use something called as Leibniz theorem. Right? This has been taught to you, and I think you already know. If I have a function that is a getting integrated with a dummy variable, let's say t, right, and the limits are h of x and l of x. So how will I get my derivative? So you can actually compute the derivative without even actually calculating the actual function, right? You can directly compute the derivative. So this comes from a derivation that I have taught in my full course, so you can go over there. But that is anyways not required. You just need to remember this thing. Okay, this is very important. This can be asked in examination. So okay, so if I see what are my limits in this case, one of the limits was x raised to the power of 6, another limit was x raised to the power of 4, and my f of t is t, right? So this will be h dash of x, that is 6x raised to the power of 5 into f of h of x, right? So f of h of x would be f of h of x, that is x raised to the power 6. So this will be t raised to the power 6. Hold on, f of h of x, right? Yeah, t will be replaced with, sorry, t will be replaced, just give me a second, x dash of x, f of h of x, right? So what is h of x? H of x is, sorry, it is x cube, right? Sorry, it's x cube. That is what I was confused about. Sorry. It's x cube. This is x square, right? Sorry. So this will be 3x square into, now my f of t is t, right? So t will be replaced with x cube, because like f of t is t. So f of x cube, I will just have to replace t with x cube, right? That will be x cube only, right? And yeah, minus, okay, this will be L dash of x, that will be 2x, and multiply by f of L of x, this will be simply x square, and this will be 3 into x raised to the power of 5 minus 2 into x cube. So 3x raised to the power of 5 minus 2 into x cube. So yeah, okay. So and you can see like that is what we have derived here as well, if you see, right? So I'm just like, although in this case you will use this approach much easier, but in a certain point you will see that the integration is not that simple. When the integration is not that simple, then you will use Leibniz theorem. So you will obviously get the derivative. Now, of course, again we will do the same thing. We will equate this equal to 0. We will get the points x equal to 0, x equal to plus minus root 2 by 3. So to check whether it is a minima or maxima, we do the double differentiation. If you do the double differentiation, what will you get? Now I am telling you the analytical approach. So if you do the double differentiation, this will be 15x raised to the power of 4 minus 6x square. Okay. Now, if I put the values over here, right? Okay, so I certainly know if I put plus minus root 3, plus minus 2 by root 2 here, this will be 15 into 2 by 3 square minus 6 into 2 by 3, right? This will be 15 by 9, 15 into 4 by 9 minus 4. So 60 is 20 by 3 minus 4. So which is actually, this is something 6.66, which is positive. So this is greater than 0, right? So at plus minus 2 by root 3, the double derivative is positive, and we know if the double derivative, so at x equal to plus minus 2 by root 3, f double dash of x is positive. That means we will certainly get a minima. Now this can be a local minima or a global minima. It depends, right? That we can be found out from graph only. Okay. Now certainly we know it will be local minima only, because the function, the sorry, it will be global minima, right? It will be global minima because uh, the function is always positive. Mostly it is positive. It can go unbounded for positive values, but it will never go unbounded in the negative side. So these will be global minima also, right? Great. What about x equal to 0? So if I put here 0 in the double derivative, right? The double derivative goes to 0. Now many students, if they only do by analytical method, they will say this is a point of inflection, but they will be wrong. This is not a point of inflection. Why? Because if your double derivative is 0, right, then you will have to check the triple derivative whether it is 0 or not. So you will have to continue till the point where the derivative will not equal to 0. Then you can certainly say that you will get an inflection point. Correct? Okay, so but if you did not understand this, how did this rule came, all this has been explained in the, so in the full course, of course it is explained. If you want to quickly see it, go into the RPY video, the differential calculus part, where I was discussing maxima minima, right? Differential calculus, I think it's the second marathon, and maxima minima, right? Just see the portion maxima minima, there I have discussed. Okay, there I have discussed. Right, there I have discussed. So yeah, now I will just come to the point that we will take the derivative till the point it is non-zero. Okay, I will come to the conclusion, don't worry. So I'll just show you one small example. So x cube, right? If I take the derivative x 2x, sorry 3x square. So what are my points of extrema? X equal to 0. So what is the double derivative? It is 6x. So its double derivative is also 0. Its double derivative is also 0, right? Now you will say, will you say it is inflection? Yes, it is inflection. But how can you say mathematically? So if you take the next derivative, right? Next derivative, that is derivative order to the power of 3, right? That is non-zero, right? At x equal to 0, that is non-zero. At my critical point, it is non-zero, right? Because it will be simply 6, right? Differentiation of this will be 6. So it is non-zero. So if the derivative of odd order is not equal to 0 and all the previous derivatives are equal to 0, then that point is a point of inflection. This is the mathematical proof I have explained there in the RPY video as well, in the full video as well. Then that critical point will be point of inflection. But in this case, is that happening? And if derivative of even order, right, is not 0, that means your function will be even, sorry, this will be even order. This is the derivative, right, not the power. The derivative is not equal to 0. That means the function has either a maxima or a minima. Okay, it will depend on the sign of the previous derivative. So it will depend on the sign of this derivative, right? Depend on the sign of this derivative, maxima or minimum. Okay, so yeah, this you can, like this we can confirm here itself. So let's differentiate this function again, right? This is the double derivative. So the double derivative is this, right? Let me differentiate it again. So this will be 60 into x cube minus 12x, right? And at x equal to 0, again your triple derivative is 0. So let me take the derivative again once more. So this will be 120 into x, sorry, this will be 3 multiplied, right? So 180 into x cube minus 12, right? So now at x equal to 0, the value of the function is negative. So fourth order derivative is non-zero, and I have told you it will be either maxima or minima, not inflection point. So if it is negative, what it will be? So if the derivative is like, if what is to happen if the double derivative was negative? What is to happen? We used to get a maxima, right? So if it is negative, what should we get? We will get a maxima. Are we getting a maxima? Are we getting a maxima, local maxima? Yes, we are getting a local maxima. So all the concepts are correct. So everything are interlinked. Okay, you can understand with the graph as well. So don't worry about it. So this is the like summary. If you want to solve it analytically, of course graphically it will not take you much time. But once a good question comes where the like you cannot draw the graph, right? Then you will have to solve with equations. So that's how you will solve with equations. So x equal to 0 is not an inflection point. So this is not correct. So option C and A are the correct answers of this question. For the function f of this value is harmonic for this, has conjugate harmonic function this. So what does harmonic mean? Harmonic basically means when function is harmonic, that means its del square f, right, is 0. That is what harmonic means. So basically uh, we will differentiate this function twice with respect to x, plus differentiate this function twice with respect to y, and if it was a function of z as well, then we would have differentiated this function with respect to z, and that would have been equals to 0. So for it to be harmonic, that means if I differentiate this twice with respect to x, first time this will be 2kxy, then this will be 2ky 2ky, plus this would be minus 6y square minus 12y square. Okay, minus 12y square, this is equals to 0. So from this, right, if I'm differentiating, sorry, minus 2y, minus 12y basically, sorry, minus 12y. So from this, assuming y is not 0, my k would be 6. So for k equal to 6, the function will be definitely harmonic. So option B is definitely correct. Now what about conjugate harmonic? So when is like the function conjugate harmonic? So if I say I have a uh, let's say some r of z which consists of real and imaginary part, we say that u and v are conjugate harmonic if if it follows the CR equation. If it follows the CR equation, Cauchy-Riemann equation. So what is the Cauchy-Riemann equation? Basically, u and v, if u and v are conjugate harmonic, that means your r of z function will be analytic. So what was the Cauchy-Riemann equation? Ux equals to vy and your uy was equals to minus of vx, right? So this is the real part. Let me assume this to be u. Okay, you can assume this to be v as well, no problem. Okay, you can assume this to be v as well, no problem. I am assuming it u. So what is u of x? U of x would be differentiating this with respect to x, that will be 2kxy. K is basically k is 6 because it is, we have assumed this to be already harmonic. Okay, so if k is 6, this would be 2 into 6, that is 12xy equals to v of y, that is del v upon del y, because I have to find out this function v, right? I have to find out this function v. So v is equals to 6 x, hold on a second, v is equals to 6 because I'm integrating with respect to y, 6x y square plus some constant function of y. I don't know, let me write this as some c1, constant function of y. Okay, now what about this equation? So this equation, right, u of y, what would be u of y? U of y would be differentiating this with respect to y, this would be 6x square, 6x square minus 6y square equals to del v minus of del v upon del x. Okay, so if I integrate this, this would be x cube by 3, that is 2x cube, and this would be minus 6xy square plus some c2 function of x, right? And I have to include the negative sign as well. This will be plus, this will be, oh, this can be anything, I don't care. So that is what my v is equals to. Okay, so here I see obviously 6xy square is common and I have this additional minus 2x square. So your whole function, right, whole function would be like, I can combine these two constants to be some function of x and y. So your v function would be 6y square minus 2x cube plus some constant that is present in the option C. So option, sorry, not C, option D. So option D is correct because conjugate harmonic has to this, assuming that the function f is already harmonic. Okay, so option 2 and 4, that is B and D, are correct for this question. The parabola x equal to y square that varies from 0 to 1, x equal to 0 to 1, is shown in the figure. The shaded region bounded by the curve is rotated 360 degrees about the x-axis. Okay, if the volume of the resulting solid of the revolution is alpha times pi, what is the value of alpha? So what we are doing essentially, we are revolving this about the x-axis, right? So let's take a very small point. So I'm revolving this about the x-axis. So what is this distance? That is simply y, the y value here, whatever is the distance, and I'm revolving it, right? So if I just consider this point, how much area is it covering? Right, it is actually pi y square, right? Pi y square. They are asking me volume. So actually not this point. If I consider this line, if I consider this particular line, right, it is covering pi y square. Now what will be the volume? Volume would be, I'm going from, let's say, x equals to x1 to x equal to x2. All this has been taught in our RPYQ, everything has been taught there. So I'm not explaining you the things here, just giving you bit of intuition how to solve this. So essentially what we're doing is essentially integrating this each areas, right, small areas together to create a volume about the x-axis. So it will be pi y square dx, where x will go from x equal to x1 to x equal to x2. This is the volume formed by the revolution. Okay, I hope that part is clear, because this is just a circle, right? I'm adding up all the circles. So what is y square? So y square is nothing but x according to the curve, right? So this will be pi x dx. X is going from 0 to 1. So this will be pi x square by 2, that is pi by 2. So your answer would be 0.5, because they have asked alpha into pi. So your alpha is simply 0.5. This is your answer of the question. A 300-kilometer long 400 kV, right? So the length is 300 kilometer, and okay, the voltage is this, has an inductive reactance of 0.75 ohm. Like obviously it will be per phase only, per kilometer. Wave propagation speed Vc is 1.6 into 10 raised to the power of 5 kilometer per second. If this lossless line, so it is a lossless line, is equipped, so basically if it is a lossless line, the resistance of the line is 0, the conductance of the line is 0, right? R and G are 0, is equipped for compensation. What is the resulting surge impedance loading with the particular compensation, right? So let me first calculate what is my surge impedance loading. Surge impedance loading is basically the voltage whole square upon the characteristics impedance of the transmission line, or the surge impedance, that is ZC. What is ZC? So remember, this voltage, right, is the line voltage. Remember here the voltage should be line voltage. Why? Because if the system is considered to be star, so it will be root 3 into V phase. So this whole square will be 3 V phase whole square divided by ZC, right? So ultimately this gives me my 3 phase power. That's why this voltage must be line voltage. Okay. So V square by ZC. So I know V square, I know voltage, right? The line voltage I know, they have given me the line voltage. Now I need to compute ZC. ZC is basically under root L by C, where L is the inductance of the line per kilometer and C is the inductance of the line per kilometer, per phase obviously, both are phase quantities, per phase. I can certainly compute what is my L. How can I compute? So because what they have given me is the reactance, right, of the line reactance, inductive reactance is given to me, that is 0.75. So this will be equals to 2 pi f into L, that is the inductance per phase per kilometer, would be equals to the reactance, inductive reactance, that is 0.75. So it is 50 hertz, right? So I can easily compute the I can easily compute the inductance per phase, that is 0.75 divided by 2 divided by pi divided by 50 into 1000. So this is basically 2.387 millihenry per kilometer. Remember, per kilometer, because inductance also is represented in per kilometer quantity. Okay, hold on a second. 2.38 millihenry per kilometer. What about your capacitance? How do I compute the capacitance? Because I need to compute ZC. So do you know what is the speed of the propagation of wave through the line? That is equals to 1 by under root LC. That is the most fundamental formula. That is, again, all these things have been derived in the full course in the YouTube playlist as well. I think the long transmission line parameters, like performance of transmission line, all these things are derived there. So this is 1 by under root LC. So this will be equals to, I know L, right? Everything is in kilometer, right? So if I write this in per kilometer, then C also will be in per kilometer, because your velocity also is in per kilometer. So everything is proper, don't worry. So but this is in millihenry, right? Make sure you write in proper units. So this will be 1 by under root 2.387 into minus 3. Why? Because this is in millihenry. Per kilometer is fine, because your C also will be in farad per kilometer. That is fine. and this VC is equals to 1.6 into 10 raised to power 5 kilometer per second, right? So this would be okay, 1.6 whole square, 1.6 whole square into 2.387. This can go, so this inverse would be 0.1636. Now this is 10 raised to power 4, 10 raised to power 10 into 10 raised to power minus 3, that is 10 raised to power minus hold on, c will go there. Oh, this will be divided by 10 raised to the power of minus 13, right? 110. Okay, that is coming out to be quite large. How is that possible? So this will be okay, something I'm doing something wrong. 1 by 100 LC, this I'm squaring it, this will be 10 raised to power 10. So c will go that side, this will, okay, sorry, this is 10 raised to power 10. Oh, this will be 10 raised to the power 7. So this will be, if I want to write this in what do I want to write? Let me write this in pico, right? If I write this in pico, this will be, I can multiply by 10 raised to the power 5, or let me write this in nano. So if I write this in nano, then I can multiply, and so basically I can multiply by 10 raised to the power 9, right, to write this in nanofarad per kilometer. Okay, so this will be basically 16.36 nanofarad per kilometer. This is the capacitance per phase, okay, per kilometer. So what will be my ZC? ZC would be under root L by C. L is 2.387 millihenry, that is 10 raised to the minus 3, and C is 16.36 nanofarad, that is 10 raised to the minus 9 per kilometer, is automatically getting cancelled. So this will be into 100, this divided by 2.387 inverse, and 10 raised to the power 6 can go on the other side, this under root. So this will be 0.381 into 10 raised to the power of 3, that is approximately 382 ohms approximately. Okay, this is the surge impedance. So we got the surge impedance. Now what is our surge impedance loading? Surge impedance loading would be equals to V square upon this surge impedance. Now let's read the question. Now they are doing 30% series capacitive compensation. That basically means if the line inductance is XL, right, they are doing a capacitive compensation of 30%. 30% basically means what? Whatever, so they are adding a series capacitance, that is minus j x, so that overall inductance of the line is reducing. So if previously it was XL minus XC, right, now if previously it was XL, now it has become XL minus XC. They are doing 30% compensation. That basically means that they are adding 30% of the line inductance as capacitance. So this will be 0.3 of XL. So now what is your new XL? XL dash, it is 0.7 into XL. So now what will be the new inductance? Your inductance also will reduce by 30%, basically, right? Line inductance will reduce by 30%. So what will happen? Your ZC, what will happen to your ZC? Everything is constant, just your inductance part is reducing by 30%. So your ZC would be basically 0.7 under root, because your L dash will now become 0.7 of the previous L, right? That's it. So it will be 0.7 of the previous one. So 0.7 into the previous surge impedance, that is 382. Now with this ZC, what is the surge impedance loading? So the voltage is what? 400 kilovolt. So 400 whole square, this will become mega upon the ZC. ZC is 382 into under root 0.7. So 319 into 400 square, so which is approximately 500 megawatt. This was for the option 1. Okay, So the option 1 is saying, yeah, 500 megawatt with 30% series compensation, absolutely correct. 500 megawatt with 30% series inductive compensation. That basically means what? That basically means I'm adding an inductance now. I'm adding 30% inductance. So now with a line, if previous inductance was XL, now I'm adding another 30% more inductance. So 0.3 XL. Now what is happening? Your XL is increasing to 1.3. So your L also will increase to 1.3 times the previous L. So your ZC also will increase to under root 1.3. So certainly, if you see, they are telling you will get the same surge impedance. No, the surge impedance loading will be different because your ZC is now increasing. Previously, if you saw, it was decreasing. We always want to increase our surge impedance loading. So actually, this is never done, right? But you can do it, but this is never recommended. So it will not be same. It will be different. The surge impedance loading will be reduced. It will not be same. Now in this statement, we are doing 20% parallel inductive compensation, right? If we are doing 20% parallel inductive compensation, that is the same, right? That is the same as saying that I'm reducing my capacitance by 20%. Okay, similar to this, if I'm reducing my inductance by 30%, then we say we are doing 30% series capacitive compensation. So this thing is the same. So here your surge impedance loading would be equals to, like, you are reducing your capacitance by 20%. So now your capacitance is 0.8 C, right? 0.8. So it will be under root 0.8 C, because I'm reducing my your new capacitance value is 0.8 C of the old capacitance value. So your ZC would be 0.8 into your old ZC, right? So your surge impedance loading will be what? Sorry, it will not be 0.8 into old ZC, right? ZC is inversely proportional to the capacitance. So your new ZC would be ZC upon under root 0.8. That is the only difference. That is the only difference. So your surge impedance loading would be 400 square upon your ZC 382 divided by this factor, right? So this will go in the numerator. That will be 0.8 under root. So if I solve this, 400 square into 0.8 under root divided by 382. So 374.6, 374.6 megawatt would be your answer if we are doing a shunt compensation of 20% in parallel. So this will be certainly, if I am doing parallel capacitive compensation, it is essentially telling me that the capacitance value is now increasing to 1.2 C, right? So this will be something else. This will not be same as this, right? You can calculate, now you know the new capacitance value, you can certainly compute the surge impedance loading, but it will not be same as this. Okay, it will be something different. So option 1 and 3 are the correct answers for this question. A synchronous generator rated at 500 kVA 400 volt 0.1 pu as a sub-transient reactance. So the sub-transient reactance XS double dash is 0.1 pu, right? uh, it is supplying a passive load of 400 kilowatt at 0.8 power factor. The three-phase fault occurs at the generator terminals. Then the magnitude of the initial fault current would be equals to what? What is the magnitude of the initial fault current? So the magnitude of the initial fault current would be equals to the pre-fault voltage. So basically, this is my EG, this is my JXS, and this is my VT, right? VT by default you assume 1 angle 0 pu. Okay, by default you assume 1 angle 0 pu, right? So when it was working properly, what was the EG? What is the EG? How do I calculate it? Your EG would be equals to your VT minus IL load current into J into XS, right? Now in this case, you see that you don't have any reactance like normal synchronous reactance given. So you will assume that your subtransient reactance and your synchronous reactance are same. Generally, they will be different. It will be given to you. If it is not given to you, you will assume them same. If it is given as different, then in this equation, right, XS will come, not XS double dash. XS double dash is the subtransient reactance. XS is the normal reactance. Okay, so in this formula, XS will come, not XS double dash. Okay, So yeah, in this case nothing is mentioned, so I will assume them to be equal. So what is now IL? IL in per unit, because they have asked me in per unit, right? I will compute everything in per unit. So we know what is the power consumed in per unit, right? So power is equals to this would be the actual power upon the kV rating, right? What is the kV rating? It is 500, right? This is my per unit power. So per unit power is 0.8, and this is equals to my V per unit, that is 1 into I per unit, that is I only, IL, into cos phi. Cos phi is already in per unit, that is 0.8. So your IL also is actually equals to 1 only, 1 per unit, angle minus 36.86, because your power factor is 0.8 and it is lagging, hence minus. So this will be, your current would be 1 angle minus 36.86 degrees into J. J is 90 and XS is 0.1, right? 0.1 into plus 90, correct? Just give me a second. So this will be equals to, how do I calculate this? So we can compute the EG double dash here. Uh, so this will be 0.1 into cos, so 36.86 plus 90 cos, so 0.6, right? So this will be 0.4, and what about 36.86 plus 90 sine, this will be 0.8. So plus j, sorry, minus j, sorry, plus j 0.8, right? So what is your E magnitude? Okay, something I'm doing wrong. Oh, this is already negative. Okay, IL minus, oh sorry, this will be plus, right? Well, this will not be, IL is this, right? IL is plus, sorry, this will be plus, I'm sorry. So this will actually be 1.4, right? 1 angle 0, 1 angle 0 plus, okay, 0.1 is also multiplied, don't forget 0.1 is also multiplied. So 1 plus, this will be 0.1 into basically, like if you convert this into rectangular format, this will be cos of 63, that is 0.4 plus j 0.6. So 0.1 into 0.4, that is 1.04 plus j 0.06. So this magnitude plus 0.06 whole square whole under root would be 1.041, something like this, right? I hope I am correct. So this is cos of 63 will be less, yeah, sin 60 will be more. Oh no, sorry, this is 0.6, this is 0.8, I'm sorry. So this is the conversion actually, sorry, this will be 1.08, so this will be 1.06, this will be 1.08. So this actually is something else, plus 0.08, like you can do the conversion, you can do the like rectangular conversion. So this is your magnitude of E. So all I want is the magnitude of the fault current. So during fault, this will be total short circuited, right? Now your, like your fault current would be your EG that was computed upon the, because fault they have not mentioned anything regarding the fault impedance, so it will be magnitude of XS, right? Double dash. This will be double dash because they have asked the initial symmetrical current. Here double dash will be there. Here actually only no dash will be there. Simple XS will be there because this is not the subtransient uh, computation. But nothing is mentioned, so you will assume both of them to be equal. So yeah, just a big difference. So this will be this upon subtransient, that is 0.1, that is coming out to be 10.63 pu. Okay, so 10.63 pu will be your answer for the question. The rotor of a three-phase induction motor has 0.04 ohm resistance per phase and 0.2 standstill reactance, right? X2S is equals to 0.2 standstill reactance, and per phase resistance R2 is 0.04 ohms. What external resistance is required in the circuit in order to get half the maximum torque at starting, right? So at starting we want half the maximum torque, then what is the amount of resistance that needs to be connected? So we know our starting torque and our maximum torque are related by this relation, that is 2 upon sm plus 1 by sm, right? So how to remember this relation? So you know your starting torque always will be higher, right? So this will be 2. Sorry, your starting torque always will not be higher. Starting your maximum torque is the highest torque that you will get, right? So what happens here is your maximum torque is the higher value, right? So your sm, right, if it's a if it's a, if it is 0.9, so sm would be 0.9 or zero point 0.8, something like that, right? So if it is 0.9, what will be the denominator? It will be 0.9 plus 1.11, something like this, right? So this will be actually 2.111. So you see your maximum torque is greater, like the denominator is greater than the numerator, certainly your tm will be greater. That's how you can verify the formula where is each thing will come. So you have to remember this 2 will come at the numerator, and it's simple, right? Sm plus 1 by sm in the denominator. So yeah, they're telling me that this, right, starting torque will be the starting torque will be half of the maximum torque. So it will be 1 by 2 tm upon tm. So basically, technically what happens, your sm plus 1 by sm is equals to 4. So your sm square plus 1 equals to 4 sm. So your sm square minus 4 sm plus 1 equals to 0, right? So from this you can actually get the maximum slip value, and if you know the maximum slip value, you will be able to compute the what do you call, you will be able to compute the R2 value that you need to connect in series. I will explain just in a second. So what will be the sm will be equals to, if I solve the quadratic, this will be minus b plus minus b square minus 4ac upon 2a. So this will be 4 plus minus 2 root 3 upon 2. Yes, this will be actually equals to 2 plus minus root 3. So of course I will not choose the higher term, I will choose the negative, because slip will not be greater than 1, slip will be less than 1. So if I choose the negative value, right, so that will be approximately 0.7, 0.27, right? 1.73 I will subtract from 2, that will be approximately 0.27. This, right, is the maximum slip, and this shall be equals to my R2 upon X2, the standstill reactance, right? Now R2 is currently 0.04, so we will need to add some resistance, let's say R, to make this ratio proper. So this will be R2 plus R by X2, that will be equals to, so X2 is how much? X2 is 0.2, right? So 0.27 into 0.2 minus of R2, R2 is 0.04. This will be the additional resistance that you need to connect. This concept has been already taught. So 0.27 into 0.2 minus 0.04, that is actually your R. Your R is actually equals to 0.014 ohms. And this will be your answer of the question. A three-phase alternator with 16 poles. So it's a three-phase alternator, 6 poles are 16. It is star connected. Winding has slots to be 144, each containing 10 conductors, right? So 10 slots, conductors per slot is 10. So overall how many conductors I have? Z is equals to 144 into 10. So these are the number of conductors, and we know each conductor has 2 turns. Sorry, I have this conductor, right? So what does it mean? So each conductor, this is one conductor, so one conductor actually has two conductors has one turns, right? Two conductors form one turn. So basically a single turn would be equals to two conductors, right? So your number of conductors will be equals to 2t, because a single turn would be equals to two conductors. Okay, that's how I remember this formula. So from this I can actually totally calculate how many total number of turns I have. Turns would be number of conductors by 2, that is 720. These are the total number of turns, that is equals to n. Okay, yeah. It is sinusoidally distributed. Flux per pole phi m is 0.04 Weber. Determine the line voltage. What will be the line voltage, right? So they have not talked about anything regarding the pitch factor, right? So the pitch, I will assume it to be a full pitch coil, so I will assume Kp to be 1, because I will assume alpha to be 0 degree. I hope you remember this formulas. So alpha is 0, but certainly we can compute the distribution factor, that is Kd. What is Kd? Kd is sine m beta by 2 upon m sine beta by 2, right? So what is beta? Beta is equals to pi upon slots per pole, right? Or in angle it will be 180 upon slots per pole. How many slots I have? 144. How many poles I have? 16. I have 16 poles, so 16, right? So this will be my beta. So this will be actually 16, this into 9, so your beta is 20 degrees, right? And what is your m? M is slots per pole per phase, right? How many phase I have? 3. So this will be 9 divided by 3, that is 3 itself. So m is 3. Okay, so your distribution factor Kd would be sine into 3 into 20 upon 2 upon 3 sine 20 upon 2, right? So what will be the answer here? Sine 30 is half, divided by 3 divided by 10 sine of 10, so that is 0.959, that is 0.96. So your voltage, right? What have they asked? They have asked me the line voltage. So this is the phase voltage. Phase voltage is equals to uh, root 2 pi f number of turns into phi into Kp into Kd, right? Kp pitch factor is 1, so this will be root 2 into 5, so that is actually 4.44. Root into pi is 4.44. F frequency is 50 hertz, I assume. Okay, they should actually, it is not mentioned, but frequency should be mentioned. Okay, I will mention it in the question. Frequency is 50 hertz. I think we forgot to mention it. Into the number of turns. Number of turns we have computed it to be 720. Into the flux. Flux is 0.04. Kd is already multiplied, so it comes out to be 6136. This is in the this is okay. One more small mistake, right? So these are the total number of turns. I have just made one small mistake. These are total number of turns. So what is turns per phase? Because in the formula it should be turns per phase, right? Turns per phase, because I have 3 phases, it will be 720 upon 3. Just a small mistake on my behalf. It would be 720 by 3, that is 240, right? Don't mess this up. So it will be turns per phase. It will not be just turns, and this will be flux per pole, right? So this actually will not be correct. This is correct. 2045.51 volts. Now this is the phase voltage. The line voltage would be, because it is a star connected system, so root 3 into E phase, so that is equals to 3543 volts. Okay, so your line voltage is 3543 volts, that is present in option C. So option C is the correct answer for this question. A 250 volt DC series motor runs at 1000 rpm, delivers an output power of 5 HP and draws a current of 20 amperes when its field winding sections are connected in series. So we have a DC series motor, uh, and the it is a 250 volt DC series motor, right? It will have a series winding and it will have armature resistance, and this then it will have the armature, right? Hmm. The armature resistance is 1.1 ohm. The motor has two identical field widening sections, each having resistance of 0.4 ohm. Okay, and the field winding sections are connected in series. So overall current condition is, if both of them are connected in series, it will total give me a resistance of 0.8 ohms. If the field winding sections are reconnected in in parallel, the motor is required to deliver the same output power. The motor, okay, if now it is required that they will operate in parallel, the motor is required to deliver the same output power. Determine the current drawn by the motor. Okay. Interesting. So what was the output power that the motor was previously delivering? Remember, the motor always delivers this power, right? EB into IA. Okay. So in this case, it is 250 volt, right? So the terminal voltage is 250, that is fixed. Okay. And it runs at 1000 rpm and draws a current of 20 amperes. So what is EB? IA is 20. What is EB? EB would be VT, that is 250, minus IA. IA is 20 into the overall resistance, right? 0.8 plus 1.2, that is 1.9. So this would be equals to 20 into 0.9 plus 250 to 32 volts. That is my EB. So this is the previous power. EB into IA would be the previous power. You can certainly multiply these two. That is fine. Now what they have told you that this power must be same. So what is EB into IA in the first case? 232 into IA, that is 20. This will be equals to EB2 into IA2. So EB2 is what? EB2 is actually, if both of the coils are connected in parallel, then the overall resistance, this 1.1, would be 1.3 ohms now. So EB2 would be, the terminal voltage is same, that is 250. So it would be 250 minus 1.3 into IA2, and obviously IA2 is still there. This power must be same. So from this we will get a quadratic equation. So this will be, just let me solve this into 20. That would be 46. This would be 4640. That is equals to 250 IA2 minus 1.3 IA2 whole square. This will be equals to IA2 whole square minus 250. Okay, 250 divided by 1.3, right? Okay, let me keep it as it is. 1.3 whole square minus 250 IA2 plus 4640 equals to 0, right? So this will be equals to b square 250 square minus 4ac 4 into 4640 whole under root. So this comes out to be plus minus 209.62, and b square is 250, sorry, minus b, right? So this will be 250 only. 250 upon 2 into a, that is 1.3. A is 1.3. Now certainly, if you see your current, all the options, right, are in the range of 20. So of course you will ignore the positive solution, you will take the negative solution. If you choose the positive, the current will be very high. That is not possible. So 250 minus 209.62 upon 2 upon 1.3. So your current, right, IA2 comes out to be, your current IA2 comes out to be 15.53 amperes. This is the current 15.53 amperes. So approximately, okay, am I doing everything correct? I'll just check once. B square, okay, sorry, B square minus 4AC, right? Sorry, 4AC. This under root is wrong. 1.3 plus 250 whole square. Sorry, the under root that I've taken is wrong. This is actually B square minus 4AC. This is actually 237. Okay, which is even smaller. Give me 1 second now. B square minus 4AC. Oh, sorry, 2 into B. So minus B plus minus B square minus 4AC by 2A. So 250 plus minus B square minus 4AC. Just give me 1 second. B square minus 4 into A into C 4640. Hold on a second. This is correct. 4640 is correct. Everything is correct. What am I doing wrong? 250. This is correct only, right? I'm just thinking like you said, because I've solved it previously. I was getting some other answer. Yep, I'm doing everything correctly. This is 250. The terminal voltage minus 1.3. Yes. 2 square. Hold on a second. Okay. It seems like I have made a small error. That is, yeah, because I've calculated it previously. So 1.9 into 20. Just a small error here. The voltage that I calculated, it is supposed to be 212. Okay, there was a small error here. This will be 212. So things will change into 20. This will be 4240. Yeah, that's what was different. 4240. So this will be B square 4240 whole square minus 4 into A into C. Sorry, 250 whole square minus 4 into A into C under root. So this will be actually 201.12. This I will obviously again take the negative solution. This divided by 2 divided by 1.3. Yeah, now it is correct. It is coming out to be 18.8 amperes, which is present in option like almost approximately equals to option B. So option B will be correct answer. Okay, this is wrong. Just a bit of calculation error from my behalf. A separately excited DC motor rating of this with armature resistance this is powered through a single phase fully controlled bridge rectifier. Assuming the load current is continuous, determine the motor's speed in radian per second rounded off to 2 decimal places when the firing angle is 30 degrees and the developed torque is 5 Newton meter. So we know that this formula for a DC motor, that the back EMF into the current armature current is equals to the developed power, that is equals to the developed torque into the speed of the motor. So they are asking me to determine the speed of the motor. So I need to calculate this value. So they have given me the developed torque, and all I need to calculate is EB and IA. So it is a full wave rectifier, right? It is a fully controlled bridge rectifier. It is a bridge rectifier, fully controlled bridge rectifier with firing angle to be 30 degrees. So basically I have a rectifier and I have a RL E load, right? RL E load, and the load current is continuous. So if the load current is continuous, do remember what was the expression of output voltage for a fully controlled rectifier? So this was the output voltage waveform. If you remember, as the load current is continuous, still the previous diodes will be turned on. So the output voltage would be somewhat like this. It will start from here, it will be 0, and again it will start from here, it will be 0. So how this comes, all this derivation has been done in the our playlist itself. I have completely taught rectifiers for free on our power electronics playlist. There you can watch how this waveform is formed, right? You can go and watch that. So the average waveform you can derive as well, no problems. Average value of this waveform would be VO average would be equals to 2Vm upon pi into cos alpha. This will be equals to my VO average. You can derive this expression, right? You can simply integrate from alpha to pi plus alpha, alpha to pi plus alpha. of Vm sin omega t, sin omega d omega t, right? And you will get the same expression upon pi. You will get the same expression. So this is my average value. So average value would be equals to what? 2 into Vm. What is Vm? So the supply voltage is given 250 RMS. So Vm would be 250 into root 2 upon pi into cos alpha. Cos alpha, alpha is given as 30 degrees, right? Alpha is given as 30 degrees, so cos of 30. So this would be 500 into root 2 upon pi into 30 cos of 30, that is equals to 194.92 volts, right? That is the average output voltage. Now what will be your current? Have they given us the armature resistance? Yes, armature resistance is given. So what would be your current, right? So your current would be, okay, I don't know what is my EB. I don't know what is my back EMF. Oh, okay, 10 ampere. So it is a separately excited motor. If it is a separately excited motor, its flux is constant. Now we know this thing, right? Basically the back EMF would be proportional to what? Back EMF is proportional to speed into the flux. So flux is constant, speed is changing. So your back EMF is proportional to the speed. Your back EMF is proportional to the speed. Okay. Now how do I compute the back EMF in the second case 2? How do I compute the back EMF in the case 2? Developed torque is 5 Newton meter, firing angle is 30. Hmm. So do you know what is the developed torque in this case? Yes, we know what is the developed torque in this case. It will be EB into IA. So okay, in this case the rating of the motor is 220. Okay, this in this case also we don't know actually. Because VT is given, IA is given. We can actually know. Oh, so in this case what is EB? In this case what is EB? EB is VT, the terminal voltage, minus IA into RA, that is 210 volts. So 220 minus IA, the rated current, into the armature resistance. So it is 210 volts. So what is the speed here? The speed is 1500 rpm. The speed is 1500 rpm. So for 1500 rpm speed, the back EMF voltage is 210 volts. Correct. So what I can write my EB, but that will not help me because there are a lot of constants here. So let's say for speed equals to 1500 rpm, EB1, the EB1 was 210 volts. EB2 would be equals to N2, right? The back EMF in the second case would be equals to, it would be proportional to N2 because your back EMF is proportional to speed. And we know basically our speed is proportional to omega. We know that, like both are almost same. So okay, yeah, this will be helpful. So what I can comment is what is my EB2 upon N2. EB2 upon N2 would be 21 upon 150. That is what my EB2 upon N2 is equals to, right? But will that help me? That will help me actually, yeah. So EB2 upon N2 is 21 upon 150. So I can replace that over here. So what is omega? Omega is 2 pi N2 by 60, right? Where N2 is in revolutions per minute. I hope you know all these things. Omega is basically radians per second. So this will be EB upon N2 would be equals to developed torque, that is 5 upon the current, armature current, into 2 pi by 60, right? So EB upon N2, EB2 upon N2, right? This is the second case, that is given 21 upon 150. So this will be 21 upon 150 is equals to 5 upon Ia into 2 pi, that is pi upon 30. So this will be basically 5, right? So Ia is equals to 25 pi by 21, right? 25 into pi divided by 21. So your Ia current comes out to be, average armature current comes out to be 3.74 amperes. What are they asking? They are asking me the speed, right? So if I know Ia, can I compute Ia? This is the Ia2, right? Ia2. Can I compute EB2? Yes, you can. Yes, you can compute EB2, because EB2 would be equals to that voltage, terminal voltage 194.92 minus Ia into Ra, that is 10, right? Ra is 10 ohm, sorry, 1 ohms. Ra is 1 ohms. So minus 1. So this will be equals to plus 194.92. So this is equals to 191.18 volts. This is my EB2. If this is my EB2, certainly I can know what is my N2, right? Because EB2 upon N2 is equals to 21 upon 150. So N2 I can calculate from this particular equation, that is EB2 into 150 upon 21. So N2 comes out to be 1365.57 RPM. What about your omega? Omega would be 2 pi n upon 60, right? So 2 into pi upon 60. So omega, what in, okay, determine the motor speed in radian per second. They have asked in radian per second, okay? They have not asked in revolution per minute. So it will be 143. 143 radian per second would be your answer for the question. This question is actually pretty good. This question is very good, because here there are a lot of things that are involved, okay? So DC machines, concept of DC machine is also involved, and obviously concept of rectifiers is also involved. So 143 radian per second would be your answer for this question. An ideal switch S is operated at 100 kilohertz with a duty ratio of 60% if the peak to peak ripple current of the capacitor is 2 amperes, right? And the ripple free load current, right, basically your IO average is 10 amperes. Choose the correct option. The average current through the source is 6 amperes, right? The average current through the source is 6 amperes. Let me reduce the thickness a bit. Yeah. And so we have to compute all this. So first of all, what do you observe? This is the circuit of a step down chopper. If you forget, right, always derive. Nothing is mentioned. You will assume your current across the inductor to be continuous, right? You will assume your current across the inductor to be continuous. So what is the voltage when the switch is closed? When the switch is closed, your voltage across the inductor VL would be equal to this Vs minus Vo, okay? And your current through the load is ripple free. That means your voltage is also almost constant, right? Voltage also is almost constant. So basically your VL graph would be something like this. It will be 50 minus VO when the switch is on, and as soon as the switch will be closed, let's say at alpha the switch is closed, right, because the duty ratio is 60%. Then what will be the voltage? Then the diode will be turned on, and if the diode is turned on, your VL will be simply equals to minus of VO. VL would be simply equals to minus of VO, and this cycle will repeat. So of course, if the inductor current is continuous, we know the average area throughout the inductor voltage graph will be 0, right? So basically what will happen, 50 minus VO into alpha into T would be equals to VO into 1 minus alpha into T. If you solve this, you will get your VO would be equals to alpha into 50, that will be 30 volts. So your VO comes out to be 30 volts. Okay, your VO value comes out to be 30 volts. Now the average, so let's first try to solve this, the value of the input power. So if I know VO is 30 and I have been given the IO average, what is IO average? IO average is 10 amperes. So what is the PO? PO is 300 watts. It is VO average into IO average. Now there are no loss making components. It is a simple LC filter. This is also ideal diode. So whatever is the input power, that is 50 into IS average, that will be equal to the output power, that is 300. So anyways, I see input power, value of the input power would be 300, not 160. So this option is wrong. So what is IS average from here? IS average would be equals to 6 amperes. So the first option, the average current through the source is 6 amperes, that is absolutely correct. The average current through the diode is 10 amperes. This is absolutely wrong. Why? Because at first glance you can see your diode current, right? Your diode will be on for certain duration of the load, and during that duration the current is 10 amperes. Again the diode is turned off. So then the source is delivering. So diode current anyways is not even 10 amperes for half the duration. So how can it be equals to 10 amperes? How can the average current be 10 amperes? Not possible, right? So but we can obviously derive it. How can I derive? So if I write a KCL at this particular node, right? So your IS plus ID would be equals to your IL, right? And your IL average, so IL is equals to IC plus IO, and we know whatever ripple current there will be, all of that ripple current will be consumed by the capacitor. But on average, the capacitor current will be zero because the voltage is constant. So if I take the average on both sides, your IL average will be equals to your IO average, right? So your, if I take the average on this equation as well on both sides, your IS average plus ID average equals to IL average. IL average is simply 10, right? That is equals to IO average. So IS average is 6. So your ID average would be equals to 4 amperes. So ID average would be 4, not 10 amperes. Last option, the peak value of the inductor current is 11 amperes. So we know our inductor current, this I have already taught in the full course, in the videos, lectures, in RPOIQ, everywhere. All these things has been taught, that this will be the behavior of the inductor current, right? And this will be the average current, and this will be the peak current, IL max. So this thing has been derived in the full course as well, that your IL max will be equals to IL average plus delta IL divided by 2. So IL average is 10 amperes plus delta IL is 2. The ripple in the load current is 2, right? Inductor current is 2. 2 upon 2, that is 11 amperes. So this option is again correct, that the peak value of the inductor current will be 11 amperes. So option A and D are correct for this question. The design specifications for a PD compensated marginally stable system are the following. So the damping ratio of the system must be this, the steady state error for a unit step input must be this, must be less than this. The values of lambda mu that satisfy this requirement, assuming that controller transfer function is this, basically it is a PD controller, and the planned transfer function is this, assuming the system to operate in unity negative feedback. Okay. So for unity negative feedback, what is the OLTF, overall open loop transfer function? That will be GP of S into GC of S, that is basically equals to 4, sorry, this will change, basically this will be 4 into lambda plus mu S upon S square plus 4. Okay, I think there is a typo here. This will be not there, right? Yeah. So overall your controller, overall your OLTF would be this. Okay. Now for this particular thing, what is the steady state error? How can I find out the steady state error? So for a, so what is the transfer function? T of S. T of S would be G upon 1 plus GS, that is 4 lambda plus mu S upon S square plus 4 plus 4 lambda plus 4 mu S. Yeah, that's it. Right, this is my transfer function basically. Correct. So now what I can do is, what is the error? Do you remember? E of s, it is r of s minus t of c of s, right? So if I take r of s common, this will be basically 1 minus t of s. Okay, and then again I can simply find out the steady state error. That will be, for a unit step, it will be s into limit s tending to 0, s into 1 by s into 1 minus this. So that would be basically this will be cancelled. It will be s square plus 4 upon s square plus 4 plus 4 lambda plus 4 mu s. Okay, so this will be 4 upon 4 lambda, sorry, 4 upon 1 plus lambda, okay, equals to, now this has to be less than my 0.1, correct? This has to be less than my 0.1, right? Steady state error must be less than 0.1. So from here I can get lambda has to be greater than or equals to 9. Okay, lambda has to be greater than or equals to 9. So this is like one of the condition, lambda has to be greater than or equals to 9. What about the other condition? That my zeta of the system must be 1 by root 2, less than 1 by root 2. What is zeta? So transfer function is this, right? So from this I can compare the characteristics equation, that is my omega n square would be 4 mu, correct? Omega n square would be 4 mu. Am I correct? No, omega n square would not be 4 mu. Sorry. Sorry. Hold on a second. So my lambda is this, right? Lambda has to be greater than 9. Actually they are asking like uh, what are the values that satisfy this requirement. So if I choose lambda equals to 9, if I choose lambda equals to 9, right, because lambda equals to 9 will satisfy the requirement. If I choose lambda equals to 9, then my characteristics equation is s square plus 4 mu s plus 40 equal to 0. So from this I can say what is my omega n. Omega n would be under root of 40. So my zeta, 2 zeta omega n would be 4 mu. Okay, 2 zeta omega n would be 4 mu. So my zeta would be 4 mu. Okay, now zeta value is given, the limiting value of zeta is 1 by root 2, right? So this will be 2 into 1 by root 2 into under root 40 equals to 4 mu, correct? So this is 2, this 2 will go away, this will be under root 20 by 2, under root 20 by 2, am I correct? So this will be under root 5. Yeah, so your mu will come out to be under root 5. So under root 5 will be your under root 5 will be the value for which both these conditions will be satisfied. So option D will be your correct answer for this question. The OLTF g of h of s from the border plot is this. Okay, there is a OLTF, magnitude plot is given basically. Then like, okay, what will be the, like, basically what will be my g of h of s, right? So I see initially I have a slope of minus 20 dB per decade. So of course it is a type 1 system, right? So I see, yeah, all these are automatically gone. All these are automatically gone, right? So of course option 1 will be correct. Okay, what I will do is I will modify one of the options so that this also is s. Okay, otherwise like this question will be very very simple. At least I want you to do something, right? So I will modify the options. So yeah, let's now do other things. So I see that I have a change in slope at omega equals to 2. So and the slope, change in slope is positive, so I have a 0 at 2. Okay, that is one thing. I have another 0 at 10. So 1 plus s by 10, because the slope is again increasing. And then again finally I have a pole at s equals to 50. So this will be 1 plus s by 50. Okay, into obviously s, because it is a type 1 system. Now what about this gain k? I am interested in this gain k. Yeah, okay. So what I can say is, when it is much smaller, have they provided us, so it is 0 dB when is it 0 dB? That is what I am interested in. So they have not provided any values, right? Okay, because they need to provide the values, otherwise how will I find it? Okay, so at s equals to very high value, they should have provided something. So I will do one thing, I will provide this value very high, right? Actually your answer would be k will be equals to 1, basically k will be 1. So I will provide this magnitude. Okay, at very high, what is the magnitude? Basically very high value. So this, right, at very high value, so what will happen, the terms with s will dominate, because when s is tending to infinity, this will be very low compared to this. So let's say s is 500, this will be 500 j, like s equals to 500 j omega, sorry, j 500, then this will be very dominating, right? The imaginary part will be very dominating. So approximately all these can be cancelled, all this can like only the terms with coefficient of s will be taken. So this will be k s by 2 into s by 10 by s into s by 50. Okay, and this should come out to be equals to 1. Sorry, this will not come out to be equals to 1. What will be this value? Because ultimately, yeah, at high frequencies, at high frequency the gain should be what? Here, what is the gain at high frequency? This will be 0.5 into 0.1 upon 0.02, that is 1 by 50 basically, correct? That is equals to 1. Sorry, it is not equals to 1, it is equals to 1 by 50. So this is 1 by 2, 1 by 10, 1 by 50. So yeah, this 5 will go, this will be 5 by 2. So at high frequency the gain is 2.5 basically. Here if I put the gain to be 2.5, then this k value would be 1 basically. Okay, so I'll change the question. I'll make the gain to be at high frequency 2.5. So if I make the gain at high frequency to be 2.5, then what will happen? Then, like, there was a typo here, this should have been, like, I forgot to put this 2.5 here, like in dBs. I'll put the value in dBs. So what will happen at high frequency, only these terms will dominate. Why? Because if I assume my s to be, let's say, 500, right? Like my s to be j500, right? Because it is frequency, we're varying the frequency. Then the imaginary part will be very high. This will be j250 plus 1, which will be very large, right? Okay, all these will be very large compared to this real part. So that's why I can neglect the real part, I can only consider the imaginary part. Okay, so at high frequency the gain will be 2.5. So from this, like, you can again verify what will happen. This will be 1 by 20, 2.5, k will come out to be 1. Okay, so high frequency gain will be 2.5. From that you can get the value of k, like, although I solved. So basically what will happen, the high frequency gain would be this given, right? This will be given, you will compare, these things will cancel, s will be cancelled, this thing will cancel, and ultimately your k value will come out to be 1. So this will be your answer for the question.
Yeah, let's see this question. Sir, I saw this particular question, but I felt that this is incomplete. You have given incomplete information. Is that so? Let's check that out. Sir, you did not even mention about ROC. So let's see why I did not mention about ROC. Because there is something interesting in this particular form. Z to the power 6, Z minus 2. Where are the poles? Poles. Z equals to 2 is a pole. Sir, if I put Z equals to 2 here, that is a pole? No. If you put Z equals to 2, H of Z at Z equals to 2, what you are getting? So 2 to the power 7 minus 2 to the power 7, that would be 0. 2 here, 2 minus 2, that would also be 0, indeterminate form. What does that mean? I need to apply L'Hopital rule. How would I apply L'Hopital rule? So what I would do is that upper side and downward side differentiated. What I am doing, limit Z tending to 2, limit Z tending to 2, upper side and downward side differentiated. So let's open it up so that I can do the derivation, I can do the differentiation in an easier manner. So this will become Z to the power 7 minus 2 Z to the power 6. So if I differentiate it, 7 Z to the power 6 minus 12 Z to the power 5. Now put 2 here. This will become 2 to the power 6. Just you put here, you can get to know that it is not coming out to be infinity for sure. Say yes or no. Right? You put 2 here, some value you will get. You put 2 here, 2 to the power 6 into 7, 2 to the power 5 into 12. Both are not equal. This is not coming out to be 0. That means it is not coming out to be infinity. What does that mean? Not a pole. It is not a pole. Now this was pretty obvious. Now two things are there. I will check at 0 and infinity. At infinity, if I see what will happen at infinity, this guy will be very large than this one. So this particular part will be gone, and this guy will also be very large. So at infinity, what will be the value of h of z at z tending to infinity? That would come out to be 1. You can see pretty obvious, no? Z minus 2 could be reduced as z only, because z would be much larger than 2. So it would become z to the power 7. Upper side will also become z to the power 7. Both will get cancelled out. At infinity, it will throw the value to be 1. So h of z at z equals to infinity is 1. That means not a pole. What does that mean? Z equals to 0 is a pole? Yes. Put 0 here. 0 minus 2. Minus 2. 0. 0 into anything? 0. 0 minus 2 to the power 7, that would be minus 2 to the power 7. So minus 2 to the power 7 divided by 0. What that would be? Minus infinity. That means there is only one pole, that is z equals to 0. So in this particular system, there is only one pole, that is nothing but z equals to 0. Only one pole is there. So if I draw the pole 0 diagram, sorry, not 0, I only need to care about the poles. So I am having only one pole, that is at z equals to 0. So there is only one ROC that is possible, no? That has to be outer of the z equals to 0 circle. Now just let me know what kind of signal it is. Causal. ROC is entire z plane except z equals to 0. What does that mean? The signal has to be finite duration and finite amplitude. That means finite duration. What is the meaning of finite duration? That means in the impulse response, like when I find out h of n, there will be, like, signal could be somewhat like this, and it is having some impulses like this. So it will be finite duration. So there will be only finite impulse responses. So it will be a FIR filter, not IIR filter, not non-causal. Only one pole was there. ROC was z greater than 0. ROC is entire z plane. If it is entire z plane, put except z equals to 0 or z equals to infinity, then it has to be a finite duration signal. If it is a finite duration signal, that means it is a FIR filter. Someone would say that, sir, filters are not there in the syllabus. DTFS they have mentioned, DTFT they have mentioned, Z transform they have mentioned everything about the discrete time. Continuously they are asking question on LTI system. Why cannot they ask a question on LTI system in discrete time? Surely digital filter is there in your syllabus. It's just that they are specifically not mentioning it. Surely the question can come. And even if someone doesn't know the meaning of FIR, I have simply put it. What is the meaning of FIR filter? The impulse responses is non-zero only for a finite number of samples. So impulse responses will be non-zero only for a finite number of samples. So if someone doesn't know what is FIR or IIR, still he would be able to solve it. In 2024, the question was asked on minimum phase system, maximum phase system from discrete time. So that's the concept of a digital filter only. So question would come. Okay, even the filter design question can also come, although that is very, very rare. But these kind of questions, that what is FIR filter, IIR filter, when you get into the industry, nothing would work without FIR and IIR. Okay, so these things, basic things you should know from the digital filter, at least very basic. Designing part very difficult, like that is a separate task. If they wanted to ask something from designing part, then they would have mentioned it. But at least these much things you should know. Okay, then, like from the how they are interrelated with the concept of ROC, how they are interrelated with Z transform. So all these things you should know. Let's go to the next one. So this question also, I know you are watching the solution and a lot of guys have messed it up, right? What you guys said? Sir, frequency of oscillations would become omega naught. Okay, frequency of oscillations, you can say, I should not say frequency of oscillations, like fundamental frequency is omega naught. Frequency of oscillation also you can say. So x of n is, sir, coming out to be 3 plus 2 sine omega naught n plus 3 cos 2 omega naught n. This is what you did, but this is wrong. That's why I am telling it. Okay. So what you did is that 2 e to the power j omega naught n minus e to the power minus j omega naught n divided by 2j plus 3 e to the power 2 omega naught n plus e to the power j 2 omega naught n minus 2j omega naught n divided by 2. So, sir, from here I know that C naught is coming out to be 3. Sir, C1 is coming out to be 1 by j. C2 is coming out to be minus 1 by j. Sorry, not C2, C of minus 1. C of minus 1. And then, sir, C2 is coming out to be 1.5 and C of minus 2 is coming out to be 1.5. You ask the value of C2, sir, answer is 1.5. Wrong. Okay, why wrong? Just notice one particular thing. What is that time period here? 2 pi by n. sorry, what is the time period? That is n. What is the time period here? 2 pi by omega naught. Omega naught, you are saying that is 2 pi by 3. So your time period is 3. You know one thing, C of k would be equals to C of k plus n. Find out the value of C of minus 1. That should be equals to C of minus 1 plus 3. Value of n is 3. That means according to you, according to the very good property, that C of minus 1 should be equals to C of 2. This is what you know, right? But is it equal? C of minus 1, C of 2, are both of them equal? This is minus 1 by j, or you can put it as plus j as well. Let's put it as minus j, this as plus j. This is your minus j, this is your plus j. So are they equal? No. So are we doing something wrong? Yes, we are doing something wrong. What we are doing wrong, that I will tell you. But how to write down the answer? You would see that, sir, C of minus 1 is equal to C of 2. Then actually, yes, they are equal. But they are equal to the summation of whatever that you are getting. That would be equal to 1.5 plus j. So this would be the answer. Now, sir, why they are equal to the summation? Let's check that out. This frequency, 4 pi by 3n. Can I write it down in this manner? 2n pi minus 2 pi by 3n. Basically, this x of n could be written as this x of n could be written as 3 plus 2 sine 2 pi by 3n plus 3 cos 4 pi by 3n. What that is? 2n pi minus 2n pi minus n pi by 3. Or sorry, 2n pi by 3. 2n pi minus 2n pi by 3. Right? Now you put the value of n equals to 1, 2, 3, whatever you put, this value will come out to be cos 2n pi by 3 only. Always. Always. No matter whatever the value of n you put. You put n equals to 0, what you will be getting? 2 pi by 3. Here you put n equals to 0, like better I should say, yeah, whatever you take. You put n equals to 1, what you will say? 2 pi minus 2n pi by 3. 2 pi by 3 again. You put n equals to 2, 4 pi minus 2n pi by 3. Again 2n pi by 3. Are you able to understand this point? 2n pi. It is already periodic with 2 pi, no? Say yes or no? And it is going in the fourth quadrant. In fourth quadrant, cos is positive. So this value will always come out to be cos 2n pi by 3. What does that mean? Your x of n expression, actually it was 3 plus 2 sine 2 pi by 3n plus 3 cos 2 pi by 3n. There you go. This was the scenario actually. So yes, it was omega naught. There is no doubt. This was also omega naught. But they were same frequency. They were of the same frequency. They were having the same frequency. This was the problem. Again, it is very tough to determine. Like, sir, blindly, how would you know that, sir, it is 4 pi by 3n? Sir, you have set up the question, that's why you know. Yes, I have set up the problem, that's why I know. But I will always solve in this manner. Then I will surely check that this is the property, no? This is the property. Then I will check that who knows the frequencies are same. This is not 2 omega naught, this is actually omega naught only. So for checking it up, what I will do? I will do this particular process. That I will see the value C of k would be equal to C of k plus n. I will find out the value. Then I would say that C of k would be equal to C of k plus 3. Then I will go to this guy. C of 0 should be equal to C of 3. C of 3 is not existing here, no issue. Then I will go to this guy. C of 1 should be equal to C of 4. C of 1 is here. C of 4 is here. No. Then I will go to C of minus 1. C of minus 1 would be equal to C of minus 1 plus 3. That means it should be equal to C of minus C of minus 1 should be equal to C of 2. That means, yeah, those guys are same. This is something I will get to know. Is that understandable to you? Then I would go to C of 1 again. C of 1, 1 minus 3 as well, no, because it is plus minus n. It is periodic. Then ahead 3, backward 3 as well. So C of 1 should be equal to C of 1 minus 3. That means C of 1 should be equal to C of minus 2. That means this guy and this guy is also same. That means C of 1 has to be equal to 1.5 minus j. This is the value of C of 1. Now they can ask you the value of C of 4, it would be same. They can ask you the value of 3 more, C of 7, it would be same. They can ask you the value of C of 1 already there, C of minus 2, this would be the same. Is that understandable to you? So C of minus 2 is not 1.5, it is 1.5 minus j. Is that understandable or not? A very good concept. Nowhere I have seen that this concept is taught. Everywhere they match it up. Even the educators have matched up this particular concept. Okay, so these frequencies are actually same. When you solve it, what you would see? E to the power j omega naught n. From here I am directly writing down the value. C of 0 is coming out to be 3. C of 1 would will come out to be 2 by 2j. And from here as well something would come out to be, that is 3 by 2. What about C of minus 1? From here it will come out to be minus 2 by 2j, and from here it will come out to be 3 by 2. So this is 1.5 plus j, this is 1.5 minus j. This is your C of 1, this is your C of minus 1, and this is your C of 3. There you go. Okay, a very good concept. When you study discrete time, always study in a good manner, because from the discrete time either the question will not come. If it is coming, then it will be a good question. Okay, it will be a rank deciding question. If you are someone targeting under 50 rank, then it will decide your rank. Okay, then let's go to the next one. Yeah, that's also a good question. So here first what we need to do is that we need to talk about xt. So let's draw the xt waveform, then we will talk about yt as well. So this is our xt waveform, which is a triangular signal, which is pretty obvious here as well. I can see that it is nothing but a triangular signal. Starting at t equals to 0, it will throw the value 1. At t equals to t by 4, it will throw the value 0, and here also it will throw the value 0 at minus t by 4. Okay, that's the scenario. This is your xt, right? T equals to 0, throwing the value 1, and then 0 0. Right, now what they are saying is that yt is a xt convolution with the delta of t minus kt. What does that mean? This value was minus t by 4, this value was t by 4. That means what you are doing is that you are making this periodic with the time period of t. Basically, how you can write down yt? Yt is nothing but xt convolution with, can you simply open it up? Delta of t minus, put k equals to minus 1, t plus t. Put k equals to 0, delta of t. Put k equals to 1, delta of t minus t, and so on. So what you will be getting, yt is nothing but x of t, like going in this manner. X of t convolved with delta of t plus t. What that would be? T plus t. X of t convolved with delta t. X of t convolved with delta of t minus t, and so on. So x of t is there, then center moved to capital T, and so on, right? So what will be your yt? This is minus t by 4, this is t by 4, center 1, then center moved to t. T minus t by 4, what that would be? 3t by 4, 5t by 4, and so on. Similarly here as well. Center move to minus t. So minus t plus t by 4, that would be minus 3t by 4 minus 5t by 4. Okay, this is your yt. Is that understandable to you? Periodic waveform, nothing else. So this is just another way of representing a periodic waveform. I could have simply given the waveform of yt, right? But what I did is that I gave the waveform of xt, then I asked you to make yt. Now what is the scenario? Average value of xt is 0. Is that so? Yes. What is xt? Xt is an energy signal. If it is an energy signal, that means its average value will be 0 only. So average value of xt is nothing but average of this is 0. So the first statement is correct. Average value of yt is 0.25. Let's calculate the average value of yt. What that would be? I need to calculate its area and divide it by the time period. So what will be the average? What is the area? Area is nothing but 2t by 4 divided, area. First I need to find out the area. Area is, this is triangular, no? So area I need to find out. What that would be? Half into base. What is the base? 2t by 4 into height, that is 1, divided by the time period. What answer you are getting? 0.25. So that is the average value you are getting. So option B is also correct. Both xt and yt are even signal. This is even. Yes sir. This is also even. Yes sir. So both are even signal as well. So this is also correct. Now in the frequency component of yt, all the even harmonics are absent except the DC value. Surely DC value is already non-zero. Even harmonics are absent. When the even harmonics will be absent? If it is half wave symmetry or hidden half wave symmetry. Is it half wave symmetry or hidden half wave symmetry? What do you mean by hidden half wave symmetry? You subtract the DC value. If I subtract the DC value, what I will be getting? this kind of waveform I will be getting if I subtract the DC value. Basically, whole graph will be shifted by 1 by 4. That means this value will become 3 by 4, this value will become minus 1 by 4. The scenario says that whatever the value that you are getting at 0 plus, the same value you need to get at t by 2 plus as well. For half wave symmetry, this is the scenario. So 0 plus I am getting 3 by 4, at t by 2 plus I am getting minus 1 by 4. That means it is not half wave symmetry. If it is not half wave symmetry, what does that mean? So this statement would be wrong, that I know. Sir, what all frequency component would be present, that I don't know, but this particular statement would be wrong for sure, that I am pretty sure. Say yes or no. Now if I need to find out the components, then what I can do? What I can do? What will be your yt? Yt is nothing but xt convolution with the impulse train. Convolution with the impulse train. Impulse train. Do you know what will be? And one thing also you know, that convolution in time domain will result in multiplication in frequency domain. Let's just say this impulse train. What will be the Fourier transform of this impulse train? Do you know? Magnitude of 1. So magnitude will become 1 by t naught, or you can write it down as f naught. What is f naught? F naught is nothing but 1 by t naught. So magnitude would become 1 by t naught, and it will be a impulse train only. The Fourier transform or the frequency spectrum of impulse train is impulse train only. Just the magnitude will be divided by t naught, and the impulses will be there after every 1 by t naught, where n going from minus infinity to infinity. So what will be your y of f? Y of f is multiplied with this particular thing. What you will be getting? X of f. Yt is x of t convolution with this particular thing, right? Now convolution in time domain will result in multiplication in frequency domain. Now whatever the x of f you are getting, that will be multiplied with this particular thing. So what will be the answer? Can you tell what will be the answer? Basically impulses you will be getting, no? The answer would be f naught will be common. X of f multiplied with delta of f minus n f naught. What that would be? Summation n goes from minus infinity to infinity. Now x of f I can take inside, no? Because it is not having a limit of n. So if I am taking it inside, what it will become? X of f dot delta of f minus n f naught. Now I know the property of delta function. What is the property? That this particular thing could be put here, right? So what is the answer you are getting? Y of f is nothing but magnitude, although I don't care about it, summation n going from minus infinity to infinity, x of n f naught delta of n minus n f naught. Is that understandable to you? Now you can put the value of n1, 2, 3, 4 in that manner. Okay, so this will be your frequency spectrum. Now can I find out? First let's find out x of f. Can I find out x of f? Sir, yes sir, I can find out x of omega. Looking at this particular graph, I can surely find out x of omega. What kind of graph it is? Triangular. And although all these things are not required, directly I can find out y of omega. Right, I will just simply pick one period. There I will find out its frequency spectrum, and in place of n I will put n omega naught t naught. My job would be done. I have taken a longer path. Like for this particular signal, how do you find out the frequency spectrum? Have I taught you? Yes, I have already taught. Pick one period. What you do? Find out the Fourier transform of that. In place of omega, you put n omega naught, and then simply divide by t naught. That would be your answer. Right? But although I have taken a longer way. So this is your triangular function. What is this triangular function? This triangular function is nothing but a tri t minus center upon width of one side, t by 4. So what will be its frequency spectrum? A2 sampling of omega 2 by 2. This will be its frequency spectrum. So t by 4 sampling of omega t by 8. So x of omega is coming out to be A2 sampling square, sorry. This will be sampling square because it is triangular, no? So sampling square would come. Okay, so sampling square omega t by 8. Right? Well and good. This is your x of omega. What will be your x of f? X of f will simply be t by 4 sampling square 2 pi f divided by 8. So this will become pi by 4. This will become pi by 4. This is your x of f you are getting. Now x of f you can put here. So what you will be getting? Summation n goes from minus infinity to infinity. X of n f naught. So what will be x of n f naught? T by 4. Sampling square. In place of f, you need to put n f naught. So what you will be getting? N pi f naught t divided by 4. What is the value of f naught t? What is the value of f naught t? F naught was nothing but 1 by t. So what is the value of f naught t? F naught into t is nothing but 1. So what you are getting? F naught summation n goes from minus infinity to infinity t by 4. Now this 1 f naught into t naught, that would also be, this t by 4 can go outside, f naught into t naught, that would be 1. So this is becoming 1 by 4. Sampling square, f naught t is already 1, n pi by 4. And surely here f of n minus f naught is also going on. F minus n f naught is also going on. There you go. Now you put the values of n. When n is equals to 4, this particular part would be 0. When n is equals to 8, this particular part would be 0. Because sampling square, what is sampling square? Sampling square x, that is sin x by x whole square. At x equals to 0, it will throw the value 1. At x equals to pi, it will throw the value 0. At x equals to 2 pi, it will throw the value 0. So if you put n equals to 4, it will throw the value 0. If I put n equals to 8, it will throw the value equals to 0. If I put n equals to 12, it will throw the value to be equals to 0. What does that mean? That means these components, that means 4 f naught, 8 f naught, 12 f naught, they will not be present. Rest all will be present. So f naught would be present. Which all component will not be present? 4 f naught, 8 f naught, 12 f naught, 16 f naught, and so on. What does that mean? Multiple of 4 f naught will not be present. Okay, multiple of 4 f naught will not be present. Is that understandable to you? Except the DC value, because DC value will be surely present here. So that's the answer. Is that understandable or not? Okay, I hope I have done the calculation correctly. If there is some error of the calculation, you may ignore it, but I hope the calculation is fine. If I talk about the DC value here, DC value is not coming out to be correct, 1 by 4. Yeah, it is coming out to be correct only because DC value is 1 by 4 only. Yeah, so this calculation is correct. Basically, if you put n equals to 0 here, what it will throw? Sin square is, sampling square is 1. This will be delta f only. So DC value is coming out to be 1 by 4. Yes, sir. DC value was 1 by 4 only. So from this particular thing, you can get to know that 4 f naught, 8 f naught, 12 f naught, 6 f naught, 16 f naught, those are not present. That means even harmonics are absent. That is absolutely baseless, because even harmonics means 2 f naught will also not be present, but 2 f naught is present. If I put 2 here, then it would become sin pi by 2. That would be 1. So yeah, it would be present. Okay. Yeah, so that's the question. But you don't need to do all this analysis just to get the option 3, because here only you will get to know that it is not half-wave symmetry. It is not hidden half-wave symmetry. It is not half-wave symmetry. That means surely here even component would be present. Okay then. So let's go to the next one.
In the given circuit, calculate the average power dissipated across the 1 ohm resistor. What is the average power dissipated? Basically, I have to find out the how can I check the average power? I will calculate the RMS value of current across the resistor, and I will multiply by RMS square. R is 1, so it would be simply IRMS whole square. So I have to find out the RMS value of current across the resistor. That is very simple, right? So here, right, I can convert this. Let's assume that sin t to be my phasor, reference phasor. So this will be 2 angle 0 amperes of current in this direction, downward direction. Okay, and here this current would be 2 angle of plus 90, right? Because cos always, this is my cos, this is my sine, right? So cos always leads the sine by 90. So this will be plus 90, or I can write this as plus 2j ampere of current. So what will be the current through the resistor? This will be let's say plus 2j equals to I through the resistor plus 2 through the other current source basically. So your I would be minus 2 plus j2. Okay, so what is the magnitude of I, because I am concerned about only the RMS. Okay, now remember here, right, this is the peak value. This phasor is the peak value because I have only mentioned the peak. So here if I calculate the magnitude, this will be 2 root 2, right? I don't care about the angle because I'm only concerned about the like value magnitude. This is the peak, right? So what will be the IRMS? Because remember my phasor representation, this was peak, that's why this was peak, right? So RMS because for power I need RMS, so this would be 2, right? I have to divide by root 2, that will give me the RMS value. So this will be 2 whole square, that would be equals to basically 4. So your power would be 4 watts. For the circuit shown below, the power factor observed by the voltage source is X, then 100x would be equals to what? Okay, so they are simply asking me what is the power factor observed by the voltage source. Yeah, so I see this is a resistive network through which a 4 amperes of current is flowing. So I can simply convert this resistive network into a single R. I don't know what is the R value, but certainly 4 amperes of current is flowing through this, right? And from here through this 2 amperes of current is flowing. Okay, I don't know what is the phase, but certainly they will not be of the same phase. Why? Because of course they are in parallel, right? If they are in parallel, the voltage here is same. So let's assume that voltage here is V angle 0. If the voltage here is V angle 0, so this current will be in same phase with this voltage, but this current will be leading from this voltage. So this current actually, the magnitude of the current is given, it is actually 2 angle plus 90. Okay, that is the current over here. So what is the power factor observed by the 10 volt voltage source? Okay, okay, uh, okay, and this is J. So can you comment? Okay, do you know what is the voltage here? Magnitude of the voltage? Certainly yes, right? The magnitude of the voltage will be this 2 into J, magnitude of this J. So 2 into minus J would give me the magnitude of the voltage across the resistor, that is 2. And I certainly know the current across the resistor, that is 4. So certainly the resistance value would be 0.5 voltage upon current, right? So I can convert this circuit essentially to this one. I can have minus J over here, I can have 0.5 ohms over here, and here I have J 0.4. Now what we will do is we will, like, I will obviously solve for this. Okay, we'll come back to this part. Let me first solve this part. Okay, so if I solve for this part, what is the equivalent circuit here? This will be equals to minus J into 0.5. I'm just solving this parallel branch, divide by 0.5 minus J, that is equals to uh, this would be minus J divided by 2, that is 1 minus 2J, right? Yes, so if I multiply by 1 plus J2, this will be 5. Basically this will be minus 0.2 minus J 0.4. So this whole thing, right, is a combination of minus 0.2 minus J 0.4, and if I add these two values, ultimately the addition is coming out to a minus 0.2. Okay, is that correct? Hold on a second. Yeah, negative sign is there. So oh, sorry, this is not minus 1, right? This is J as well, right? Oh, sorry, hold on a second. uh, J is there, divided by 2 on both sides, minus 2J, 1 plus 2J. Yes. Okay, sorry, this will be minus J 0.2, this will be plus J 0.4 plus 0.4. Okay, I think there is some typing mistake because these two values are supposed to cancel each other. Okay, I'm sorry. So there is, seems to be some typing mistake. This R is 0.5, this is 4 ampere, sorry, this is 2 volts, right? 2 upon 4 is 0.5, so 0.5 is here, into 0.5 minus J divided by 0.5 minus J. If I multiply by 2 on both sides, this will be 1 minus 2J. J minus J minus 2, just minus J minus 2. Okay, there is a bit of oversight here. This actually should have been J.2. Okay, this will change because Otherwise this question will go very lengthy. Just bit of typo in the question. This should have been j.2. I will change this in the question. So yeah, if this is j.2, what will happen? Essentially this thing will be cancelled, right? j.2, this part and this part will be cancelled, and if this part is cancelled, so what you're left with is this whole combination is only j.4. This whole combination is not j.4, sorry, only 0.4 ohms, right? And essentially here also you have a resistive network, so the power factor would be simply 1. Okay, that will be the power factor, that is 1 unity, because resistive network the power factor is 1. 100 into 1 would be 100. Okay, just a bit of typo here, this should have been 0.2. So your answer would be 100 for this question.
Yeah, so there is a system which is having an input of xt and impulse response is also given and output is yt, right? So what will be your output yt? Sir, output yt would be nothing but xt convolved with ht. So xt convolved with, what is ht? Delta of t plus 1 plus delta of t minus 1. So what is your output yt? X of t plus 1 plus x of t minus 1. That is your output yt. Okay, this is your output yt. X of t plus 1 plus x of t minus 1. So can you draw the waveform of x of t plus 1 and x of t minus 1? Yes, sir. And then you simply need to add it up. So what will be the waveform of x of t plus 1? What will be the waveform of x of t minus 1? X of t plus 1. X of t plus 1. X of t plus 1 means it will be shifted backward. So it will be there between -3 to 1. -3 to 1. And here you will have the peak value. अरे यार, -3 to 1. So peak value will be there at -1, no? Peak value will be there at -1. So this value is 6. And peak value will be there at +1 here. So this goes from -1 to 3 and peak value will be 6 here, but that would be occurring at, peak value will be 6 here, that would be occurring at +1. So you need to add both of them. You need to add both of them. That means between -3 to -1 this particular graph is there, but between -3 to -1 there is nothing. So what will happen? The graph will be followed between -3 to -1. So if I draw the graph, like here it is non-zero till -3, here it is non-zero till 1, non-zero till -1 and non-zero till 3. So the graph will be made between -3 to 3, and something is going to happen at -1 and +1 because nature is changing. Okay, so starting like this is how the graph should go, and then between -1 to 1, here there is a decreasing slope of -3, here there is an increasing slope of +3. I told you same slope will become 0. What will be the value? Value you can check at any point. At -1 it is throwing value 1, sorry, at -1 it is throwing value 6, here it is throwing value 0. At 1 this is throwing value 0, it is throwing value 6. So both values will be added, 6 and 6. So here you will have 6 value, here also you will have 6 value. So this value will be 6. And then similar kind of graph after 1 to 3, this will decrease down to 0. At any point you can check, at t equals to 0 you can check. This is the slope of decreasing -3. So what will be this value? This value will be 3. What will be this value? This value will also be 3. So at 0 if I check the value, 3 plus 3, that would also be 6. So this will be the graph of yt. So within second you should be able to draw this particular graph. Okay, so this value will be nothing but 6. So what they are asking, slope of yt between -1 to 1, is it 0? Yes sir. Yt is triangular? No. Yt is trapezoidal? Yes. What is the energy of dyt by dt? So energy you need to find out. So energy of dyt by dt, can you draw the waveform of dyt by dt? Yes sir. What will be the waveform of dyt by dt? So simply I need to take the slope. What will be the slope? Between -3 to -1, the slope will be 6 by 2, 3. And then between 1 to 3, then between -1 to 1, slope will be 0. And then between 1 to 3, the slope will be -3. This will be 6 by 2, that would be 3. This would be -3. Between -3 to minus 1 between 1 to 3. Okay, so 9 into 2 plus 9 into 2. So what will be the energy? 36 joule. So 36 joule. 134. Very straightforward question. These kind of questions should be solved. If you are aiming for a decent rank as well, then also this kind of question should be solved in the examination hall. Let's go to the next one. Yeah, so here they are saying that x of t is having a Fourier transform of x of omega. Then you need to find out the value of x of 0. So first thing that would click to me that, sir, I can do this particular thing. That x of 0 is equals to, if you know this particular thing, that x of 0 is equals to nothing but the integration of xt dot dt. But integrating this particular graph, very difficult for me. Then what I would think, that xt is the convolution of two particular graphs, x1t convolution with x2t. This is the scenario. And you know that, sorry, not convolution, multiplication. You know that multiplication in time domain will result in convolution in the frequency domain. So if I find out x of omega, that would be x1 omega convolution with x2 of omega. But don't forget one more thing, outward 1 by 2 pi would also come. So can I write down xt in this manner? I know that, sir, it is getting a form of sin 80 by pi t. Sin 80 by pi t. We are getting this form. But here pi square into t square should come. But here pi into t square is given. In our analysis, pi square into t square is coming. That means I need to multiply with pi as well. So I need to find out the Fourier transform of this one. I need to find out the Fourier transform of this one. Then I need to convolve them and then multiply with pi and then divide by 2 pi. So effectively I need to divide by 1 by 2. Multiply with pi, find the Fourier transform of this one, that would be x1 of omega. Then find the Fourier transform of this one, then convolve both of them and then multiply with pi and divide by 2 pi. Multiply with pi, divide by 2 pi. That means effectively I need to divide by 1 by 2. Is that understandable to you? So can you find out their Fourier transforms? Very easy. And can you do the convolution as well? Yes, sir. Again, very easy. So sin 80 by pi t, it would be there between minus 1 to 1. And the next one would be there between 1 by 2 to, like this would be there between minus 1 by 2 to 1 by 2. x1 of omega, this is x2 of omega. Between minus 1 by 2 to 1 by 2. Both are having amplitude of sin 80 by pi t, sin 80 by pi t. Both are having the amplitude of 1, 1 only. So this is having amplitude of 1, this is having amplitude of 1. This is between minus 1 and 1. And I need to convolve both of them. So if I convolve both of them, what I will be getting? Lower limit added, higher limit added. What is the gap here? 1. Minimum gap is 1. So slope will be changing after a gap of 1. Slope will be changing after a gap of 1. What will be the slope? 1 into 1, slope has to be 1. Slope has to be 1. So this is the graph you will be getting. The slope has to be 1. What does that mean? This slope has to be 1. So this gap is 1. Right? So this value has to be 1 only. 1 by 1, then only the slope will be 1. No? So this value has to be 1. But it should be multiplied with pi and divided by 2 pi. It should be multiplied with pi and divided by 2 pi. So what value you will be getting? 1 by 2. So this value is nothing but 1 by 2. So what they are asking? X of 0. This is your x of omega that you have drawn. They are asking x of 0. So what is the value of x of 0 you are getting? So that is nothing but 1 by 2. So answer is 0.5. Okay. So answer is 0.5. Well and good. Again, straightforward. It might happen that it would take a bit of time in the calculation, but you should be able to do it. Let's go to the next one. Yeah, you need to find out the value of current I2. So this input current is given, that is 0.5 ampere, and op-amp is having non-ideal gain of 3. So if this node is V, what this node will be? Minus 3V. Say yes or no? Because this node is V, this node is 0. So 0 minus V multiply with 3 will be equals to V naught. So V naught would come out to be minus 3V. So can I apply nodal at V? Yes, sir. V minus of 3V, that would become plus 3V divided by 4. This current I have written, outward current. Then this current also I can write down. What that would be? V minus 2 divided by 2. V minus 2 divided by 2. This current also I write down. And there is input current as well, that is 0.5 ampere. That should be equals to 0. From here I can get the value of V. So 1.5 V would be equals to 0.V. So V would be equals to 1 by 3. So value of V is coming out to be 1 by 3 volt. So what will be the value of current I2? I2 will be 2 minus 1 by 3 divided by 2. So that would be 5 by 6. So 5 by 6 would be what? 0.8 something. Right? 0.8333. Okay, so that's the answer. 0.833. Well and good. Let's go to the next one. Again, for which value of beta transistor will be in the saturation? Sorry, transistor will be in the active region. Okay, so this is your transistor. Current is flowing from P to and P to N. So this will be NPN. This is your emitter junction. This is your collector junction, and this is your emitter junction, right? P is at 5 volt. Now VB value would be given. Okay, VB value I forgot to mention. Should have been mentioned, no? So I will mention it. VB is 0.7. Okay, here it is not mentioned. So VB is 0.7. So what does that mean? What will be this potential? This potential will be 4.3. So P is connected to positive, N is connected to less positive. What does that mean? It is in forward bias. You want it to be in active region. That means you want it to be reverse bias. That means you want this node. Let's just say this node is, let's call this node as VA and this node as VB. So you would want VA to be greater than 5 volt. This is your target. That's it. Okay. So will you be able to achieve it? So this is 5. This is 0.7. So this will be 0.3. So if it is 0.3, then this will drive a current of 1 milliampere. If this is driving a current of 1 milliampere, then how much current this would drive? This is the emitter current, this is the collector current. So this will drive beta upon beta plus 1 into 1 milliampere. Right? So how much will be the drop? So into 1 milliampere multiply with 2 kilo ohm. So drop will be beta upon beta plus 1 into 2. So what will be the VA potential? VA potential will come out to be 10 minus 2 beta upon beta plus 1. That would be VA, should be greater than 5 volt. So 2 beta upon beta plus 1 should be less than 5 volt. What does that mean? 2 beta should be less than 5 beta plus 5. Isn't it always necessary? Now here it will go 3 beta. So beta value should be greater than minus 5 by 3, which is pretty obvious. Beta will always be greater than minus 5 by 3. Right? Beta will always be greater than minus 5 by 3 because beta has to be positive. That means for all the options it is correct. There you go. Okay. So just that I need to mention that VB value should be 0.7. I will modify the question and then all 4 options are correct. Okay. Very straightforward it was. What did you do here? So two networks in between, say there is some resistance. Always put I2 equals to 0. If you do this thing, that means your concepts are not clear. Okay. Always go by the current. What I would say is that this can drive some current. This can also drive some current. If this 6 volt is driving some current, let's just say this is I current, then here also there will be I current. Here also there will be I current. There is no doubt about it. Here also there will be I current. But now at this node, I current is also coming and I2 current is also coming. Now I cannot command that what will be the current here. But I can also say that this current is I and this current would also be I. So from this node to this particular node, till this point I can say the current would be I. Right? But rest of the things I don't know. Here, let's just say this current is I1, I2 is already given, I3. So this current would also be I3. But at this node, two currents are there. I2 is also there and I3 is also coming from here. Then I will not comment here. But I can also say that this current is also I3. Say yes or no. Right? What about the potentials? I know that, sir, this potential is 0. This potential will be 4 for sure. I don't know the potential here. This potential is 0. I don't know the potential here. This potential is also surely 0. If this is 0, this will be surely 6. Now you notice one thing. Very good thing you can always, if this kind of question is coming, always see the current and potential. Whatever the comments you can make, those comments you make. And only the current that you will assume, those will be from the batteries. That's it. Now what comment I can see? This is 6, 2 ohm and 4 ohm. So 2 ohm and 4 ohm are in series. Right? Both are having the same current. No, this current is I, this current is also I. And they are divided into, this is your 6 potential and this potential is 0. This is 2 ohm and this current is 4 ohm. Sorry, this resistance is 4 ohm. So 6 volt between 6 ohm. That means this will drive here 1 ampere current. So what did you understand? That this current came out to be 1 ampere. What really happened here was that, sir, I can remove all these things now. One good thing I got to know that these currents are 1 ampere. This much current is 1 ampere. Well and good. Now here there is a ground. Here there is a ground. I know this potential. I don't know this potential. Let's just say this potential is V. What is my target? My target is to find out this I2. Right. So what I can do is that V divided by 1 ohm plus V divided by 2 ohm plus V minus 4 divided by 2 ohm. that would be equals to 0. I just applied the nodal analysis here. V minus 0, V minus 0 divided by 2, V minus 0 divided by 1, V minus 4 divided by 2. So what I am getting? V equals to 2 volt. Not 2 volt. 2V equals to 2, that means V equals to 1 volt I am getting. So this potential has come out to be 1 volt. If this potential is 1 volt, this potential is 0, what does that mean? How much current would be flowing here? 1 ampere current would be flowing here. So what did you understand now? That sir, 1 ampere current was here and 1 ampere current is coming from here as well. This is your 1 ampere current. So how much total current will be flowing here? That would be 2 ampere. Now I know that sir, I don't know the current going downward, but I know the current going here. Because if this current is 1 ampere, this current will also be 1 ampere, this current will also be 1 ampere. So this current will also be 1 ampere. So at this node, 2 ampere current is coming, but 1 ampere current is going out. What does that mean? This current would have been 1 ampere. There you go. So this ground is taking 1 ampere current. Now this ground and this ground both are same, no? Both are same. I could have asked you, what is this current going inside? That will also be 1 ampere only. 1 ampere current is going into this ground. You can check as well. How will you check? What you can see here is that, sir, I have got the value of this V, right? I have got the value of this V. Sir, this potential is 1 volt. This potential is 1 volt. This potential is 1 volt. This potential is 4 volt. So 4 minus 1, 3 by 2, that would be 1.5 ampere. So, sir, I know that, sir, this current is 1.5 ampere. Now here 1.5 ampere current is coming, but only 1 ampere current is going here. What does that mean? 0.5 would have been going here. Say yes or no? 1.5, 1 is going here, 0.5 would have gone here. This would also be 0.5, right? This would also be 0.5. And if this is 1.5 ampere, that means this current is also 1.5 ampere, this current is also 1.5 ampere, this current is also 1.5 ampere. So here the scenario is this current is 0.5 ampere and this current is 1.5 ampere. What does that mean? 0.5 coming here, 1.5 going here. That means from the ground, 1 ampere current would have come. So ground is taking 1 ampere current, it is providing that 1 ampere current as well. So is that analysis clear to you? In concept text as well, I have framed the question from here. In our test series as well, I have framed the question. In our class notes as well, there are questions. In the gate examination as well, from this concept question have been asked. When this question was asked, the answer was 0. Okay, so people, I have seen a lot of solutions. People have just made an assumption. What they do is that one network would be there, other network would be there. Whatever the current battery gives, it would take back the same current. Whatever the current battery would give, it would take back the same current. So here the current would be 0. This kind of concept people have made. But they don't even know that ground can also take into action. Ground can also make some decisions. Because if here there is a ground, then the ground can also take up some current, no? It is true that whatever the current battery would give, it would take back the same current. But is it necessary that in all those elements the current would be same? It is not necessary. Here the current was 1 ampere, but here the current is 2 ampere. In the whole network current is 1 ampere, no? 1 ampere, 1 ampere, 1 ampere, 1 ampere, 1 ampere, 1 ampere, then 2 ampere. Here, what is the scenario? 1.5, 1.5, 1.5, 1.5, 0.5, 0.5, 0.5, 0.5, then 1.5. Okay, so have some good knowledge and have some good concepts as well. Okay, let's go to the next one. Yeah, so consider the following circuit, sir. This was a very lengthy question, sir. Was it lengthy? Am I asking you some expression like find out the voltage expression at some time t? What is the value of voltage? No. That means I am expecting something intuitive from your side, right? So is it a LTI system? Yes. So what you could have thought, a lot of approaches are there. So first approach could have been that, sir, this is a LTI system. Now I know that, sir, if in place of RT, if UT was there, then it would have been easy for me. In place of ramp function, if you have applied step function, then it would have been very easy for me. So what you do, sir, if I know that, sir, if I apply UT, I know a particular output. So what will be the output if you apply RT? That would be simply the integration of this output. That would be, integration of this output, because you know that if you integrate this UT, then what you get? RT. So whatever the output that you are getting, you integrate that output will be here. So can you directly write down the output V naught T if input is step? What will be the initial value? At 0 plus. So initially capacitors are having 0 voltage, but the whole circuit is shorted. If the whole circuit is shorted, that means, sir, there will be an impulsive current. If there is an impulsive current, then what would happen? Voltage will be simply divided. So if I am saying I am applying UT, then here voltage would come, that would be 0.5. At the steady state, what would happen? Both capacitors would be open circuited, so whole voltage would come up. So what will be the expression? 1 minus 0.5 5 e to the power minus t by 2. This will be the expression. Surely there will be ut as well, right? Then you simply integrate it. Now you don't need to integrate, just think about it. If I integrate, surely there will be a ramp function, no? Surely there will be a ramp function. And surely there will be some transient response as well. Because if you are integrating e to the power minus t by tau ut, some component of transient would also come up, and here purely ut is also there. What does that mean? Some component of a ramp would also come up. So from here only you can think that, sir, ramp and transient both would be there. So what is the first option saying? Contains only transient? No. Purely ramp? No. That means it will have both transient component and ramp component, and it will never settle down to a steady state value. Why is that so? Because ramp will never settle down to a steady state value, no? Ramp will always keep on increasing. So it will never settle down to a constant steady state value. So this option is correct. At 15-second, ramp component will dominate. What is the time constant of this circuit? Sir, 2 RC. RC value is 1 second. What does that mean? Time constant is 2 seconds. After 5 to time, that means after 10 seconds, who will die out? Transient component will die out. So at 10 seconds, after 10 seconds, transient component will die out. So who will remain? Only the ramp component will remain. So what I am saying is that at 15 seconds, ramp component of V0 will be dominating the transient component. Yes. Or how one could have thought that, sir, at t equals to 0, it will have 0 voltage. But sir, at t equals to infinity, capacitor ideally should be open circuited. Like, what is the meaning of steady state? Steady state means capacitor will not be changing the current. Capacitor will not be changing the voltage. If they are not changing the current, then surely voltage will also not change. Right? This is the meaning of steady state. Right? What does that mean? Voltage should not be changing. Sorry. What is the meaning of steady state? The meaning of steady state is the voltage should not be changing. That means current has to be 0. So you can consider it as open circuit. If I consider this as open circuit and this as open circuit, then what will be the circuit? The circuit would be somewhat like this. This is resistance R. This is also grounded. This will be V0. So circuit is saying that complete input is exposed to V0T. That means at the steady state, V0T roughly you can write down as RT. At steady state, your V0T is roughly equals to RT only. That means as a steady state, only this component will be dominating. Right? That means this option will be surely correct. That you would see that time constant is 10 seconds. That means this option will be surely correct. Now you know that I am applying a ramp. The input will be gradually increasing. That means capacitor will be gradually increasing its voltage. So surely some transient would come up, no? That's pretty obvious. It's not that, sir, just as I apply the input, directly the ramp signal will come up. At the steady state, it will be RT. So surely there has to be some transient that is dying out. So then this option would also be correct. That it will have both transient and ramp, and at the steady state, transient would die out and ramp would remain. Okay, so you don't need to apply Laplace transform and all these kind of things. I am not asking the V0 expression. I was just testing that how much do you know about transient. Okay, so that's it. Let's go to the next one.
The rate of change of phi x, y, z equals to in the direction normal to its surface at the point this equals to what? So they are asking me the rate of change in this direction, in the direction of normal to this surface. Okay, so how do I calculate the rate of change? So basically they should have mentioned the maximum rate of change, because directional derivative gives me the maximum rate of change. Basically they are asking me the maximum rate of change, right, of phi along the normal of the surface. So what is my surface? How do I calculate the normals to a surface? So if I just find out the gradient of my surface, right, that will give me the normal vector of my surface. Okay, what is the gradient of this? Gradient of this would be 2xy plus y square, this is 0, into I cap plus into I cap plus this would be x square plus 2xy plus z square, okay, into j cap, then plus this would be 2zy into k cap. Okay, this is what my normal vector is equals to. right? Now I have to find out the unit vector, right? This is just the normal. I have to make it unit vector. So at point 1 comma 1 comma 1, so 1 comma 1 comma 1, if I put 1 comma 1 comma 1, this will be basically 3i plus this would be 4j plus 2k cap. Okay, 1 comma 1 comma 1. So the unit vector, right, unit normal vector would be simply 3 square plus 4 square plus 2 square. So that is 9 plus 16, 25 plus 2, that is 29. So this will be 3i cap plus 4j cap plus 2k cap upon under root of 29. Okay, that is my an cap vector. And like basically they're asking me the maximum rate of change, right? So I have to find out the directional derivative, right? That would be basically the dot product of my basically I have to do grad of phi and then take the dot product with my normal vector. That is my directional derivative. I hope you remember these things, right? So yeah, what is grad of phi? Grad of phi would be, this will be yx yz. So let me first of all calculate grad of phi. Yz I cap plus yz I cap plus x yz I cap plus xz j cap yz I cap plus xz j cap, right? Yz, yeah, yz I cap plus xz j cap plus xy k cap. So this will be basically I comma I plus I cap plus j cap plus k cap. That's it, right? So this will be my grad of phi I cap plus j cap plus k cap. This I will do dot with 3i plus 4j plus 2k upon root 29. So this will be equals to 3 plus 4 plus 2 upon root 29. So in the options, yeah, this will be 9 upon root 29, that is present in option B. So option B will be your correct answer for this particular question. If there are 5 people in a row, what is the probability that no 2 of them have the same birthday? Okay, so if 5 people are there, what is the probability no 2 of them have the same birthday, right? So if I assume that, let's say the birthday of one of the people is on the date X, right? Let's say 19th of October or whatever. Then the birthday of the other person, right, cannot lie in this, right? So how many choices I had to choose for the birthday of person X? 365. Right? I have in a year, like assuming normal year, right? I have 365 choices, the 365 dates to choose from for the first person. The birthday can be any 365. As soon as I have chosen a date for the person 1, for the person 2, the number of dates are 364, because let's say I have chosen 19th of October for the first person. For the second person, I cannot choose 19th of October because they have told me that no 2 of them have the same birthday. So that's why I will have one less number of days. Again, for the third person, I will have 363 days. For the fourth person, I will have 362, and for the finally for the fifth person, I will have 361 days. So these are my number of days with which I can choose the birthdays, right? So if I did not had any condition, then in how many ways? So this will be multiplied, right? Because person 1 has a birthday, then I will choose the birthday for the person 2, then I will choose the birthday for the person 3, then I will choose the birthday for the person 4, and finally the person 5. Okay, now if let's say I did not had any condition, so what is how many what are the total number of ways that person 1 can have birthday? There are totals 365 days. So any day can be birthday for the person 1. Again, there are 365 days for the person 2. Any day can be birthday. There is no condition. Previously, if I had chosen 19th of October, I cannot choose 19th of October again. But here, if person 1 has birthday 19th of October, no problem. Person 2 can also have 19th of October. Basically, I am calculating the total samples upon the favorable. These are my favorable samples. I am computing the total samples. So for person 3 also 365, person 4 also 365, person 5 also 365. So overall, your answer would be this 365, all this multiplied 365 into 364 into 363 into 362 into 361 upon 365 raised to the power of 5. Okay, so if I solve this, right, you will see that this will be cancelled automatically, and this I can write 365 minus 1, which is this value, divided by 365 with this value. Again, this will be 365 minus 2, which is this value, upon 365. Again, this one and this one. So option D will be your correct answer for this question. So those were all the video solutions. I hope you have like enjoyed this whole exam. It's like not just an exam. If you feel the questions were at that level, you must have felt that whenever you attempt any paper at PrepFusion, or whenever you see any video in PrepFusion, right, you know the quality is at the highest. We try to keep the paper difficulty obviously on the easier side, because the name obviously suggests BoosterX. I hope you have enjoyed this, and again we'll come live at 6:30 p.m. Make sure you join there and you can see all the analysis, right? Make sure in this window you do your own analysis, and then you join at 6:30 p.m. and then see like where do you stand, what shall be the safe marks. All those things will be discussed in the live session today evening. So I hope you have enjoyed this whole solutions. I will see you in the next video. Until then, happy learning.